Hello, hello, hello. The time has come. Finally. I mean, could have done this earlier, but, welcome to Void Star Lab, where, oh crap, I forgot to take the sticker off here. We've got a lot of stuff coming into the lab, and, well, I'm really excited about today's episode. Welcome, everybody. I'm gonna have a little Pop-Tart action as we go. Yeah, welcome to the stream. Today's gonna be an interesting one because it's we're doing it in a way I've never really done before. So usually, like, we have a project, right? See, it says project right over there. It's not really accurate today because we're not really doing a project. We are more well. I kind of have a lot of filaments, and I realized that I have to start using them. So, a while ago we built where's the button? Here it is. A while ago we built this printer, the E3D tool changer. Quick refresher, the tool changer is, oh hey, I forgot to flip this light on. There we go, that's better. The tool changer is it's a 3D printer with different detachable extruders. Like, this thing has 4 extruders on it. It can actually pick them up one by one and use them. So the reason why we built this is because, well, spoiler alert, but in a few weeks we're going to be doing the sequel to the Every Filament video. And, well, there are a lot of filaments that my Prussias and stuff can't handle. That's what this is for. So, today, well, we're actually going to use it, right? So it's this is pretty exciting stuff. This is a different type of stream than anything we've done before. It's likely that a lot of stuff is going to fail. We're going to have to be quite organized in order to do this properly. But I think if we do manage to pull it off, the payoff is going to be excellent. Let me just. I realize the font is going to be too small for anyone to see. Here, we can take a quick look. These are all of the filaments that I think I got for this episode. Look at all these. There are tons of filaments. In fact, I think there are exactly 69 filaments. We got all kinds of crazy stuff. Like, we have everything from PET made from recycled soda bottles to, oh, what's that? Ugh, that's weird. Yeah, to, like, Stratasys super proprietary support material that we're going to have fun trying to get out of its packaging. To, I mean, this one's made with pine. It's going to make the place smell like Christmas. Yeah, there's all kinds of crazy stuff. Yeah, these filaments have come in from all over the place. We've ordered filaments in from Europe, from New York City, I think there's even one from Australia. Yeah, it's gonna be neat. Hopefully, a lot of them work. I didn't have a lot of time. I only had time to throw one in the dryer, so we'll try to dry a few more. Let's show you the 3D printer set. I'll show you the 3D printing room setup here. So as you can see, actually, now that I realize it, well, before we get too deep into it, we have a couple of things to do. First, let's shout out Akelia. Thank you so much, one of our most regular supporters. Welcome to the show, and thank you very much for the super chat. Akelia says, live stream hype. Shout out to Brooke. No, that's not how this works at all. Also, my own name just seems to have scrolled by there. I think I might have sponsored myself, unless it said my brother. I know my brother is a patron. Yeah, Ablative Kitten, thank you so much for the super chat. Build me a device that destroys terrible printers. When all you have is a hammer, you better find yourself some nails. Honestly, I think Gravity does a pretty good job of that. You could take the opportunity to make a flying printer, right? You take the opportunity to make a flying printer. Anything will fly if you throw it fast enough. Akelia, thank you so much for another super chat. It's so generous of you. Shout out to Zack too. Thank you so much. I think folks are starting to discover the bot. That's right. We finally listened to what you folks had to say. I know, big mistake, and got ourselves a bot. We have equipped the server with Nightbot, and yeah, we've equipped the server with Nightbot, and you can see the commands there in the corner, and you just type those into chat, and it'll send links to, give links to things. Let's see, from the top to the bottom, we've got, you can say Discord to get a link to the Discord. You can click Mailbox to get our mailing address, so you can send us crap. We'll talk about that in just 1 second, because it's relevant. You can hit projects to have it tell you what project we're working on. I don't know why you would need that one, because it says they're right on the screen at all times. And, but yet people still multiple times per stream ask me what project we're working on, which is, I don't know what the circumstances are in which you're reading chat, but you can't actually look at the stream, but, it's there. You can type socials to have it say, what our social media address is. Subscribe to remind everyone else to subscribe, and of course, finally, things to see whether this episode is sponsored by things. This one's not. Yeah, they are. Yeah. One thing at a time, Techniac. He wants me to show the shirt. I'll show you the shirt. Just give me a sec. These are all rate limited, so they'll only respond once every I think 30 seconds ish. So, yeah, there you go. Unfortunately, Liam, the bot is not capable of getting you a girlfriend. I think the bot identifies male, so can't handle it personally. What's going on here? So yeah, some of the let's see. Yes, so it's doing a bunch of stuff here. For one, it seems like people are trying to spam the bot. It's rate limiting. So tell you what, I will just on one hand, I rate limited it more aggressively so it would be less annoying. But if people really want to mess with the bot, then there we go. I'm going to drop the rate limits back down to 5 seconds, and I'm sure everyone will be able to have great conversations. The bot will actually start limiting itself, I think, if it's talking too much. It's also doing some moderation. By the way, there we go. That'll work fine. So it's actually also doing some moderation. So you can no longer spam all caps. You can no longer say the same message. If you say the same message 5 times in a row, no matter how long you're on the stream for, it'll kick you out. The bot will not block itself, Josh McEachern, if it starts spamming. No, it doesn't work on moderators. So, Techniac, Brooke, please don't abuse your privilege. Talon, if you're here, come on, but be an example to the community. Yeah, basically, it's if you had an idea of posting the same thing over and over again to try to get our attention, at least have the decency to edit it each time. But yes, so yeah, there we go. It's now going to so now we have a bot that's going to ruin chat and break up everyone's conversations. It's going to be great. I've also a number of other things going on here. I have also hidden the analytics. I hid the analytics. I can't look at it during stream anymore. Hopefully that makes me less stressed, because holy crap, just being able to see how many people are watching the stream and see that number drop the moment I do something wrong, does that ever stress me out? So, speaking of the... Oh, hey, Roy Kazitsky, thank you so much for the super chat. Hey, just got an Arduino R3 form Elegoo for projects. An Uno R3 form Elegoo. Huh? What? An Uno R3... Does Elegoo make Arduinos? Do they really? Huh, yeah, I guess they do. I didn't even realize that. I thought they just made 3D printers. Yeah, they make little robots and kits and stuff. Huh, isn't that neat? Today, I learned. So, speaking of the mailbox, yeah, I've got some really cool stuff in the mailbox lately. So first, check out the shirt. Yeah, check that out. is that I think Reagan from a regular on chat, or a regular on stream, and on our and a longtime patron is. Oh, are we starting to lag? That's one of the downsides. I can't see. Oh, hang on a sec. Oh, looks like we're working fine. I do see some lag. Yeah, one of the problems here is I can't. Looks like YouTube is having trouble. Yeah, unfortunately. Yeah, we're using ultra low latency mode, so I've never used. This is an experiment. We'll see how that plays out. Why can't we change this? Is that working? Are we good? Are we good? How we doing? How we doing? Are we fine? I think somehow. All right. There are a couple things going on here. I think. Yeah, sorry about the lag. We're using ultra low latency mode. I'm giving that a shot because I spend a lot of time responding to chat, and we also do occasionally bring people on. We're not bringing anyone on today, but it will happen very soon. So yeah, we're trying out ultra low latency, and perhaps that changes things. It also seems to have kicked me off of secure. I have a secure. I use RTMPS, the secure streaming protocol, but it seems to have kicked me off back to unsecured, and that caused us to start losing frames. So that's. I don't know how the hell I could have done that, considering that I didn't even have that thing in view, but yeah, there you go. Anyways, we're good. Everything's fine. Everything is fine. There's nothing to be stressed about at all. Alright, the shirt. That's right. Yeah, so Reagan, one of our regulars, got me this awesome Quagsire shirt. So thank you a lot, Reagan. And Trucku, one of our another member of our community on Discord, sent me an awesome care package that includes some really cool stuff. And the first thing is he included a Mio, as you're all aware. I'll explain why I'm always drinking Mio in a sec. But yeah, he sent me one that I've never seen before. This is Strawberry Pineapple Smash Mio. Strawberry Pineapple Smash. So yeah, let's get some pineapples. This is. Well, first up, Trucker, thank you so much for sending me all the awesome stuff. If we're not receiving enough stuff yet to do a full mailbag episode, but I still stuff that you send will often get used. Eventually, we'll start doing full-on mailbag episodes. But thank you so much. We're going to be checking some other stuff he sent out soon. But yeah, pineapples are really significant to Brooke and I because they figured into are meeting up. So in the game Ingress, a pineapple. This is not the color I expected this to be. A pineapple is sort of a way to troll someone. It's basically in Ingress. It's sort of like Pokemon Go, like you play in the real world, and a pineapple is basically when you. So in Ingress, you have the ability to when you can conquer territory, but you can also give it to enemies. There are items that immediately switch a portal over to your side or the enemy side, and so that means you can give the enemy assets. Why does it? What the hell do you do with this? Well, you set up a portal in the least defensible, least valuable, most obnoxious way, which is to say that you deploy the resonators, the things that have to be destroyed to take control of it, as close as possible to it, and you load it up with the worst items, with the worst mods. That means that it ends up looking like a pineapple, because it's all spiky and it has stuff coming out of the top. Anyways, thank you so much for the Mio, and we'll get to the other thing for a sec. I don't plan on talking with my mouth full for most of the stream. As you'll see in a sec, a lot of stuff has changed. So I've been, I was started a little behind the 8 ball because I had a lot of stuff to take care of before this started. It's actually really good. All right. Ablative Kitten, thank you so much for the very generous super chat. I really, really appreciate it. How's your day anyway then, Zackerman? I found some ducks today, and even a swan. Got a model kit too, and I'm bribing you for lab assistant with plushies at some point. Just gotta remember the P.O. box. Thank you so much. I really appreciate the super chat. The Blade of Kitten is a very active member on our Discord, and I really appreciate the support. So, yeah, without further ado, let's see if I can turn this thing on. Yeah. Oh, there we go. Worked fine. Awesome. So what's up with the Mio? Well, usually I have coffee or tea. I'm kind of a snob that way. But I always end up waking up only a few minutes before the stream starts because there's a lot of stuff to prepare the night before, so I'm up late. It means I wake up late, and I have to, sometimes I'll only have like a few minutes to prepare everything. So usually I have coffee or tea, but I don't have time to let tea brew for like 5 minutes or, do the 56 steps required to make coffee with an AeroPress. So that's what the Mio is for. The Mio is pretty much just for streams. So that's why I'm always drinking Mio. Michael Pass says, Mr. Freedman, I wanted to thank you for your hard work. You give us hardworking NYC people a good name. Unfortunately, I'm now playing for Team Colorado. Or I'm playing for Team Denver. So, unfortunately, you're stuck with Louis Rossman. I know. We gotta work with what we got. Stingray Master, thank you so much for the $2. The stream is not sponsored by Mio, says Brooke. No, the stream isn't sponsored by anyone. Believe it or not, we do run streams that aren't sponsored. We do run an occasional video. We haven't had one of those in a while, though. I've been pretty lucky. Anyways, you didn't come here to see me like rant about Mio and eat Pop-Tarts. You came here to see some stuff, particularly filaments. So let's turn our attention over here. Let's actually switch the lights on our new printer. Boop, boop. I was trying to figure out a way to get that display to stay on, to turn on automatically when I approach. And I realized that the reason why I was turning off is because to prevent screen burn-in. But I realized I never actually researched if LCDs have burn-in, and I realized how silly that sounds. But it's an untested assumption. I was just assuming that. LCDs had burn-in, because, plasma screens have burn-in, CRTs have burn-in. Yeah, they all burn-in. Alright, the LCD screens don't burn in anymore? Did you know that? That, LCD screen burn-in hasn't been a thing for, 15 years. It doesn't happen anymore. I can leave this thing on full brightness forever. And yeah, over time the backlight starts to wear out, and over time the screen can become less responsive. But LCDs don't burn in anymore. Sure, every once in a while you'll turn it off and you'll see, it'll look like it's burned in. But all you gotta do is wait a day. Even if it's the screen's been on for years, you wait 1 day. And it goes away as soon as you turn it on a second time. It's crazy. Juan Rodriguez, thank you so much for the very generous super chat. Pardon, I finally finished building my Chromance. Thanks a ton for putting detailed instructions and build material onto Zuki. It was a very fun learning experience. Thank you so much. Thank you so much. I try really hard on that one. I don't think it's as good as I don't think the instructions are as good as I could have got it. The way the strips are connected is a little weird too. But I think it was a pretty good attempt. Some folks are saying that phones and Ultimaker and LCDs. All right, the character LCDs are different. They're using an older technology that is prone to burn-in. But the IPS and I think the ST the in-plane switching. I think basically the LCDs, the liquid crystal technology used in modern displays is not prone to burn-in. The old ones did. So don't follow this advice for character LCDs or something. But yeah, a screen, you can just leave an LCD monitor on forever. It has no ill effects at all. It's pretty crazy. OLEDs don't really get burn-in. They get burn out. Yeah, you don't want to leave an. I don't think you want to leave an OLED on forever. Although, don't quote me on this either. I haven't looked because I think I heard somewhere. I'm not 100% on this. I think that that AMOLEDs, because of how they're refreshed, or like, yeah, they will burn in, but it has to be like months on end. Yeah, it's pretty crazy. Oh, it seems like our bot is doing work. So the way this thing works is the first time you mess up, it'll mute you for 5 seconds. Then it'll then after a few times it will kick you for 10 minutes, and then it'll permanently blacklist you. So you're not just getting thrown out. You can run like bang or exclamation point commands to see what it does. So yeah, here's why I switched over to this. Because I've done a bunch of renovations and reorganization on the workshop. Yeah, we always seem to have problems with when we stream outside the workbench. So I've given a little attention to the rest of the shop. So now we've got a shelf up here with all our stuff. You see that? See our overhead camera? It's now attached to a shelf on the wall instead of to the parts cart thing. So we shouldn't like be sending it wobbling every time I accidentally kick the parts cart. So yeah, over here in front of the window, I set up another desk, and this has our laser cutter. Remember that? We got room under here. See that fan? That's important. And I took the enclosure, the Boxmo enclosure, and I moved it out here. And that's because when we put the box fan in this window right here, I took the back panel. Here, check this out. I took the back panel out of the Boxmo enclosure. So, you see? Check that out. So when we put the box fan in the window, we'll be able to do resin stuff here safely and soundly, and that's going to come in handy because we are doing a bit of resin printing soonish. And yeah, we finally have the laser engraver set up. We're going to be able to engrave stuff with the laser. Oh, hey, there's a light in the way. Get that out of there. Let me show you what I did in here. Hopefully it's nice and clear on camera. Let's zoom in all the way. Zoom in all the way. Open up our aperture. All right. So check this out. Let's see if everything works. What? Why is it so dim in there? All right. So yeah, check this out. We've got our. We now have all three of our other printers set up in there. So we've got the Viper up there. I hooked that up to Octoprint. Haven't tested it yet. That's one of today's jobs. Let's see. And then under here, woo, we got the Squire of Squirt, and next to it is the Sultan of Squirt. And you see, here, check that out. I'm not sure if you can make that out right there, but I've got them all on. There we go. I've got them all on really heavy concrete paver stones on top of a carpet pad, and that the carpet pad isolates the vibration. The block provides a really stable surface, so this should improve print quality and make everything a lot quieter. The tool changer. Turning our attention back here. We're gonna have to drop our sensitivity again. The dynamic range of this camera is a little on the sus side. There we go. So yeah, you can see that this printer as well is resting on 4 concrete pavers, and that should both increase the quality and also reduce the amount of repairs the printer needs, and finally make it a little quieter. Yeah, you can also see right there is a tiny dehumidifier. When we print high temperature filaments, we're going to put that inside the printer enclosure. We're going to see if it works. We're going to put it inside the printer enclosure to raise the temperature in there, and also to keep any stray humidity from wrecking our filament. Because if you thought nylon was bad, wait until you see PEEK. So yeah, let's get our exposure dialed in right. Exposure, how does that look? That looks alright. Is that blown out? That's a little on the blown out side. Alright, works fine. So, yeah, that's what we're doing. So today we don't really have a project. The concrete hack. I didn't come up with that, by the way. That's from CNC Kitchen. A lot of the stuff that we might even do today, but a lot of stuff from this episode is either, when I say inspired by, but what I really mean is ripped off from CNC Kitchen and Maker's Muse. Yeah, I'm not really trying to push the envelope on 3D printing. I'm more trying to show you what other people have done. So, yeah, there are going to be a few techniques and things, including stuff like the blocks that I got from places like CNC Kitchen. Yeah. Cordy, pardon me for missing your super chat. I was running around the room. What are your thoughts on... Thank you so much for the very, very generous super chat. I really appreciate it. What are your thoughts on Mosaic's Palette 3 and Palette 3 Pro? Similar idea to the tool changer, except use one extruder for up to 8 filaments. These are interesting. So you have stuff like... So there's the palette, there's the MMU. So the way all these things work is, for anyone who's not familiar with them, it allows you to print multiple materials by basically feeding different plastics in through the same nozzle. It's pretty cool. There are really two things you can do with multi-materials, right? Okay, 3 things. The first is you can print multiple colors. Right, you print all PLA, but you just have a bunch of different PLA colors on tap, so you can, make certain details different colors. The second thing you can do is you can use a separate material for the supports and for the print itself. Right, so like you can use a dissolving filament like PVA. You can use an easy to snap filament. Like an easily detachable filament, like poly support. I have a number of them here, like or Spoolworks scaffold. And finally, you can keep a bunch of different materials and nozzle stuff on hand, so you don't have to swap them. You don't have to waste time swapping them. The palette and the MMU only solve one of those problems. They're good for when you want to print multiple colors, but they don't quite as they don't solve the third one at all, right? It's like, sure, I mean, the MMU kind of. The MMU makes it a bit easier to swap filaments, because it does it for you. But the palette doesn't. And I'll explain why in a sec. But neither of them works they're supposed to work well, but neither of them works very well if you're switching between a support filament and a structural filament. Because, first off, that means you have to use those two filaments that that have the same temperature profile. And when I mean the same, I mean the same. Because they're printing out of the same nozzle. You don't have time to wait for it to heat. First off, you don't have time to wait for it to heat up and cool down. The second is you can't purge it as easily. So if they're different temperatures, one won't be able to push the other out of the nozzle, or it'll burn it. Yeah. With something like the tool changer, because each material also has its own dedicated extruder, there are no restrictions like that. I can do stuff like print polycarbonate at 260 Celsius, supporting it on printing polycarbonate, supporting it on I forget the name of the material. Basically, there's a support material that detaches from it that melts at 240, and gives you options like that. So I think all right. Another neat thing: the difference between the palette and the MMU is that the palette actually splices the filament together before it drives it into the printer. It's really cool. It actually syncs up with the G code, and it cuts the filament at just the right place, so that the color transition happens during printing. You don't use much of a wipe tower. I'll explain. Don't worry about what a wipe tower is. The way the Prusa works is it actually retracts the filament, right, and it loads another filament in. So it's the palette is much faster, and it also the Palette Pro, yeah, it has like eight different colors. It's pretty cool. One thing it can't do. This is a big weakness of these systems. One thing it can't do. Neither of these are blend filaments. You can't print two filaments out of the same nozzle. That's not possible with our current nozzle technology. So, yeah, I don't know. I guess this is a really long, complicated way of saying that I don't really like we're gonna do some multi-material printing, but I think the value of it is in support filaments, not in multicolor. I don't. There are some niche uses for it, but on balance, I think it's smarter either to make the print in multiple pieces, which you glue or snap together, or to just color it after the fact. I think it makes it easier. What am I missing here? Anytime someone uses the Bing subscribe, it's flagging the chat in stream, and Bing mailbox is not being recognized. Well, I knew there would be some problems. Yeah, unfortunately, what is going on here? Why is it switching? There are a lot of problems going on here. Mailbox should be working. I don't know why subscribe is being so weird. I think too many people are using the. Let's see. Let's take a quick look at what's going on here. What's going on here? I may have configured this wrong. I did set this up at like 4 o'clock in the morning. So let's see, mailbox. This command. Oh wait, I got the alias wrong. I did it wrong. I thought the alias was. All right. Well, I seem to have made a bit of a mistake here in setting aliases. I thought the alias lets you use multiple keywords for the same command, but I was wrong. Apparently. I don't know why it's not letting me copy that. That's really weird. Bear with me one sec. If the command is supposed to call another command, specify the other command here. Oh, that's not what's supposed to happen. All right, all right. Let me set this up properly. To err is human. To truly screw up, you need a computer. Paste. There we go. Okay, so now mailbox and mailbag will work. So anytime someone uses Bing subscribe, it's flagging the chat in stream. Why is it doing that? That shouldn't. That's really weird. And Bing mailbox. So Bing mailbox is fixed. Now mailbag will work as well. I don't know why it's giving people a hard time, because they're saying. This is Stingray Master. Thanks a lot for the super chat. He says, or she says, or they says. Super chat. Very nice. Why is it not letting us... Why is subscribe not working? I don't know why it should work. It's just exclamation point subscribe. I don't know why that's not playing nice. Here's what I'm gonna do. I'm gonna go into the spam protection, and I'm going to edit. I'm just gonna edit one of the. I don't know why it's doing that. Maybe it's not letting. That's really weird. I don't know why subscribe isn't working. I wonder if that's something inherent to YouTube. It could be. Yeah. I wonder why it's not working. Yeah, that's very strange. All right. Well, let's. I'll just change it right now. What should we change it to instead of subscribe? Let's just call it sub. There we go. And let's change it on screen so people. I set this up as a text document as well. Ha ha ha. No, I'm not buying a license to Sublime Text. Get out of here. Who does things like? Who buys software? Wait a second. It should be updating. What the heck? One sec. Let's switch this back over. Yeah. I always end up messing more with the stream than I do with the. There we go. I always end up messing more with the stream than I do with. Is it not saving because I didn't register unregistered hypertext or hypercam? What's going on here? Come on. Is it just not saving it? Like, are we not doing that anymore? My phone is erupting. Hang on one sec. It seems like everything is going to hell. Bear with me one sec. Seems like everything is going to hell. At least it doesn't seem like we're losing any frames. At least. There we go. Okay, that works. Let's see what's going on here. Alright, I am going to disable notifications on the admin chat because my phone is blowing up. It's stressing me out. Brooke has sent me 11 messages, and I've missed all of them. Let's see. Yeah. Alright, so Brooke, there's no need to tell me immediately as soon as someone super chats. I have this on responsive mode. So, let's see here. Yeah, so I've got this on ultra low latency mode. So if I don't respond to someone within 10 seconds, it's not that like I haven't seen it yet. It's that like that's when I've missed it. So all right, enough. Let's roll. So yeah, today's episode is we are going to just we got a bunch of filament related tasks to do. The main thing on the agenda is the main thing on the agenda here is to try to do a bunch of these fancy prints. I haven't used many of these technologies before and many of these techniques, so things are gonna go to hell. Yeah, the things we have to try are from top to bottom. These aren't in order, by the way. We're probably not going to do them in this order. But some things we have to do is we want to try some high temperature engineering filament, like PEEK or something. Want to give that a shot. We want to try multi-material print. Not necessarily different materials, but at least I'm thinking that we'll use some cheap PLA to get our multi-material printing going before we start bringing in like the dissolving support and all that stuff. We also have some weird composites that we could try out. There's some really weird, neat stuff. We might also get some fan favorites, and see what folks want to see. And finally, we have some really weird, exotic, bizarre stuff like Vario Shore and lightweight, like foaming PLA. The PLA foams as it leaves the nozzle, so you can make low density prints. Anyways, our goal here is just to try to print some of them. So you can see we've got all 4 printers. Three of the printers are up. One of them I'm not 100% on. We're going to give that a shot. So yeah, hopefully we can get this all sequenced and rolling nicely so that we're running 4 boats at once. Benchy takes about 2 hours and change, give or take. Benchy takes somewhere in the neighborhood of 2 hours to print. So hopefully we can get this all set up properly. So this is wobbling a lot. Hopefully we can get this all set up properly so we can get 4 boats going. And we're starting a new one every half hour, so there's a lot of action going on. So yeah, let's make this happen. So we have let's turn our attention over to the overhead camera here. I'm gonna scooch, scoochy, scooch. All right, so let me show you what's going on here, because we're not done with the changes yet. First thing, in the previous video, in the previous stream, we worked on my last client project, and last night I printed it. So this is our first revision of what could be my very last client project. And yeah, this is a device that an art piece mounts to, and uses a motor to a stepper motor to spin it around at random intervals. And we discovered last time that you can now just Amazon just now straight up sells USB power banks that don't shut off automatically. Like you just hold the button for a couple minutes and it stays on. So it's awesome. So I just wanted to quickly show this one off so that folks who also tuned in to our last stream can see how our work has paid off. This is a fairly large print. It took about 11 hours and used about 300 grams of filament. The real deal is probably going to take a bit more because this only has 2 walls at 0.6 millimeters. The real thing I want 3 because, we don't want this thing breaking loose and falling off the wall. So I want to show this guy off before we get too deep into it, just so folks can see that the stuff even if we don't remember, finishing projects is kind of my thing. So even if we don't manage to get all the tasks done, even if we don't manage to get all of these tasks done on stream, I almost always end up finishing the project. So it doesn't, even if I don't always I am going to get better at showing it off. I'm going to start showing more things, showing more finished projects off on Instagram. So yeah, you can follow me on that. But yeah, I just want to say that, like, I actually finished the stuff I start here, and I appreciate everyone who watched. Because honestly, like, I tried not to make a big deal out of it, but the last stream was a big one for me. I've been doing this for, I did this for almost a decade. It's it's really the end of an era. Let's see, my phone is blowing up a second time. What's going on here? What's this going on? Right, we missed one. I missed a super chat from a certain Michael Pass. Thank you so much, Michael, for the generous super chat. Et l'argent and silver. I don't get it. I don't get it. I don't know my idioms. I'm an idiot. So yeah, this is what we ended up designing. Let's just I already have all the parts handy. Except the boards were there was a chance the circuit boards would show up today. I ordered them from Osh Park, and like they're cheap and they're cheap. They're American. They support the open hardware community, but you never know when your boards are showing up. So I hope they would show up today, but it looks like they didn't. But yeah, let's do a quick little test fit here. So we've got our USB battery pack. Does it fit? Oh, it doesn't fit. Yep, this is why we prototype. It looks like I measured something wrong. How did this happen? It seems like 2 millimeters too small. How did I mess this one up? Let's see. This is measuring at about 84 millimeters, and the hole is at about 80. Why did I do that?
The stuff on your desk is making a lot of noise because it's so close to the mic.
Oh, the stuff's making a lot of noise. I'm sorry. Brooke has just walked in and let me know that I'm making a lot of noise. Yeah, really sorry about that. I forgot that this can is acting like an amp. Don't worry, we're pretty much done with that. Then we've got our little slot for the stepper motor. You see it basically bottoms out, even though I haven't even cleaned the support interface. You see it's got these little wiring channels here, so I can route all the wires. I modeled in some keyholes. See right there, make it easier to do. Anyways, yeah, this is the project, and unfortunately it's not done. I have to reprint it because I'm an idiot. I seem to have just forgotten the second part of the 84 millimeters. But yeah, that's what we do with our projects. So what the hell is this? Well, this is another one of the things that. Oh, first we have what should we call it? We got a tablet here, and with any luck, the tablet is going to display chat and stuff. There we go. We got the chat going, so I can keep an eye on this even when we're not sitting at the workbench. So yeah, sorry in advance for the sound. We're going to buy some new audio equipment soon. Pardon me. But what the hell is this? Well, this is this is a spool of Stratasys filament. I know, right? That's really something. Yeah, this is a spool of Stratasys filament that Trucku sent me. And they come in this ridiculous canister. This thing is made of steel. And this thing has to weigh like 10 pounds. I don't know how much of that is filament and how much of that is... so maybe that's what this is here. 92 cubic inches, 1,510 cubic centimeters. Like, I don't know what that is in normal 3D printing units, but yeah, this is soluble support intended for high temperature filaments. But yeah, this stuff hopefully should work in general. And this is definitely the weirdest packaging of any of the filaments that I've got so far. I took a little look at this, and I couldn't figure out how to get the filament out of it. I'm not sure, we're not going to use this right away, but I think it seems an appropriate way to get started to try to get filament out of it. So yeah, it's got this label here that's the instruction manual. So let's let's peel that off and stick it here so you can take a look at the instructions. Duruth, the Eldritch Cryptid, says 1 cubic centimeter is about a gram. So this is only 1.5 kilos. This thing weighs a ton. It's a steel drum. It's like a magazine. So I don't even know what this does. I'm kind of curious. I almost want to reverse engineer it. I'm wondering if this is just shorts and lets. I wonder if this is just a dead short. I wonder if this just lets the system know that there is a can of filament there. I don't need to worry about wobbling the table. This is great. This isn't part of the assembly process. I just want to rip this off and see what's on the other side. Hopefully, it's got some wires leading into like mysterious inner parts. Let's see what's going on here. Anyone who's used Stratasys printers probably know. Stratasys is the company that bought MakerBot, and this is like a big boy print. Oh, hey, it's actually got a chip on it. Wow, it's got nothing but a single chip. What on earth is this? One chip, not even a decoupling capacitor. What's the label on that? It's marked. The font is really weird. I can't read it. Let's see. I've got just the thing. I got just the thing. Wow, we still managed to make this thing wobble. Huh. Guess I gotta put more slack on these wires. Sorry about that. Haha. There we go. I'm like a nerdy pirate. Let's see. What's the number here? DS24B33. DS24B33. Let's take a quick look and figure out what that one is. Let's see. DS244B3. Was that correct? It doesn't sound right. DS24B33. DS24B33. It's a 1-wire 4 kilobyte EEPROM. They're not kidding about the 1 wire. That literally has only 2 pads on it. I guess maybe this is acting like ground. Maybe the screw hole is mounting as a ground. All right, so this actually has a memory chip in it, so that the printer can identify what the filament is. And I wonder if it also writes onto it, so it keeps track of how much filament is left to keep you from refilling it and just running the same canister over and over again. So that's pretty neat. I'll put this back for authenticity, but it would be kind of interesting to try to hook this up and pull the data and dump the data off of it. See what's going on. Anyways, let's take a look. So so let's see. So the first thing we have to do is lift tape, remove plug. So I don't know if this is used already. It doesn't look like it, though. It looks like this is completely unused. All right, so check this out. So we've got this plug, here, and that seems to be. Actually, let's see if I can get my. See if I can get my picture-in-picture going. Where is my? Yeah, there it is. So you can see in there, it's actually inside just a spool of 1.75 millimeter filament, just like with a bunch of stuff in it. But I think this little plug here keeps it from rotating. Yeah, check that out. See, it moved a little bit. I think this little plug keeps it from rotating. This is really over the top setup. And then we're supposed to put this back on. We're supposed to put this tape back on. Because this is a soluble... I don't know what this actually dissolves in. I think it's water. But that would mean it's attacked by atmospheric humidity. So, yeah, that would mean that it's important to keep this sealed. So look at all this, all rubber gaskets and stuff all over the place. It's really cool. So, let's see. So, I think now we're supposed to mount it to our filament rack. I don't think we have one of those, but yeah, we've got a cap we got a cap that comes off here to block the filament from escaping. We have a gasket here that this is like a brake. Oh, I see what's happening here. So this is like a brake, and it wants us to tear this off. So this, I guess this belt system here is what actually advances the filament, and this rubber pad presses against that and keeps our filament from turning too much while it's in storage and while it's in transit. Yeah. See, so that's what this is basically what we're doing today. Is we're fighting with fancy filaments. There we go. This is so goofy, and I think this little pad is supposed to like go here. I think we're supposed to use this this cap. Where is it? I think we're supposed to use this little cap here to. Oh, it's got tape on it. You just stick it right there. Yeah. So I think somehow this is supposed to. No, we're now supposed to be able to get at our filament. I think. I don't know how to manually advance it though. This is it. The instructions are over. I'm guessing the system itself, like, it must drive this. Like, there's nothing for the there's nothing for this pulley to engage with. So I'm gathering there must be like a wheel or something, like on the printer, that powers this. So yeah, now I'm feeling kind of dumb. I don't think there are any steps I forgot to do. There's no way for it to detect that this flap is closed. The flap has to be open, right? Because otherwise, you just put it back here. So how the hell does this drive? It's gonna be really obvious, isn't it? Like, this is gonna be something really obvious. It's gonna make me go, oh my friggin' god. Yeah, that's really that is really something. Let me tell you. It's a real something. I don't even know what this is supposed to do. It's supposed to like engage the something or other. Yeah, I don't know what the heck's going on here. But I'm enjoying the process. So what's this actually supposed to? So we have a little tension spring in there. We have a little leaf spring in there to tension the filament. What's supposed to go? Normally, Jerome says normally it sticks out of the hole. It's auto feed. Yeah, I guess there is supposed to be a filament coming out of that little hole there, but there certainly is not. I wonder if there has to be a trick. Like there has to be a way to manually advance this, because if the filament were to just snap off while you're loading it, then there's no way that you'd just be screwed, right? Like. Right? Although it does kind of sound like something that could happen with a piece of industrial equipment. So what's happening here? There has to be a way to turn this. Maybe the spring is like acting like a brake. I see the filament in there. Oh, this is just a wheel. Oh, this is like, so this right here is just an idler or something. Oh, there we go. I just wasn't pushing hard enough. There we go. So yeah, I guess this part here gets driven by this part here gets driven by the mechanism, and yeah, here we go. How many idiots does it take to advance some filament? So we're probably gonna have to re-spool this. I don't see any way that we could. I mean, maybe I could make a bracket to like attach this to the side of the printer or something, but yeah. Let's take a look at the filament itself. This is very tough for support filament. This stuff, by the way, if you want to look for it, it's called SR110. I was going to get really cute and put all the links for all the filaments in the description, but I did not have time for that. So yeah, this is SR110, and this is really, really stiff as support material. This stuff is not snapping. Look at that. It's turning white like ABS. Normally when you bend ABS turns white when you bend it. So I wonder if this actually just straight up is ABS. There's one way to tell, right? There's one way to tell. And how you react to this depends on how experienced you are with materials, from what I've been told. Very nice snap, by the way. It's really, yeah, really cuts cleanly. Let's get this out of here. And yeah, we're going to lay it on fire. That's kind of what I'm getting at here. We're going to lay it on fire. Where is the fire? I got a fire, Corbin. I got a fire. I thought I had the... Where'd I put the lighter? Did Brooke, did you steal the lighter? Did you take my lighter again to do magic things? because I'm sure I put the lighter back right there. I guess we're not burning it. All right. Anyways, that's what I was going to do. I was going to lay it on fire. You can tell a lot about a plastic by how it burns and the smell that happens when it burns. Brooke says the lighter you gave me.
The lighter you gave me?
I thought I had 2 of them.
You gave that to me when we were out on the patio.
I guess I gave Brooke the lighter that I was. I guess I gave her. I thought I had 2 of them. Maybe one of them ran out. Sorry, Brooke. I love you. Yeah. So let's see what happens here. Let's give this a little. Give this a little roasting. Look at that. All right, lid on fire. Ooh, I don't like that. I don't like that at all. No smell. It's almost like a buttery smell. So it's definitely not a styrene. But it foamed up like crazy. Here, let me switch back to this guy here. Take a look. Focus now. Come on. Come on, focus. Focus! What the hell? There we go. See that? It foamed up. I'm guessing it's not supposed to do that. So I don't know. It didn't make a lot of smell. Maybe it's not. Maybe it's like a nylon. Yeah, because this is designed to be used for film. Like, this is designed to support like polycarbonate and nylon. So maybe it's like a form of nylon that won't bond easily to other nylons. I don't know. I'd hope we'd luck out and it would. I'd hope we'd luck out and it would just smell. It would make a smell that I recognize, but it doesn't look like we're that lucky. So hang on one sec. Doesn't look like it's a good idea to use, so we're going to drop this in some water and just see what happens. Doesn't look like we're going to be able to use this today, though. Because, well, the fact that it foamed up shows that it has a lot of... shows it has a lot of water in it. And it was date stamped 2016, so it's on the old side. So I think we're going to have to dry that out before we do anything. And that could be a problem. We're probably gonna have to disassemble. The can and put it back. There's actually a flow chart. I forget where it is, but I had this flow chart that like you light the plastic on fire and you follow the flow chart and it helps you identify what it is. So yeah, I just figured that was a cute way to get started. So we got a few things to do today. One of the first is we have a lot of filaments. One sec. Let me get this out of here. I should have done this early. Oh my. Let's find a good one here. There we go. So for this episode, a lot of our filaments came in as samples, right? Like loose filaments. So I've been printing these spools, like they're adjustable. You see, like they got these bars that move in and out. I've been printing these guys here, and yeah, we're gonna have to re-spool some of these filaments, or we won't be able to print with them. So that's one of the tasks to do today. We're not gonna do this. We're not gonna do this first. Instead, we are. I'd like to get some prints going, and then we can spool them up. So yeah, I think the first order of business is to figure out what kind of filaments we want to do. We could do some conventional we could like print some conventional filaments that we didn't cover. We got like some holographic. We got one with holographic glitter in it, so it changes color depending on the angle you look at it. We could just try something funky like flexible wood filament, or we could go straight to hard mode and try to do multi-material printing. That I have no idea what's going to happen there. I'm actually really afraid of that. I've been really dreading this and trying to avoid it, but the time has run out for procrastination. We're going to have to cross that bridge sooner or later, and I think today's later. So I'm thinking that's where we start, unless anyone has anyone has a oh, what did I do here? I must have made a boo-boo. Everyone's messing around with the bot. I'm thinking that we should try some multi-material printing. I think we should see what happens there. So the tool the tool changer so the tool changer has this. I've never used it. In particular, the thing that it requires from us is that our 4 nozzles are offset properly. And what this means is basically each nozzle, for each extruder, the tip of the nozzle isn't necessarily at the same point. So it uses this set of offsets. We actually got a few things going here. We got a set of offsets that we need. So we got to make sure that those match, because if they're off even by like, a tenth of a millimeter, then the support filament and the 2 colors of filament or the 2 materials won't line up properly. So they might fuse together or not bond at all. So there we go. Let's move that out of there for now. So we got to make sure we dial that in right. And we also need to calibrate our E-steps, because we have to make sure that the exact right amount of filament is being ejected. And finally, there's one final thing we have to do, in that we have to adjust our brush script. Actually, from this angle, you can't see the brush. Maybe we can get it from here. It's just out of sight. There it is. All right, so check this out. This right here, actually going to, let's head back to the control panel, and I'm going to drop the bed. Oh, it won't let me because we have to home the system. It won't let me control anything until we home it, which is weird because it'll crash eagerly even after it's home. So we'll home that, we'll drop that. Basically, right here is a little brass brush mounted to the side of the thing. That needs so I actually have 2 heights of nozzles, and this only works for one of them. Let's zoom. Let's get this out of the way. Let's get this out of the way. There you go. We should be able to see it. Come on, get down there. Yeah, so there it is. That right there. Yeah, that right there. So it's got this brush, and basically because we have the extruder hot, but sitting there, not doing anything, plastic is going to ooze out of the nozzle. And you can use like a wipe tower or something to collect that, but the way this handles it is it has a script that drags it over this bristle brush and knocks it off. And it's supposed to have this bit of wire here, that paper clip, that's supposed to knock most of it off so it doesn't clog the brush. I kind of destroyed that by kind of running an extruder into it. So yeah, we got to fix that, and we got to get that working. Otherwise, we won't be able to do multi-material prints because it's gonna just be a boogery, disgusting mess. So yeah, we gotta make sure our prime script is working. We have to make sure our brush script is working. And then we have to double check. Let's see. Then we have to just confirm that all our extrusion stuff. All right. Got to structure my thoughts here. All right. First, we've got to load in the right filament. Second, we have to get our prime and brush scripts working. Then we want to. Let me think here. We are going to have to we have to redo a bit of our calibration, because right now it's calibrated all right, but it has to be tightened up. So we got to make sure that our Z's all we got to make sure our Z height is all our Z offset is all the same. It's all consistent. Then we need to get our E steps dialed in. And finally, if possible, I'd like to. I'm not sure it's necessary. I was going to say rerun PID calibration, but I'm not sure that's really necessary. I think we'll be all right. But yeah, I haven't done any squirt puns. Oh man, really messing this up. Yeah, I had hoped to run this stream yesterday so I could call it like Squirts Day Thursday. Yeah. But yeah, if you're hurting for a squirtin', then here we go. The puns are mostly going to be in the names of the printer. Like here, check this out. Haha, there we go. Yeah, this is Squirtsephony. I originally called it Squirtburist, but it didn't look right. But now this looks like it says Squirtsophone, so I think we need a new name. I decided to call the Anycubic Viper the Squirt Viper. Yeah. I really like my job. By the way, sorry, Brooke, for messing up with the lighter. I thought I had 3 of them, and I finished one and gave one to you, but I was wrong. Yeah, so without further ado, let's give this a shot. So the extruders we're going to use. So the extruders we're going to try to use for multi-material printing. Let's actually switch these around. There we go. The extruders I'd like to use for multi-material printing are these two, because they're both the same. They're yeah, we got our liquid-cooled Titan Aqua extruder. We have 2 just regular-ass Hemeras, and this Hemera has a volcano. These are the ones that we're going to be using primarily for multi-material printing. And right now, this one is loaded with PET, and this one is loaded with PLA. And I believe you can actually use PET. No, I'm missing some stuff. Akelia, thank you so much for the very, very generous super chat. Really appreciate it. The tool changer should be called the Squirt Hydra because it has 4 heads. maybe we'll call it the Squirt Hydra. Figure that out. I do seem to have something in my hair, don't I? Oh, it's a piece of support. It must have got flung off while I was piece of support material. Must have got flung off while I was cleaning up that client print and flew into my hair. You know, I kind of like it there. Yeah, so we need to unload the PET and we need to load up some PLA because we're gonna work out the kinks using PLA because it's cheap. I don't want to waste our fancy pants support filament. I'm also not 100% sure we can even use the support filament because it could be waterlogged. So, yeah. Let's get set to unload our filament here. How do I do that on this? Let's see. I think it's here on our dashboard. Do I close this? Oh, there it is. Okay, so it goes 0, 1, 2, 3. So we want number 2. I want to load. Yeah. Let's see. So we just hit this, and it should pick it up. There we go. I'm amazed how well this works. Like I've never had a failure to engage a tool. QWERTY, thanks a lot for the super chat. Not pleased with the idea that I have a Taz squirt horse in my basement. Squirt horse, it squirts. All right, so we pick this up. Let's get the temperature up to 235 so we can unload our PETG. There you go. Now it's heating up. The fan turns on automatically at 70 degrees, so that you'll hear that in a sec. In the meantime, let's go grab some PLA that I'm not very attached to because it's probably gonna get wasted. It's whatever PLA we're using here is gonna go to waste. So yeah, I'm running out of crap filament because I'm running out of crap filament because I'm trying to use it all to make room. So this is actually getting harder and harder. Let's see. Silk filament's a bad choice for this. That filament's expensive. That one's really expensive. Let's just use some white. Well, do some boring. Oh, hey. No, this is it. This is perfect. All right. I got this from Fusion Filaments when I bought. Fusion Filaments has some pretty neat stuff, and this is one of the filaments that I got. It's one of the filaments that I got from them. This is their well. First off, the spool itself. Let me show this to you. The spool itself is 3D printed, which is kind of cool, and you can actually open the spool up and replace the filament on it, which is kind of neat. But this is color purge filament, so whenever they switch colors between two manufacturing runs, it. Yeah, then like they end up with filament that's like 2 colors combined. In this one, it's a little bit white and a little bit red, and they sell you this filament. So for like $15, you can get a kilo of filament of a color that you're never going to be able to match, which is fine for what we're doing. Yeah, isn't this nice? It's not as PP yellow as it looks in on camera. It's more of a fluorescent. It's more of like a fluorescent green. Here it shows up a little better. Yeah, there you go. Shows up better on this because we got color science. So yeah, that's what we're gonna do here. We're gonna use the gray filament that came with the Viper, and we're gonna use that's already loaded, and we're gonna use this color purge filament because we don't really care about it. So once we have this all dialed in, of course we're gonna have to use some purge filament, or some cleaning filament to get the PETG out, so we don't burn anything. H4 says, "What about calibrating the colors of your cameras?" I used to, but it seems to clear the calibration every time I restart OBS. It doesn't store it on the camera, and I haven't figured out a way to automate it. So it's just a lot of time. Yeah, it's just a lot of time that I'm not totally sure we got. So yeah, let's do this. So we're gonna move this back. Is this it? Ah! We crashed. We crashed. We have to start over. Yeah, let's. It doesn't like enforce the this. I haven't figured out how to get this printer to like enforce its software, like its soft limits. So we have to recalibrate. I guess I could have just got away with calibrating Y because that's the one that crashed, but yeah. So recalibrate that. In the meantime, let's actually set this to idle at 230. Oh, it's not going to run that because it's running another G code, or it's running it's running the script to home itself, so it can't run any commands. Alright. So let's see. Just have to pick this up. And bring it back. Come on. Oh, is it heating synchronously? Why is it doing that? Why is it heating synchronously? Should only take a second. All right. There we go. All right, and let's get the plate all the way out of there. There we go. All right. Should probably grab a paper towel. Yeah. Oh, one sec. I hope. Oh, jeez. Should have tucked my shirt in or something. All right. So let's do this. I'm gonna try to not sit in front of the camera. There we go. Bring this over here so I can actually see it. So yeah, let's pull this out of here. Let's retract. There we go. And let's pull it out of the really, really ridiculously long feed tube. Let's clean the nozzle off too. This is using a sock, but it's still PETG. You know how PETG is. So I'm now winding it back. I'm now winding it back. It's being pulled through this ridiculously long, it's like a meter of PTFE guide tube. This is the last of Polymaker. I need to raise this a little. Yeah, the way the spool holders work on this isn't great. I should really print some detachable spool holders. Yeah, this is Polymaker or Polylite PETG, and I actually really like it. Looks like we have less than 100 grams left because all the blue parts here have been printed in it. Let's get that out of there. Let's grab our color purge. In the meantime, actually, let's switch our temperatures back over to 200. Yeah, let's switch our temperature back to 200 so we don't burn the PLA. I'm not gonna shove this all the way in yet. I'm just gonna just gonna hold it in place. All right, so yeah, we shouldn't turn the temperature down yet. I just realized. There we go. Because we got to run some of this purge filament through. This is I'm not actually sure what plastic this is. I think it's just I'm not actually sure what plastic this is. I just know that it tolerates a lot of temperatures, so use this in between filaments. There we go. Use this in between filaments to kind of clear the nozzle when you're switching between materials with different temperatures. Yeah. Very nice. Let's keep on extruding. We want to run a whole bunch of this. What is going on here? We have rather a lot of emails. Keep on extruding. Yes. There we go. Talking to there we are. Talking to Micro Center. They really like the PC video. I wish more people saw it. I wish YouTube showed that to more people. Because I thought that was one of the best. I thought that was one of the best episodes in the channel. I loved making that so much. It was so much fun, and the PC itself came out great. But yeah, Micro Center loved it. It was a lot of fun to film that episode. All right, so let's get our purge filament out of here. Let's switch our temperatures back to PLA temperatures. Let's feed this through the ridiculously long tube. It looks like nothing's happening, but this filament is hauling ass. It seems we got stuck on something. I think it's a coupler I had to add. Yeah, I cut the filament in the wrong place, so I had to add a coupler. Oh, come on. Don't be like this, filament. Yep. Ah, jeez. What's going on here? I should have beveled the inside of the PTFE so it has a bigger target. So let's keep feeding this on through. It's going up over the top, and it should be visible right. Yep, there it is, right there. So let's get this in here. I think it was actually extruding a little fast, so we're gonna slow this down. Have it extrude. There we go. I gotta get some of those little clips to keep that keep the locking nut in place. So you see it. The PLA can easily push out the purge filament because purge filament is liquid. Even though it's even though it like survives, like even though it won't burn at 230, it still can print, or at least come out of the nozzle at only 205. So yeah. Oh man, this has been a hell of a week. Let me tell you. This has been a lot of getting the last video done, and also messing around with all these pavers and stuff. These things are heavy. This printing setup was a workout. Okay, so we now have two PLAs. Yeah, we now have two PLAs going. Now, yeah, we have two PLAs going. I think the next thing to do is to work on our brush script. Yeah, I think that's going to be our. Yeah, I think that's the next order of business. To get our brush script going. Let's go like this. So you fine internet people can actually see the brush. There we go. Make sure you folks can't see my underwear. All right, let's go over here. Switch back over to our stream. Seems like folks are enjoying the bot. Hopefully it doesn't take chat over too much. Yeah. All right. So let's. So let's make this. Let's embiggen this. Ew, where did this screen come from? I need to get rid of this. What do we want to do here? We want to go to we need to log into Squirtsephony. There we go. Oops, that's not what I wanted at all. There we go. Yeah. So we're logged into Squirt Stephanie. Let's head over to our. Let's actually increase the font size so people can see what the hell's going on. We're gonna go to System, and let's take a look at our brush script. So yeah. Let's see. We really. I don't want. I'll try to get this in the center, so we can actually see what's going on. Oh, it's gonna display the soft keyboard. Oh, man, none of my system is working right. Oh, what the heck? That's not what I want at all. Alright. My hotkey is not working. That launches the launcher. There we go. And my mouse has deleted the preset that allows me to actually move it at a speed that I can handle. So I don't know what the heck happened there. Is this it? Yeah, there we go. Alright. And now I can't get rid of the window. Oh, that's great. No, I can't get rid of the window. Alright, okay. I'm not going to be able to get rid of the on-screen keyboard. So basically, this is a very simple script. All this is doing is first dropping the bed to make sure that as we... So this script runs basically... I believe a script runs between when we pick up the film, we pick up the extruder. So here's what happens when we switch extruders. Yeah, when we switch between extruders, the system, I think, or between layers, I don't know. I think it's when we switch extruders. It first runs T free, which is tool free. And that causes it to go back to its cubby hole and drop the old tool off. Then it will run T-pre for the new tool. This one causes it to pick up the new tool, like to move it into position and lock it. Yes, we definitely want to be... Warnings, I think I put those in for myself. Then it runs T-post. You see it's got... I've commented out the prime. This is something we want to be careful about to put back. Basically, after it picks up the new tool, it will squirt a tiny bit of filament out just to make sure that when it starts printing, there's filament in the nozzle. That's why, if you've heard me in past episodes, in past streams, saying like, what the heck's going on here? Like when it's not printing for the first few seconds of a layer, it's because the nozzle isn't primed. There's no filament in it. Because, like a Prusa, for instance, it draws a big fat line on the bed before it starts the print. This doesn't do that because it assumes you've already run the prime script to extrude a little filament. We want to get that uncommented. We want to get that rolling too. Yeah, so it runs that, and then it's going to, after it primes, it's going to run the brush script. The brush script is really simple. Basically, all it's doing is hopefully driving it over to the position where the brush is, and just, I think it's, yeah, brush in and brush out. I think all it's doing is like zigzagging across. And yeah, we're gonna have to adjust this a little bit we're gonna have to adjust the brush itself to make sure it's at the correct height. And we also want, we're also gonna have to adjust it a little, depending on, I don't know, like, hopefully it works, but we might have to shift these coordinates over a little bit. So yeah, so let's get this done. First thing I'm gonna do is I'm gonna unscrew the brush itself, and we're gonna just push it, we're just gonna do a sanity check here. I think, yeah, hopefully this isn't as far down as it can go. Like, no, oh wait, it's not even close. Alright. Oh, I guess it is as far down as it'll go. Alright, so let's just pray. I don't want to unscrew the whole thing. So we have two heights of brushes here. We have two heights of extruders. And I don't actually, like, Renee set up this, like, the guy who sort of, like, contributed a lot to this, he set up this really fancy system where the brush itself has its own axis, so the brush can raise and lower depending on the height of the extruder. We don't have that, so we just have to remember never to run the brush script with extruders 1 and 4. So yeah, let's run this and see what let's run this one and see what happens. Yeah, I think we can do this like so. Oh, 8. We're gonna open up another instance of the window, or another instance of the front end, and we should be able to run it. Never mind, I guess we can't. What's the G code to run a script? Let's see, M98. Alright, so we'll run that here. Let's open up our console and let's go M98P brush.g, I think. I think that's what it's called, brush.g. Alright. Oh, that wasn't supposed to happen. Alright, so what happened was it bashed the tool against the left side of the printer. And the reason why it does that is because usually the brush is... So there's a place to mount the brush on both sides of the printer, the left side and the right side. And it thinks that the brush is on the left side, but it's not. It also can't... This script is set assuming you're... Yeah, the script is set assuming you're using a V6. You're using the E3D V6 Bowden. And we're not. We're using with the stock fan. We're not. We're using the a Hamera with an extra large fan on it. So it's crashed the fan into the side of the printer. So yeah, that's going to be a problem. Needless to say, that's going to be a problem. So we've lost homing. Yeah, we've lost homing. So I'm going to manually detach the tool. And yeah, I'm going to manually attach the tool, manually return it, and then we'll rehome it. So let's see. So we're going to go back. I'm going to do this here so I can actually physically hold the tool. So let's grab this. Right. So we're going to go to macros, and we're going to run coupler unlock. There we go. You folks want to see the real engineering parts. Well, sometimes I give you folks what you want. All right, the next. So it still thinks it's active, right? It doesn't know that it's detached the tool. Maybe I'll change that. So that's really easy to do. We just have it pick up tool -1 and P0, which means don't run. Basically, this says pick up. Drop off all tools, but don't run any scripts. And this will cause it to, pay attention right here where it says active. When I run this, it's going to go from active to standby, but nothing's actually going to happen. See? There we go. So, yeah. Now we can safely go and home it. And I forgot the G... I gotta learn the G code to do all this stuff, so I don't have to keep clicking back and forth between menus. G28, that's it. So let's home this again. The reason it seems to stop here is because it's homing the C-axis, the coupler. Yeah, kind of interesting. Let's see what's going on. I haven't checked on chat in a couple minutes. Yes, everyone knows that the subnet here at Voidstar Lab is 192.168.1. Oh no, you could never figure that out on your own. Yeah, so we crashed it the first time. We're gonna have to do this. We're gonna have to do this manually. Yeah, so let's we're gonna make sure the bed is dropped. I'm just trying to think of the best way to do this because I don't actually know what the script is supposed to do. Let's just run the script by itself, right on. Let's just run the script on its own, and with no tool attached, and just see what happens. It's actually I'm gonna try to decrease the font size here. Yeah, so we get our G code back here. All right, so we're going to do, what is it, G92, M98. I'm tipping my hand here a little and showing. I'm tipping my hand here a little because I don't have a lot of experience working directly with G code. So yeah, feel free, judge me all you want, but. You know what? I was going to say judge me all you want, but let's keep it between us. But that's an unreasonable ask. Nope, tell everyone that Zack has no idea what he's doing. He's never worked G code before. that Zack doesn't know the G-code off the top of his head to run a script. Well, I will. This is how I learned everything, by the way, is just bashing my head against it. Like, being put in a situation where I have to use it, whether I know it or not, and just, like, smash my head against it. Alright. I've been waiting for someone to ask this question. Sean Taffert says, Zack, what if you just make a second brush at a different height for extension for EXT 1 and 4? This is possible. This was actually the original plan. The problem is that I won't be able to use one generic brush script anymore. Now I'm going to have to... Alright, so this is using RepRap firmware. RepRap firmware... There are control commands in G-code, right? Like, variables, if, then, switch blocks, iterating, like programming stuff in G-code. RepRap firmware doesn't support any of them. Not one. So there's no way for it to know that it's on brush 1. Or there's no way that there's no way it can adjust the G-code, right? Like, there's no way you can say, oh, I have extruder number 1, so I have to use brush number 1. Oh, I have extruder number 3, I gotta use brush number 2. There's no way for it to know that. This printer, everything it runs is literally just following instructions to the letter. Running one command after another. Like, yeah. The only time we have that level of control is during the slicing process. So I need to write a second script, and then I have to make sure that the brush scripts are never called anywhere on the printer itself. That they're always, I have to make sure that I'm always running the special G-code profile that will add in the correct brush codes at the right time. So it is doable. It's going to take a little time though. So yeah, that's why it's not ready yet. But yeah, let's just see what happens here. Actually, there's a way for this to slow down all its motion. Let me see that. G-code motion scale. RepRap. So yeah, basically, I want to slow down. Let's see, speed factor override percentage. I think this is at M220. Yeah. All right. So here's what we're gonna do. We're gonna run. Let's see. Let's switch back so you can actually see what I'm doing here. And there we go. Printer vision. Let's see. We're gonna do M220, which I think is global speed scale. And what's the parameter called? It's called S. I wish this was all standardized. So let's see. So this parameter, so this G-code should cause it to, every time it does anything, do it at 1/10 speed. So now we should be able to run M98. Yeah, there we go. All right. So looks like it's moving into position. Check that out. It's starting at the front. It's moving. It's going back, forth, back, and then kind of scribbling a line on it. Let's actually make this full screen so you can see what's at play here. And I'm actually going to scale this down even slower. M220 S5. And now we'll do M98. There we go. So. Yeah, I'm thinking here, we can, alright, so our options here, right, are either, so let's see, our options here are really either rewrite the script or install the brush on the other side, and you know me, let's install the brush on the other, oh, alright, we can't install the brush on the other side, because the hammer, the nozzle is alright, so for the V6 nozzle, so for the E3D V6, the nozzle is basically centered with the tool changer plate. With the hammer, it's offset all the way to the right, so the brush is not actually long enough to, like, if we were to grab one of the, if we were to try to do a brush, the brush would actually overlap the plate, and as soon as we drop the plate, it would snap off the brush. So we have to rewrite. So we have to rewrite this script. We have to do it from scratch. So we have to write a script based on the existing one that is going to cause it to start at the front, move back, and then scribble its way across it. Yeah, that's what we got to do. So let's. I know it's not fun, but I know it's not the most exciting to watch, but we have to do it if we're going to do multi-material printing. It's not optional. We have to brush. We gotta brush. Yeah, the brush has to happen. Yes. Column E says, find the offset and add that to each of the existing numbers in the same script. Would that work? I guess if we just know the distance between the two. I guess if we just know the distance between the two, that'll at least give us a starting point. I think that's a decent. I think that's a decent idea. All right, so let's get a rough idea here. Let's see. I don't have a metric. I gave Brooke her metric tape measure back. There's no need to bring it in, Brooke. Stay at your battle station. Yeah, we'll just estimate it in inches, and take it from there. So I think these are in the neighborhood of let's call it 13 inches, give or take. About 13 inches. Loizos Grautos says, "What about?" I hope I pronounced that right. What about a brush at each parking position? That's actually kind of interesting. I guess the thing I'd be concerned about is the filament getting fused to the brush if it cools down, and then causing some damage when it picks up a cold tool. But that's interesting. I'll think about that. Yeah, I'll think about that. Eris Palm says, what if you just make it brush in all possible nozzle positions sequentially, so at some point every nozzle gets brushed? I mean, that would take a... So, like, what you're saying is basically, like, pick up the first tool, brush it where it's supposed to go, pick up the second tool, brush it where it's supposed to go, and so on. That would add a ton of time to tool changes. Remember, this could, like, if we're printing in multi-materials, right, it's not unreasonable that this could change tools 20 times in a single layer. So anything we can do to cut down the amount of time that it takes is anything that cuts down the amount of time that any of these scripts take will save a ton of time on the overall print. So yeah, let's figure this out. So we got we got 13 inches, and we want to get that into millimeters. Approximately, it's 330. All right. So let's start by. Let's see, so we'll drop our bed. It's the same as usual. Let's see, we're gonna copy all this. Anybody know how to do multi-line? Can you do multi-line comments in G-code? Is that possible? Anyone know how to do that? Anyone know how to do multi-line comments in G-code? I'll look it up. Multi-line comments in G-code. Parentheses to embed add a comment at the end of the line, use a semicolon. A semicolon is not treated as... It's in a... So, let's see. Inline comments. I guess we can't do multi-line comments in G-code, huh? Interesting. So let's just do this manually. Basically, I don't want to delete the script altogether. I just... I don't want to delete it just yet, because we might cause more harm than good. Yeah, alright, so with each one of these, we'll just add 330 to it and see what happens. So, yeah, this becomes from 32.5, it's 362.5. Let's do 3. 62, 65, 68, 71. I'm gonna mess up basic arithmetic and get completely skewered. Comes with the territory. If you can't hang, then if you can't handle people ripping apart every minor mistake you make, then YouTubing's probably not for you. Okay. Oh, we don't want to save the web page. We want to save the script. All right. So let's give this. Let's do a sanity check here. Let's just make sure this. See what happens. That's weird. Shouldn't have gone to the other. Should have gone to the other side. Is X negative? Is it? Is this? Oh, it's moving 1/10 speed. That's why it's going so slowly. No, I think I had it right. Increasing x moves it to the left. Let's reset our speed here. M220 S100. I forgot we need to home we need to home again. It might have. But let's see. Let's take another look at our brush. Oh, it's negative. Oh, I'm so stupid. For crying out loud. This is yep. I just made it move. So why does it enforce its own limits on the left side, but not forward? Like why will it easily try to drive the y-axis through the front of the machine, but it won't drive it through the left side of the machine? Oh my. Alright, I'm dumb. When you add a negative number to a positive number, you end up with a number between the two. I know, right? Okay, so alright, there we go. So this becomes 320.5. Becomes instead of 38, becomes 350. Hang on, my math is wrong here. Basic arithmetic is really hard to do. Yeah, there's a reason I'm not a real engineer. 330 minus 32.5. 297.5. Alright, so let's see. 330 minus 35.5. 330 minus 38.5. And 330 minus 41.5. Up. I keep reflexively saving. All right. So yeah, let's just the y coordinates are all the same. 330 minus 32.5 is here. I think this should work. 288.5. All right, I think this should work. Let's save it. Let's run it, and let's actually slow this back down. There we go. All right, so let's do. What was it? M89, M85, M98. I don't even remember. M98. Let's see. I want it on this so we can. I want it on this screen so that we can edit the script and test it without having to switch tabs. All right, so we're M98, and we're going to run brush.g. Let's do this. All right, so it looks like we're a little too far over. Let's see. Yeah, we're a little too far over, but let's see how far approximately. You think 50 is probably too much? 50 is probably too much. So I'm going to change this to move 10 millimeters per step. Is that looking right? Oh wait, hang on a second. We're not necessarily incorrect here. We should test this with a tool, so that we have everything lined up properly. Yeah, we should test this with a tool. So let's increase our speed scaling back to normal, and let's pick up tool number 1. There we go. We're gonna pick up tool number 1, which I guess the other one. I guess they've all cooled down by now. And now let's slow this back down again so we don't crash. Let's run the brush script again and get an idea of where it's ending up. Let's switch back over. Actually, let's switch over like so you can see the brush. Here we go. Let's run this. So we're still pretty far over. Yeah, we're still pretty far over, but let's just move our. We're gonna move this over and manually line it up. I hope we can. It looks like the fan is awfully close to. So it looks like the hot end cooling fan is awfully close to colliding with the side of the printer, or at least the belt. Oh man, it's a bit of a. I guess it's not as close as it looks. So this is approximately So this is approximately where we want the where we want our x. So let's take a look. Our x right now is 332.5, give or take. So let's open our brush script back up. 32.5. So that's about the middle. So let's see. These are in the neighborhood of like 290. So we want to add, let's see, 330. Really want to add like 40 to each one. Let's call it. Yeah. Let's add 40. We'll add 40 millimeters to each one. So, come on, math, don't fail me now. Yeah, 33. You saw nothing. Let's add 40, right? That's what we're doing? Yeah, we're adding 40. All right, 32, 32. All right, let's see how badly this messes up now. I'm going to slow that down, and run it while I'm looking at it like from below, so we can so I can make sure it's actually like lining up approximately right. So let's slow this down to 1% speed. And now, is there no way to run this? Hang on, let's see. System. Can I right-click this? Brush. Doesn't let me run. Yeah, it doesn't let me run system macros from this menu. I think I'll need to. To change that. Trust me, I'm still here. All right, let's run this. Did it work? Is it running? I think this will do it. I think we want to move this a little bit over. Yeah, I think we want to move everything like just a few millimeters over, maybe like 5, and then we'll give it a shot. Yeah. One thing I don't like is how I feel like this should really come in from the front and then turn around, but we'll see how much damage this causes. So yeah, let's move this 5 millimeters over. So it's 229. 5 millimeters. It's going to be 6, 3. All right. 5 millimeters. 3, 2, 3, 2, 3, 2, 3. Alrighty. Let's run this one more time. I think I might have been too far. Yeah, I made a boo boo. I think I might have done it I think we probably should have done it in the other direction. So let's add 3 to each of these. And yeah. Let's see. Save that. Run it again. Oh, it's crashing into stuff. Yep, we went too far. I hear it crashing. So let's cut a few. Shave off a few more millimeters, and after we're done here, only the cool people will be left on the stream. Yeah, after we're done with this, only the coolest of the viewers will remain on the stream, so that we can we'll have the whole internet to ourselves. Let's see if this crashes. Yeah, it's a little close. Let's get 1 more millimeter out of there. Get a millimeter out of there. 39, 6, 3. Oh, one thing I haven't done here is back up the scripts off. Basically, I've never downloaded the scripts and configuration off the printer and backed it up. We should probably figure out how to do that before something terrible happens. That seems better. Yeah, that seems pretty good. Seems pretty solid. Yeah, so I'm just going to go around to the side of the printer and yeah, I'm gonna go around to the side of the printer and just move the brush up so that it contacts the nozzle. So, you know, the brush doesn't work very well if it doesn't actually touch the nozzle, you know? It's very advanced. It's very scientific. So let's unscrew these. I wanted to use thumb screws, but I couldn't find any long enough. There we go. Let's just make sure these are all nice and tight. Of course, we don't want to crack the acrylic. That would be uncool. And I'm going to bend this. Yeah, I'm going to bend that little loop down out of the way. That really should be a silicone wipe. This design uses a paper clip to knock the booger off. It should really be a silicone wipe. Either way, I don't really want to use it right now because the booger is going to fall directly on the spool of filament. Probably jam something. So yeah, I don't believe the bot can handle multiple commands in the same line. I think you have to ask them one at a time. So yeah, let's just make sure that we don't hear any. Let's listen in for any scary noises. Seems good to me. All right. I think we're in decent shape. Let's drop our tool off. Oh, beautiful. Oh, mwah! Bellissimo. Yeah, next thing to look at is our prime script. I don't think we've prime and purge. And these... Oh, it seems to have brush... Oh, this seems to be like... Oh, hang on a second. Folks can't see what I'm seeing. So it looks like the brush script is actually integrated into the prime script. So it's a good thing we checked this. So yeah, like you can see how manually like trying to set stuff for the different extruders is just going to spiral out of control. We have to remember to keep track of all these ourselves. Like, yeah, it's going to be a big pain. Anyways, let's open up the brush macro and just transfer the stuff. Transfer the stuff over. So here are brush in commands. Let's see, brush in, brush out. We'll get those here. All right. So then we want to park for prime and purge. Then we want to run out. So we want to adjust these the same. I guess we want to adjust these the same amount as we do with the other brush. I just don't want the two. I just want the tool to collide with. I guess they're all the same depth. So no. I was gonna say like I don't want the tool to collide with like the volcano extruder, the tool on the far right. But if it didn't collide in the left, it won't collide in the right because they're all at the same distance from the back. They have to be. It's otherwise changing tools. Actually, yeah, changing tools would be kind of obnoxious. Anyways, yeah, let's do this. So, let's see. So, what's the distance here between these two? So we've got 339 plus 32.5. Is that the distance we moved? Yeah, we moved 371 over from 32.5 to end up at 339. All right, so this is where 37.5 is. This is really far. No, this is really far over there. Minus 41, minus 37. So it's gonna be somewhere in the middle, right? Oh wait, that's the difference. 371.5 minus 37.5. All right, so we're gonna hang out at 334. Yeah, which is right in the middle. That seems right. 334. Okay. So for the prime, what do we got here? What's G? I don't even know what these commands are. G92 E0 is I think relative mode. I don't know. Let's learn. Yeah, learning. G92. Set position. So E0 is extruder. So setting extruder position. What does that mean? What is extruder position? I don't know a lot about G code. So we're G1. So we're going to extrude 10 millimeters at speed 200. Then we're going to go to 1. We're going to change the speed to 50. Yeah. Corvus 2606 says it resets the extruder. Beefing says, I like how things gets free advertising even when they aren't. I thought it was pretty funny. I thought it was pretty funny. No, we've already worked out they're going to sponsor next month. So it's too late. Haha. Seriously though, we're doing some fun stuff with things the next couple of months. Maybe a little more. Anyways, save. All right, so we can't test this without a hot nozzle. So Corvus 2606 says it's so you can't extrude too much if you're in relative mode. Let's check this out. Let's see what's going on here. Let's actually put this back. There we go. M114. Get current position. Causes it to report its current X, Y, and Z and E coordinates to the host. Could be interesting. Could come in handy. All right, let's. All right, we don't need this. We don't need to look at our brush script anymore. Let's pick up. There we go. Let's pick up the tool that we just put our cheapo purge filament in. Let's allow it to come up to temperature, and then we will test the prime script. In the meantime, let's take a look at our purge script. Oh God, we have to change these two. This also has all of our brush commands. All right, so this looks like the same, except it's just running out more filament, or this just squirts a whole bunch of filament. So yeah, all right. We need. So hopefully we got hopefully we got these brush commands right. Because yeah, if we hopefully we got these brush commands right. Because if we messed them up, it's going to affect 3 scripts. Yeah. So why is the brush in here longer? What's going on here? So this is going. So it looks like. All right, looks like we have to manually go back and adjust all of these as well. Douglas Spalato says, "Hey Zach, would you like to test a new polymer? It's called AT-PET and it's very impressive." Yeah, look, I mean, my every filament episode, I want to have every filament. So yeah, feel free to send a sample to my. Feel free to send a sample and some information to the mailbox. Here, allow me to type in mailbox. Come on, did it work? Why is... Keeper says, why do you have the brush in so many places? Can't import them. It cannot. RepRap G-code supports no variables at all. No variables, no constants, nothing. The G-code, from my understanding, cannot be altered at all. The closest we'd be able to do is make separate scripts for, like zigzag forwards, etc., and just invoke those scripts from within the other scripts, which, now that I'm thinking about it, was probably the smarter thing to do. Yen says, "I'm surprised how short the stream delay is." Yeah, we're trying out ultra low latency mode, which sadly does not allow Google to generate live captions, and we can't broadcast in 4K. Neither of those, I think, matter very much. Yeah. Colony says you should write a tool to compile the subscripts together into a master script. I don't have time for that, even if I could figure out how to do it. Yeah, I don't even have close to time for that. But yeah, I think we yeah. is there a pattern here? Why is our why is our soft keyboard covering the entire thing I'm trying to look at? So yeah, brush out. So this looks like the brush in is just brush out backwards, right? Minus, yeah, going from 155 to 154, minus 41, minus 32, minus 41, minus 32. Okay. Oh, yeah, we don't. Close the window I was working on. That was smart. What's going on here? Why did we freeze something? What's going on here? What's going on? There we are. Hopefully that doesn't happen again. Minus 41, minus 32. All right. So we want these minus 330 and minus 330.5, minus 339.5. All right. Minus 330.5 minus 339.5. Yeah. Yeah. Minus 330.5 minus. Oh wait. 339.5. Let's actually just copy this. Yeah, let's just copy this and paste it. Ain't nobody got time for this. Brush out. 339, that's replacing 32.5, so let's get that here. Yeah, I don't have a good enough sense for G-code to be able to guess what these do. So minus 38, minus 35. Minus 38 becomes this. Minus 35 is 336.5. Minus 38 is here. I guess I should have backed these scripts up, right? Because I was so careful about doing that in the... Colin Mills, thanks a lot for the $6.90. Nice again. I agree. Nice. I completely lost my train of thought. Minus 35.5 is this. 336. 35.5. 336. All right. Then we want to park and purge at minus 37.5. Do we have that? No. What did we decide this thing was? Was 371.5 is the difference? 371.5 minus 37.5. Let me tell you, this is beyond difficult to do while trying to hold a conversation. So please be patient for the next few seconds as we finish the job. There we go. All right. So it looks like. All right. So let's give this a shot. Let's see how this. See how this goes. All right. By now, we should be nice and hot. Let's see. Why didn't it heat up? Why did it forget that I wanted it to heat up? Let's heat this up, and then we will test the prime and purge commands, and just make sure that this actually can, in fact, scrape boogers off the nozzle. Yes, we're scraping boogers hardcore. I probably should have added in a bot command to let people know about Patreon. Yeah, you go to patreon.com/Zack Freedman to support the channel. I should probably also have shut off Backblaze before we started the stream, so it doesn't ruin anything. Let's see. Somebody has accused me of rolling in serious YouTuber dollars. Let's see. What's the context of this? Let's see. Hunter Carsaboom says, can't wait for the day when Zack gets a metal 3D printer and get a video on that. I can't think of any circumstances that would cause me to get a metal printer. They are not like... A metal 3D printer is not like a plastic printer, but metal. It's a piece of industrial equipment, right? It's a piece of industrial equipment. Like, even if I could afford it, and even if I had a use for it, and even if like I had a ventilation system installed for it, as far as I can tell, these machines are massive. So, as far as I can tell, these machines are ginormous, and the the Fab Lab is, or the Void Star Lab is only so large. Maybe in the far future, like, you know, when we are YouTube millionaires and we have our entire studio and staff and all that stuff, then we'll have room for things like metal printers and the budget to be able to run them. That's the other thing. Even if someone were to buy me a metal printer, the material is very expensive. Let's see, where are we at? We're 280 or 208. This machine heats up very quickly, and this isn't even one of the higher powered extruders. The water cooled one heats up in like that. That thing can go from 0 to 250 in like probably a minute, maybe 30 seconds. Not 30 seconds, probably a minute. It's so crazy. Goddamn, my dog says, wait, there is a way of working with variables and G-code. Depends on the flavor of the G-code interpreter. It is commands do exist, but I don't think most 3D printer firmwares support them. They are more of a thing for CNC machines, because you got to remember that, like, for CNC machines, tool changing is like a standard feature. Like, yeah, like hobbyist level CNC machines have chucks and collets and you yourself install the tools. But even a low-end commercial CNC can have a tool rack that changes automatically. So having code that runs conditionally is much more relevant for a CNC machine for the most part than it is for a 3D printer, from my understanding. For a laser cutter, you never, like, there's no point in that because you only ever have one tool, it's only ever doing one thing. So, yeah. Caleb Wright says, hey, have I heard that name before? Zack, if you wanted to get into a lab with laser cutter, CNC, and metalworking stuff, we can host you in Boulder for free. That'd be pretty neat, at least to check out. We are very limited on the tools we can use here. That would be pretty sick. Anyways, let's see, we're at 2:05, so let's run the script and see what goes wrong. Yeah, let's. So we want to run. Which are they? Prime and Purge. You're not gonna be able to. Like, I'd have to really readjust some cameras to see what's going on. So you're gonna have to do honor system on this one. But let's run this. Let's see what happens. M98. We're gonna do prime.g. All right. I'm gonna be ready to cut the power if something goes wrong. What happened? Is it supposed to squirt? Oh, hey, it's squirting! It's squirting! Oh, it kind of worked. It dropped a gigantic booger. It dropped a gigantic glob of filament onto the spool of filament directly under it. But apart from that, this seems to have worked. Yeah, let's move, hang on a second. Yeah, I'm going to go back to here. We're going to move the X over. Oh, we homed the X. Oh no! Oh, I keep doing that. I keep hitting home instead of move. Now I have to go back over here, and I have to unlock the coupler and home it manually, because the fan is so big that it causes it to home the x-axis wrong. I know. Eventually, like, hopefully we get some printing done, right? It's part of the fun. All right, let's move. What's going on here? Why is our movement G-code not working anymore? Let me put this back. What's going on here? Why can't we? Oh, it is working. It's just moving at 1/10 speed. All right, I'm dumb. We're gonna do M220 S100. All right, this could take a bit. I think I may have tried to move this like 200 millimeters at like 1 millimeter per second. Whoopsie! I'm just going to cut the power and we'll start over. I don't mean like start over like. There we go. All right. Yeah, it would have taken forever to run all those G codes. I don't mean like start over. I mean like we'll just restart the machine. Because yeah, it's still saved all of our code. Don't worry. We don't have to rewrite any G code. But I think the I think the scripts are working pretty solid. I think our what did we do? We tried our did we try prime or purge? We tried prime. We probably want. Let's try purge. Let's set our extruder number 2 active temperature 205. Let's pick it up. Let's wait for. It should only take a few seconds to come up to temperature because it's already at 180. And then we will run purge P98 or M98. There we go. And we're going to run purge.g. But we have to wait for it to come up to temperature, or it's going to try to extrude filament that isn't when the nozzle isn't hot enough. I don't think it has any sort of protection. So, yeah. Anyways. Oh, we have a maker studio right here in Westminster. Is there? Because that's got to be new. Otherwise, I feel like I would have known about that. Alexander Thompson's is hyped for Prusa XL. I don't really get that jazzed about large form factor printers. Although, it is also a Core XY printer. Is this Prusa's first Core XY? I think it's going to be interesting. I don't have any interest in a large printer, because if anything, I think we want to try to move smaller. But it's definitely a Core XY is always interesting. I'm really liking this form factor. Or this drive system. I don't even know what you call it. Anyways, I really like it. Okay, we're hot. Let's run this. So we should extrude a bit. Yep. And pull it back. Oh, that's really. Alright, so it scrubs it back and forth. Alright, we're shifted a little over to the left. Pardon if you saw my butt. We're shifted a little over to the left, but I think that's fine. One thing that's bothering me is the brush thing, the brush holder has like a little circle in it, right? It's a ring. It's obviously supposed to hold something. And it keeps moving over there and extruding. Like, that's why it's parking in a specific position. Now, I'm wondering if there's like a cup or something that we're supposed to install there to catch the filament. Let's quickly go over to E3D's site. Not the Dozuki, because apparently that's not actually the canonical instructions. Here we go. Let's see. Which I know that for some, I know that the brush is in the wrong instruction. There's no. Like, it's in one of the instructions, it doesn't make a tremendous amount of sense for it to be, and I don't remember which one it is. Is it in commissioning? No, it looks like it's already installed. Maybe it's in the wiring section. Is that it? Brush? No. Wiring is in the. What happened? Why did that happen? Maybe it is in the spool holder section. Let's see. Brush. Yep, there we go. It is in the spool holder section. Has the brush in it. So it's not calling for anything. I don't know what the little ring in there is for. You see that right there? This guy right here. I don't know if that's supposed to like it looks like it's supposed to hold like a little cup or a little like some sort of something to contain the filament. At the very least, like, maybe I'll just grab a piece of tape and I'll seal the bottom of it up. Maybe that'll be good enough. Everything's gonna go wrong. There we go. Let's grab a little duct tape. If a blade of kittens here, here's your daily duck. Your daily dose of duck. Let's move our extruder over. And let's just install little bit of tape down here. There we go. I think that'll work for now. I just don't want any globs of filament. Don't want any globs of purged filament making a big mess on our printing filament. Okay, so hopefully we've got our brush and our purge. Hopefully we've got our brush and purge and prime scripts ready to roll. So next thing to do is we're going to go back to our, there we go, here, I think it's free. Yeah, we're going to go back to our free scripts, and we're going to uncomment the purge line because we want it to now purge whenever it picks up a tool. And, yeah, let's see. Let's see, free. Of course, this is going to cause problems if the tool wasn't preheated. There we go. So I hope this works. I hope this works properly. We have to make sure. Yeah, we gotta. It could be things could get weird if we pick up a tool without preheating it first. So we'll have to be mindful of that. I wish it was possible to add in switch statements and stuff. Yeah. Maybe if we switch that firmware everyone wanted me to switch to. Like hell, I'm rewriting all these for Clipper. Get lost. Yeah. I'm thinking what else do we want to do? I don't think there's anything left to do. We could try. I think we should first try doing a multi-material print before we start messing with any calibration. Just as a diagnostic, just to get an idea of how much we have to fix. Don't want to fix problems until you know what they are. So let's. Oh crap! What just happened? Oh man, that went completely to hell. Why did that happen? Why did that just happen? So I went to switch the tools, or I went to put the tool back, and it crashed into the side of the print. It crashed into the printer on the, it went to brush, crashed into the side, and then when it returned the tool, it missed. So something has gone wrong here. I wonder if at some point we switched between absolute coordinates and maybe we switched between absolute coordinates and relative coordinates and we didn't switch back, perhaps. Let's take a quick look here. So let's see what could these have any effect? No, this G92, could that be it? I don't think so. G92. Sorry, that really threw me for a loop. Allows programming of a 0 point by resetting the current position of value specified. So it's probably not this. What about purge? Is there any funny stuff going on purge? I don't think so. What's G4? What is that one doing? G4. Dwell. What does that do? Pause the machine for a period of time. And pause for 4 seconds here, but not in purge, but not in prime. Let's take a look at brush. Any funny stuff? No? Just drop in the bed. So something screwed the coordinates up. Did it lose track of the homing? Is that possible? What happened here? Yeah. Sean said he rehomed the x-axis last time he moved it. I thought we removed the tool and I rehomed it. We shut it off and back on. We picked the tool up. Hello World says you need to level the bed. That is certainly not what's going wrong here. Corvus2606 says, did you home after powering off? Yes. The firmware doesn't allow any movement commands to run at all unless it's homed. So let's see. Did I home it with the tool on? Oh, well then it wouldn't have homed in the. Then it would have crashed when it homed Z, and it would have dropped the tool when it homed C. Alex says, I got the stream on in the background and nearly got a panic attack from the sounds. I know. I know. Okay, we don't have a tool. We don't have a tool picked up yet. Let's do this. Let's do this again. See what happens. Let's pick up the tool. It should try to prime it now, or it's gonna wait for it to come up to temperature first. Ooh, I think I worried a little too much about that. Richard Brooks says you homed with the tool on, so the position is wrong. Huh. Oh, then that was my oh, all right. I guess it was my mistake. It shouldn't. Then how did it home the Z-axis? It should have, when it homed Z, it should have just crashed into the plate and started grinding, and bent my X-axis and cracked the plate and all of that. But we'll see. Yeah, let's see what happened. Let's see what happens. Did I only homed X? Well, yeah, but the problem. Oh, did I only home X? James Schultz says the firmware is prevented from extruding while cold. Yeah, I didn't realize this. That if you pick up the tool and it has to come up to temperature, then it'll wait. So I guess right now it's paused between commands. Right? Shouldn't it home? Or shouldn't it be priming? All right. Well, let's. Here's what I will do then. Let's just move this over. I'm just moving this so that it has some room to travel when we return it. So let's see if it crashes now. Let's return it. Brush it off. And now it should return. Huh. It seems like a weird. Why is it priming before it returns, or before it stows it? That seems weird? That seems weird. No, the problem was definitely that I homed the X-axis with a tool in it. That was definitely the problem. I think I must have got sidetracked partway through and forgot. So yeah, let's. Yeah. All right. So we should have everything we need to try to do a multi-material print. Here's the second challenge. I don't know where to find a multi-material. I don't know how to get a multi-material STL. How do I? Yeah. How do I do that? Yeah. Where does one get a multi-material STL? How does that even work? Confined. I don't know what to look for. So with things, I don't actually think this will be very easy. I don't actually think this will be very easy to find on things, because things doesn't render. Things only renders, I think, step files in color, in different colors. And as far as I can tell, there's no way for it to search by meta print. Like, you can't search by metadata on a print. Like, I don't think I could search for a project with an STL file that has multi-materials. Multi-material slice is multicolor. Andrew King says, Google is your friend, don't kill me. I literally Googled. Like, I'm here on Cult 3D because I Googled. If you're going to be condescending, at least have the decency to, like, find something to be condescending about. I'm joking. I appreciate all the comments. Yeah, I appreciate all the comments. There's a multi-material benchy. Yeah, do we want to? I'm not sure I want to spend 2.5 hours though. I was hoping something, an animal ring. Oh, you can make a ring with a little pair of bunny ears on it. That's what I'm gravitating towards because it's fast enough. I'm joking about the Google thing. I hope I didn't actually. Hope you're not actually taking that. Oh, that's kind of neat. Make a little. Oh, it seems like. I don't think that's what this is supposed to look like. This doesn't look a lot like a multicolored fidget star. I think this looks more like a pile of multicolored spaghetti. Oh no. This person is having It seems like this particular model is a lot harder to print than the people who are printing it seem to think they are. Akelia, thank you so much for the super chat. Print Luby's Foxy, melanistic fox model. I don't want to tie up the printer too much, but let's at least take a look at that. See if that's on. Let's see if that's on Colts. Otherwise, in the meantime, let's open up Yegi because Yegi takes ages to load. Let's look. Yeah, let's see if there's. Is this it? Dot to the Lock says you can do another keycap. I could do it. Yeah, I suppose there could be a keycap. We got a cookie cutter. I don't know which of these is which, but it's probably going to take too long. I'm thinking we go for the ring, because the detail on that is on the XY plane, so that will give us an idea of they'll give us an idea of our offsets. It'll make it easier to see if basically like if the different colors are at a different height. Then we have to adjust our Z. You know, if there's a gap on one side, whenever two filament colors join each other, if there's a gap on one, like left side but not the right, then our X is off. Something of the sort. So I think this is the way to go. At least it didn't try to charge me for it. Colts. Alright, let's do this. Is it working? Is it downloading? Why isn't it downloading? See, this is why it's so easy to. This is why I am taking things money. All right, let's do this. Extract to the files, and let's see what we got. So we've got STL files. Let's see. We want the bunny one. Is this broken up into multiple pieces? Enigma, thank you so much for the super chat. Hello, Mr. Freedman. Take my money. With gusto. So, alright. So it looks like what's going on here is that... Here, let me open... Actually, maximize the wrong thing. Oh, jeez. Alright, so let's open this up with Super Slicer, because that's what we're going to be using. I hope this doesn't cause too much trouble. So, here, let's zoom in using my Space Mouse. Why is the Space Mouse moving so slowly? Why is nothing working today? Why is my Space Mouse so slow? What's going on here? Why is the Space Mouse so slow? This is at maximum speed. Why is this so slow? Alright, so it looks like they separated out the colors. So the different colored elements are actually different STL files. So I think you're supposed to just print them simultaneously. I'm gathering that's what we're supposed to do. We're supposed to just print them simultaneously. And, like, I guess they are supposed to, like overlap or something? So, is this really how multi-material prints work? You just, like, make each color its own thing and just print them, make its own STL and just print them together? It seems kind of jank. Anyways, I think that's what we got. We align them, we set up slice protocols, and slice them together. So, yeah. So now the question is, can we figure out, like, what'll happen? Like, can we set our extruders properly? Let's see. So we want this one. So, yeah, let's see what happens. This might work, this might not. Extruder 2 and extruder 3. Alright, so this worked. Because I know I set the, let's see, in filament settings, or I think in print settings, like I hard-coded in like specific extruders to use, but it doesn't seem to have taken effect. So yeah, 3D view looks, alright. This looks pretty cool. I think it basically this basically fits. I think we could move the. Let's see. I think we could move the ears over a tiny bit. Maybe like call this 150. Yeah, that looks pretty lined up. Is this possible? It's 110? No. 109? No. It's 109.5. Yep. Yeah, so I was right. Okay. Cool. So, yeah, we're going to have a brim on this because it's very thin. We want to go to our printer settings, and I just want to take a look at our custom G code. Because, let's see, mesh leveling, our tools are preheated. So after layer change, do we want to brush? No, we don't want to brush after a layer change. I think our layer, so I think this is done automatically. Alright, so when we switch tools, it's automatically purging and brushing. So I don't think we need, so for a tool change custom G code, I don't think we have to brush it. I think that's done for us. So, yeah. Crystal Wombat Plays, thank you so much for the very generous super chat. New subscriber and stream viewer was off sick today due to my second COVID shot, so I sat and watched your video on printing all the benchies. Glad you enjoyed and glad you're here. We will be starting at least one benchy today. I think this has been taking too long, so I don't know if we're going to finish any, but hey, I really appreciate it, and I'm glad you're getting vaccinated. Yeah, the second one hurt more at the beginning, but I got over it sooner. I don't think it was the shots that hurt that much for me. I think it was more that like I slept at a weird angle because my arm hurt and it made my back hurt. So yeah, I think this could work. So let's slice it. And why is it printing the brim in material number 2? Does that matter? Does it? Yeah. Does that make a difference? So what's this look like from the different layers? Oh wait, hang on a second. I'm using the wrong. So starting it all printing in material number 2. So it's going to be a different color at the bottom. It's a little weird. I don't think it'll make a huge difference though. I don't think that'll make a tremendous difference. So yeah. So this is only. It says only 10 minutes, so we'll know pretty quickly if things are going wrong. So. Yeah, let's give this a shot. Let's give this a shot. Let's see what's going wrong. Let's see what goes wrong this time. All right. So we also have to make sure that it heats up both nozzles, not just one. Let's see what happens. We're gonna go to downloads. And because that's where I'm storing all my sliced G code. All right, let's see what happens. So let's make sure it's heating up both of these. Yep, looks like it's preheating both. I wrote that in myself before I would pick up a tool and then heat it up. Yeah, if you haven't been vaccinated, you totally should. You totally should. The new Delta COVID is extremely transmissible among unvaccinated people, and it seems to be not very transmissible in among vaccinated people. Like I think here in the States, somewhere between 97 and 99% of people in the ICU with COVID symptoms have not been vaccinated. So I would strongly recommend it. Granted, your body, your business. Feel free to die, But I don't know. If you're gonna put your life in jeopardy, I feel like you should be doing it on something like skydiving, or I don't know, throwing a pie at Vladimir Putin, something of the sort. All right, let's see what happens. So it's still coming up to temperature. We're at 170 out of 180. Yep. Go up to a cup, branching a banana. Something spicier. Yeah. Although I've been accused of being I've been accused of being a liberal, and if you don't get your vaccine and then you get COVID and end up in the ICU, you will have owned me. So it's a calculated risk. So let's see. We're bringing this up to 215. Why is the temperature is all weird? Hang on a sec. Yeah. All right. I think this is going to happen. It's up to temperature. Oh, it's bringing the bed up. All right, the bed's hot. What's it waiting for? What's going on here? Nothing's happening. What the hell? Why? This isn't something I expected to happen. Oh, wait. Things are happening. Was it like waiting for the temperature to stabilize, maybe? Why didn't it, it was supposed to purge. There's a giant booger on it. What the hell? Well, now I realize this angle is terrible. I stubbed my toe. Let's get a little bit. Let's get a little bit higher. This is Colorado, after all. A mile above sea level. Yeah, Colorado, the opposite of the Dead Sea. And since we're zoomed in, our aperture is now effectively smaller. So yeah. All right. I think this is good. Yeah. Anyways, yeah. Everyone who has been vaccinated, thank you very much. You will never know how many. Unfortunately, preventing something means you never know what the results are. But like, how many people are? I know I said I wasn't going to check analytics, but what's going on here? I know I said I wasn't going to check analytics, but I want to check really quick. This is important. We have 331 people. So yeah, 331 people in chat. It's pretty safe to say that at least one person in this chat right now who is vaccinated. If you hadn't been vaccinated, someone would have died. I feel like it's fairly safe to say. All right, here we go. We're brushed. All right, we're brushing. We're squirting out a little bit of plastic. We're going to brush again. Hopefully it stashes the tool properly and picks up the other one. All right. Is it priming properly? What's going on here? Oh, is it waiting for it to come back up to temperature? Is that what's going on here? Oh man. Wait a second. All right, so something's wrong here. Yeah, something's wrong. This is gonna fail. It's not priming properly. So at some point when it picked up the tool, it should have primed it and then brushed it off. This is gonna come out wrong because there's gonna be no material in the nozzle when it starts printing. So yeah, why did that happen? Yeah. Why did that happen? Yeah, see, it's brushing when it's returning the tool, but shouldn't it be brushing when it's picking up the tool? At least the tool changing and stuff is good. Huh. Yeah, this is pretty interesting. I don't know, like maybe it's not someone in the chat right now has saved someone, but like there have been let's see, we've had thousands of people in total have viewed this stream. So odds are at least one person would have infected someone, and that person could have infected, who knows how many people. So, because that's the thing, you're not like, if you keep someone else from getting sick, you're not just keeping one person from getting sick. You're keeping all the people who you would have got sick from getting sick. So, yeah. If you don't believe me, just play Plague Inc. Anyways, the tool changing part is working very well. Unfortunately, it's the scripts. And by the way, like, I didn't write these scripts. These all came with the printer. So unless I'm misunderstanding something, it seems like this is exactly what's doing right now is what we don't want it to do. Right? Like, what it's doing right now is going directly from the rack to the printer. And what we don't want, that's what we don't want it to do, because it's going to have like a booger of filament that's drooping off of the nozzle. So, I wonder what happened here. My best guess is some jabroni. My best guess is some jabroni put the purge and clean script in the drop off the tool script instead of in the pick up the tool script. So yeah, let's head back over to my machine and take a look at that. This is not in focus. There we go. So in the meantime, luckily this is a pretty low stakes print. It should only take a few minutes. Let's see. Jonathan Marshall says, can we talk less COVID and more 3D printed guns? I think our country has plenty of guns. I think we should be making things that there aren't enough of in this country, like Quagsires and boats. We need more boats. Yeah, America needs just far more boats. We have a real boat crisis here. There's not enough boats on our streets. All right, let's take a look at our macros. So, yeah, all right. So let's see. So we've got the T3. That's when we're picking up the tool. Yeah. So it's purging when it's picking up the tool, right? But like, why isn't it? It's picking up the tool and it's. I'm really confused here because why isn't this working? Am I just being an idiot here? So yeah, all the people whose anti-vax comments are automatically hidden are like, yeah. Jay Carter says, "What's jabroni mean? A jabroni's a putz. A jabroni's a schmo." Yeah. Why? Look, this is not how this is supposed to work. I'm really confused now. Pre and post? Called after tool 1 has been selected. Called when tool 1 is freed. Oh, did I mix these up? Does free mean releasing the tool and not picking it up? I thought it was when it was. Wait, I think that's our problem right here. Yeah. I think. Yeah, this is exactly what's wrong. I mixed up what the different scripts did. Why is this one called part? 0, 1, 2. Oh, cannot delete it because it's open. Oh, so this is actually updating live. Oh, that's pretty neat. Ah, that's pretty interesting. Kalia says, Zack, count from 0, not 1, if using tools 1 and 2, not 2 and 3. They're both correct because they're both correct internally. Internally on the firmware, it numbers the tools. So in G-code, it numbers the tools from 0 to 3. In the slicer, it numbers the tools from 1 to 4. So I'm trying to keep track of which ones I'm referring to, but switching between the two numbering systems is tricky. Yeah, an upside. Jacob says, by the way, have you seen the upside down portable 3D printer? Upside down printer. Is that 3D printer skill shots? 3D printer trick shots. Huh. All right. So, yeah, we want to So we want to cut the purge stuff from the free scripts, right? And we want to add it to the pre-scripts. Right? Yeah. Pre or post? Called after the tool. Alright, so this is... Check. So this is where we were supposed to have deleted it. Alright. This is where we're supposed to have deleted it. From the post scripts, not from the free scripts. None of this is documented anywhere. I have no idea how anyone figures this stuff out, besides for pure trial and error. It's like Linux command line utilities. Like, I keep seeing flags that are just not in the man page, and I'm like, how the hell? Like, how the hell does anyone figure out how to use tar? How the hell does anyone figure out what? Like, just to unzip a regular ass file, you need like 4 different flags and like 2 parameters. 2 of those flags have capital letters. And I swear 2 of them are not in the man page. I have no idea how people figure out how to do this stuff. I'm just going to take a quick look. It's actually looking pretty decent. This is actually looking alright. We'll see how those... the real question is the top... Like, it looks like the X and Y is actually pretty on point. The real proof in the pudding here is going to be the surface. Hopefully the white and gray areas both have an equally level surface. But if one of them has drag marks and the other doesn't, then that means our z-axis is off. But it looks like our X and Y are actually dead on, which is great. Another thing we want this to let's see, we're wasting a lot of time. Let's see. I think this might be my fault. The reason why we're wasting so much time coming up and down in temperature is because I think I accidentally when I was switching the filaments before, I think I might have hard set this to 215 Celsius, which is overriding what it says in the G code. That's another thing. I have no idea what manual commands override stuff in G code. For instance, like here, check this out. If we we definitely don't want this to go 2,000 degrees. So yeah, if I were to drag the slider, right, and change the power of the part cooling fan, it's immediately going to switch back when another command gets run. But I switch this, right, to, I switch this, the active temperature of tool number 2 before we even started printing, and now it's overriding everything that's in the printer. Yeah, what the heck. Yeah. Nicholas Marshall says, we need to install Linux onto Zack. I mean, I think that would work fine for the first 20 minutes until, one day I wake up and, I can't see anymore because, one of the, I can't see anymore because overnight it updated, a Python library, and that somehow caused a dependency issue with my eyesight drivers. Yeah. Christopher says you bricked it, Zach. I certainly did not brick it. I think this is working fine. Mike Misak said, I haven't seen every episode of Building This. Where'd you buy the components for connecting the tool heads, or was it a kit? It's all a kit. It's all a kit. The stuff I added was... let's see... So I added the monitor and the Raspberry Pi and stuff. I added the enclosure, the hood over it, the doors in front. I added those. There's there are a bit of electronics here and there that I added. But on the whole, it comes as a kit. You just buy all the parts. You do have to 3D print parts. It's a bit like the Voron in that respect. They only send you the non-printed components. In order to make this 3D printer, you already need to have a 3D printer. This is, as far as I can tell, the worst 3D printer to try to get as your first printer. Mindspeed 200 says the beauty of Linux is it only updates when you want it to. I mean, it's beautiful if you're a pen tester or a hacker, because if something doesn't update automatically, it's safe to assume that outside of the most savvy companies, no one's going to update it. I am rigorous about updating all my stuff all the time, and it is basically impossible to get all these Raspberry Pis to continuously update themselves. There's just so many gotchas and corner cases and other things that like make it harder for them to update themselves. But yeah, I think that's, on the whole, it's a downside. I think people are irresponsible. Yeah, it's more important. It is worth breaking the usability of a product if it also improves the security of the product. That's a problem. It's an intrinsic problem with Linux. Windows has actually been very good about this. I've been using Windows now for around 5. I've been using it on and off for about 7 years, but I've been using it heavily for about 3 or 4. And only a single time have I ever had anything break after an update. And I apply every update on Patch Tuesday. So I'm actually really impressed by it. Yeah. Beefing says, what Zack just said is he loves Apple and thinks they're perfect. No, Apple has problems. Apple, especially now, has problems. Apple makes a lot of smart decisions, and they make a lot of stupid decisions. They make a lot of decisions, period. So this thing should have, let me just see here. The time estimates for this are off because SuperSlicer has no idea of how long it takes to switch extruders. So I realized that its estimate is going to be way off because it has there's no possible way for SuperSlicer to know how long it takes to switch. Veldorg says, Apple, we make decisions. They do. Apple is very bold when it comes to and this is a neutral statement. Apple is very bold when it comes to changing things about their products, and I say that because it's for better and for worse. One thing that I think they're making. All right, there's a difference here. Updating and code signing, right? Updating and code signing should be enabled by default, and they should continuously try to switch themselves back on. But you should be able to override it on a per. You should be able to override it on a per program basis, basically. And this has become a real problem on Apple or on Mac OS because they now require code signing for kernel extensions, and even by default, they require code signing on shell scripts, and it's very difficult to do that because each individual command line utility you have to manually, while it's running, you have to run it, right? You have to run it. Running it will fail, and then before you run anything else. Oh, wait, it finished. Let this cool down so we can pop it off. Yeah, so before you run anything else, you have to go to the security center, type in your password every time. Manually, go over to the security center, type in your password, click, I want to allow this to run, or you click, this was blocked. Okay, I want to allow this to run. Are you sure? Yes. And you have to type your password in a second time. So if you run a shell script that invokes 20 command line utilities, you have to type in your password 40 times. And they've turned that off altogether for kernel extensions. Mac OS, it's Mac OS now. They don't call it OS 10. Mac OS will no longer run unsigned kernel extensions, which is basically I can no longer use a Mac anymore. Before, I was still using my Windows PC for gaming and my Mac for work. But now I need unsigned kernel extensions because not everyone who implements a custom libUSB driver is going to get their code signed with Apple. Yeah. And the way Teensy Duino has to be installed now on Mac is bonkers because Apple now they not only. All right, so it gets worse. Not only does Apple require code signing, and you can bypass that, but it also calculates parity, or it also calculates integrity of all programs, and you can't override that. So if you modify the Arduino installation using something like Teensy Duino, Apple, Mac OS, no longer runs it at all. It'll just say this program has been tampered with, and there's no way to override it. And I think that's going too far. I understand with the code signing part. It's not something you want users to be able to defeat easily because a hacker, someone social engineering them will just walk them through it. So, like if they're saying, if the computer's saying, yeah, this is unsafe, like maybe the first time the hacker can convince, the social engineer can convince them to just, oh, don't worry about that, it says that for everything. But the fourth time they're like, this is a little sus. But yeah, you do need the ability to say, like, yeah, I'm a professional. Like, yeah, you should have the ability to say, I'm a professional. This is what I do for a living. Like, I know what I'm doing. Hell, make this something you have to uninstall the operating system for. Like, make this a flag that you have to set while you encrypt your hard drive or something. I don't know. Anyways, let's take a look at our bun. I don't want none unless you got buns, hun. All right. So let's see. So this is our very first multi-material print. Come on, where is it? And you can see the gray and the white parts actually line up very well. Let me hold this up to the light here. They actually line up almost perfectly. And the z-axis, I mean, I think this is homed a little too close, because you see the ridges? Let me see if I can... Yeah, you see the ridges? I wish I could manually focus this camera. Let's try this. Let's try doing it over here. Alright, so you can see the ridges. There we go. That shows that we are homed a little too low. And yeah, our backside is discolored because it did something weird with the brim. But yeah, apart from that, like, I can't push these pieces apart. So they seem to be fused together. Let's see how close I can zoom in. There we go. This looks pretty solid. Honestly, this is pretty good. Let's get this back where it's supposed to go. Excellent. Yeah, when it comes to anyways, just to wrap that up, when it comes to security, yeah, users must be protected from themselves. And even you, remember, you are not like, and I'm saying this you to everyone here, you can be social engineered. You can be scammed. There is a scam that out there. Every person has a scam that will get them. Sooner or later, someone will get you. Or, like, yeah, no one is that smart. So, and sometimes, you'll make a mistake. Like, maybe, I don't know, maybe you'll open up, I don't know, you'll expose your computer to SSH on the open web for, like, 10 minutes so that you can, like, log in and check a print or something. But then you forget to switch it off afterwards. Like, things happen. Juan Rodriguez says, I got scammed into building a Chromance. Yes. Error Raider says the signatures rely on the cloud. There's a death sentence for future runnability. I don't actually think so. I think the code integrity checks are downloaded to the machine. I think they're downloaded locally. I don't actually think this needs it. Like, I don't think programs have to be reactivated. I don't think this is a giant problem either, because 99% of the time, right, a new program that you're installing, you're downloading it off the internet. It's pretty rare that you're going to be installing a program from a flash drive without an internet connection. So I don't think it's actually that much of a problem. And remember, like, you can't... Which is more likely, right? You having to run a critical program... Which is more likely, you having to run a critical program and not being able to because code signing doesn't work in the field and you don't have an internet connection you installed off a flash drive, or your mother like installing an app that a friend recommended on Facebook that is keylogging all their passwords. Like, which of them is more likely? It's a rhetorical question. It's the second one. Mom, if you're listening, you guys have to watch out for scams. People fall for scams all the time. No one is... Yeah. Anyways, I think we've ranted about this enough. Let's... Jake Carter says, have you ever programmed anything and realized how easy it is to make mistakes? Yeah, and on top of that, you have software like the Linux kernel that's been... People have been working on that and testing it for decades. Friggin' Bash, right? The literal command line. The thing used by basically everyone who runs Linux for decades had a ridiculous bug that allowed anyone to log into anything just by typing commands, but just by typing letters with a keyboard in the username and password prompt, and that was there for decades. And that was a piece of software that everyone used all the time. Yes, mistakes happen constantly. Can't trust you. Even people who do things, even people who want to do all the right things, are still the only people. So yeah, be careful out there. Yeah. So this, what do you? Yeah, the heartbleed bug in SSL as well. That one, friggin' every website updating. When both those bugs happened, or they were revealed at about the same time, and I had to update a ton of embedded Linux devices that I did not intend to update, and it was a total nightmare. I basically had to spend more or less a week manually logging into boxes and devices and just updating everything I'd ever built to get rid of the heartbleed and shell shock vulnerabilities. Yeah. Janrumpf says no system is unhackable. You can only keep patching. On top of that, nope. On top of that, the people are always going to be the weakest link. No matter how weak the system is, the people are always going to be the weakest link. You could have the sturdiest door mounted on an indestructible wall with the greatest lock, and all someone has to do is put the key, the key on the molding over the door, and your entire security is busted. Anyways, I think we need to update our to-do list because we have successfully printed multi-material. This is it. This is the first multi-material print I have ever printed. Yeah, isn't that neat? I do use the word hacking, cracking. I use the words hacking, cracking, and security interchangeably because I think people people who actually do that. I generally try to use the terminology that the experts do. So, this is an X. All right. So what should we do next? Do we want to do a dissolving supports, perhaps? Now that we know that multi-material works, should we try to do that? I don't think we're actually going to be able to print PEEK. Pardon. I think we might have to strike the high temperature filament because I think we might have to strike the high temperature filament here because it's dawned on me that I tried to dehydrate it with our dehydrator, but that's not even close to hot enough. We're gonna have to buy a convection oven, like a convection toaster oven, to dry it out because I'm pretty sure I actually have to bring it to 200 Celsius to dry. I'm pretty sure I have to bring it over 100 Celsius to drive moisture off of the PEEK. So I don't think we're going to be able to do that. Jacob, thank you so much for the Polish. Anyways, thanks so much for the very generous super chat. Did you design the 3D printer or buy it? It's 90% off the shelf. I didn't buy it. It was provided by E3D. But this is 90% stock, and I added bits and pieces to it. Yeah, this is the whole reason. Colin Carnell says, "Isn't that the whole reason I got this printer?" That is correct. It doesn't change the physics of driving moisture out of filament. Yeah, I mean, look, it's part of printing. Part of using exotic stuff is that you. Look, all right, fine. You want me to admit it? I'll admit it. I'm unprepared and I'm sloppy. I ran with part of doing exotic stuff is you make assumptions that have always applied but now don't. For instance, that a dehydrator can dehydrate filament, and I forgot that a dehydrator won't dehydrate this. I need a toaster oven, and I can't just throw it in the toaster oven because the toaster oven will melt the spool, so I need to figure out what to do to spool the filament. So, yeah, I guess Beefing it says, why not YOLO it, maybe it still works. I guess we always could. I mean, I guess we could just, try to run some PEEK through this. I was thinking of doing a multi-material. Powder Sim says, can you just stick it in the regular oven in the kitchen? No, we don't have a convection oven. You can't. just throw you need the air circulating through the filament, or it's only going to drive moisture out of the outer layers of the filament. Yeah. Duram says you don't need that high temperature to dry PEEK. Food dehydrators overnight work perfectly. Give it a shot. Jake Carter says put it under vacuum for a bit. I can't pull a vacuum. Yeah. H4 says maybe there's a metal spool from the big metal box from the start of the stream. I don't actually think there's a metal spool inside the Stratasys filament. I think because like when I was poking around in there to rotate it, I had a I think it's got some sort of like fiberglass like spool or something. Yeah, I think that could work. Let's think for a second here. How do we want to do this? It seems like folks really want to see some high temperature filaments. I think our best choice here, because I was thinking of going directly from multi-material to support filaments, but if all you cool people want to see high temperature filaments, then I think the best thing to do is to figure out which of the filaments that we have don't need to be dehydrated, which of them aren't hygroscopic. So let's do that. I think it's our best option. So I believe nearly all the high temperature filaments I have are made by 3DX Tech. So let's start at their website, 3dxtech.com. I'm fairly sure. So let's look for a high temperature plastic that is not hygroscopic, and we'll see if we have it. Let's try to zoom in a little bit. ESDPTG PA6. I don't think I have that. Let's see. OBC. I got to get some OBC. We don't have that. PPE. We got PEEK. PEEK takes on water like a sponge. Also, look how expensive these are. These are crazy. Oh, it's got materials on the side. I'm dumb. Alrighty, let's see. I've got PPE. I don't know if. Let me check. Let me see if. Let me just take a quick look. Survey the stuff. We got PEEK. We got PPSU. We got. That's not high temperature at all. It's total opposite. We've got some PSU. We got PPS. All right. A lot of different materials here. So yeah, let's see. PPE, is that it? Polyphenylene ether. I don't even know what this is. Do I have this? I might. I do want to try to get all of them. All right, so this has to be dried. PVDF is a support filament, I think. Yeah. Oh no, this is the fluorinated stuff. Drying not required. All right. I do have. It's not this exact brand, but I do have a PVDF filament. I didn't know Kynar was PVDF. Kynar is often used as insulation for ultra fine wires and like wire wrapping wires because it's quite strong even when it's very thin. Don't need a heated chamber. Don't need drying specs, or there's no drying specs, so that's neat. Let's keep that one open in the background. PPS. I'm learning about these materials for the first time too. So this has to be dried 110 Celsius. Jesus. Right. Let's see. PPS. Polyphenylene sulfide. This also has to be dried. PSU. We got some of that. This has to be dried at 120 Celsius. Jesus. PSU we just checked. Oh, I'm dumb. PPSU, we have some of that too. This is PPSU is, hang on a sec, what's going on here? Stratasys compatible. I wonder what that entails. Thermax PPSU, I think we have this as well. This has to be dried at 120 Celsius. It's crazy. We don't have PEI. The PEI I think was too expensive to send over. PEEK and PEEK both take they both take on water like a sponge. So I think PVDF is our boy. Let me go rustle that up. Where is this? Polymax PCFR, Tribo Plus.
did I? Did we Polymax, Labrick, Graphene? Let's see. There's still. I might not have spooled it up yet. PA glass filled. I should probably bring all these out. Let's bring these out. Let's hunt this down. Let's see. The PVDF I have is Fluorodur brand, made by I think Filament. So I don't remember if I put that away. These are the Fibrology filaments that we just got. This is PAGF. This is glass-filled nylon. We've got their Fiberflex, which is pretty interesting. This is Fiber Silk, which is supposed to be like a silk filament, so it's shiny, but it's supposed to be much stronger. They claim to have fixed the problems. Here's PCTG, which a lot of people are saying is the best material ever, but it's really hard to find. It's really hard to find. So let's see, we got Filaflex, PLA with minerals in it. Alright, so it's not here. I don't remember. I think I put it away, but I don't really remember. What's this? This is carbon fiber PEEK. This is Laywood biofilament linen cast. Let's see. Cast PA. It's pretty neat. Holman T-line ESD TPU. Yep, it exists. Colorfab Varioshore. Alright, so I must have spooled it up already. Give me a sec, I'll hunt this down. Where did I put it? Xfil Piva 3DX Stat, Reflectaway, Graphene PLA, Aramid, Lay Foam, Protopasta, Lay Felt, PSU. Where did I put it? What the hell? Did I lose a filament? I'm sure I bought this, and I'm sure I spooled this up. Maybe I just didn't label it? What the hell? I seem to have lost the filament. Yeah, there are a lot of filaments in here. It's a lot easier than it sounds to do that. Yeah, there are a lot of filaments here. Crap. I guess like we could just try running like some PEEK or something and just see what happens. Final 303, PCFR, Easy Wood. Yeah, I don't remember where I put it. Biofill linen, graphene PLA, 3DX stat, AF80. I figured it would be here. Tribo Plus, non-oiling AF80. Where's Fluorodur? Did it fall off the wall? I don't think it fell off the wall. There's a spool missing. I don't know what happened to it though. Why did I pull a spool off? Oh, wait a second. We got here. PLX3 Polysupport Arnitel. Arnitel IT 2060 HT? I have no idea where this filament went. I definitely had it. That's really weird. I lost a filament. Okay, change of plans. What is this? This is Arnitel HT. So Cordy says, do you have any health concerns when it comes to printing some of these materials? The new materials for the new video are actually much safer than many of the ones I printed for the last video. The only one that should be... the only one that should off-gas anything nasty is the vinyl. It's PVC filament, and that'll off-gas chlorine and just completely suck. So for that, we're gonna have a special ventilation system hooked up. But for the other ones, we shouldn't really have any trouble. And thanks a lot for the super chat. It's very generous. I really appreciate it. I'm just trying to figure out what to do here. How, where, why, how, who, what. All right. So let's see. We also have Polymax PCFR. It's flame-resistant polycarbonate. That's sort of high temperature, but it's not the same. 3x stat. Look, I guess we could just start running some PEEK. I guess we could just start running this and see what happens. Yeah. What do you say? Are we just gonna run some PEEK and see what happens? So this is PEEK Filament, the most notorious of all the high temperature filaments. Resists chemicals, resists wear, resists strain, resists radiation, just all kinds of crazy stuff. Look, let's try some PEEK, right? Let's give it a shot. Let's give it a shot. I'm gonna have to go over here because we need to do some messing around with the printer. So yeah, we want to print this. The first thing we have to do is mess around with the limits on our print. This isn't a kilo of PEEK. It's just spooled up really loosely. I think it's around 200 grams, which is still a tremendous amount of. That's still a lot of PEEK. It's not cheap stuff. It's actually quite expensive. We could do weed whacker filament, although I don't think that'll work. I think we're going to want to dehydrate that for a few days first. I'm not going to be able to stop myself looking all over for the Florida man. Alright, well, we tried. Okay, so, let's see. Let's see what we got here. Active temperatures. Alright, we're gonna let's look this up. 3DX Tech PEEK. I have to look up the printing parameters because they are nuts. They are crazy. It's going to take a while to heat up the enclosure as well. I think we need to bring the enclosure to 100 Celsius, which the bed should do a fairly good job of. We got to be the PEEK has piqued everyone's interest, says Brock. We'll give this a shot. It says dried 120 Celsius for 4 hours. We certainly have not done that. What does this mean? Supports breakaway support. Oh, we do actually have some high temperature support material, although I don't want to use it yet. Alright, so let's check this out. Extruder temperature 375 to 410 Celsius. So let's go back here. We need to be able to actually load this. So let's add 375 to our active temperatures and add 375 to our standby temperatures. I know, right? Bed temperatures. All right. So what did this say? This said 130 to 145. So what do you think? Should we? We'll start at 130, and if it doesn't stick, we'll set it higher. So we'll add 130. The bed can actually go to 200 Celsius. So Master Machetier says, Jesus, what printer do you have that supports those temperatures? This is an E3D tool changer, and we're going to be using the Titan Aqua extruder, which is a liquid-cooled extruder. And that's important. Chamber temperature, we don't have a sensor for that, so it doesn't matter. All right. I thought there was something to set in like a maximum temperature. Tool temperatures, bed temperatures. Let's see. Yeah, I thought there was something here. Let me just think for a second. I wish I had a thermometer that we could throw in there. I had this, but we ran out of. I had this, but the batteries were dead, and the store was selling replacement coin cells for like $6 each. So screw that. But yeah. Okay, let's do this. Maybe, although now I'm thinking about it, maybe we should maybe we should do our homework first. Like maybe we should read up a little about it. Maybe technical data sheet. Is that what we want? Oh, this is all its physical properties. It does have information. Okay, 0.4 millimeter nozzle, 0.25 layer height. All right, they recommend 100% infill at up to 45 degrees. 100% infill. I don't think we're going to do that. Extrusion temperature 380 to 400. Bed temperature 130 to 140. Craziness. All right, we're gonna have to make a profile. Let's, you know what? We're zooming everything in. I'm just gonna increase the density. Display density. What do we got? All right, let's increase the size of all the stuff. Yeah, let's increase the size of all the stuff so that everyone can see what's going on. And yeah, there we go. All right. So I guess we could try to print the bunny as our first print. I mean, we could try to go straight to doing a Benchy. I don't think it's going to work though. I think we probably want something small. This filament's very expensive. So let's try doing the Benchy. We're going to delete one of the colors. We're going to switch this over to extruder 1. Extruder 1's the Titan. I hope this works. I haven't run any filament through this extruder yet, and I think like it is all metal. I don't think it'll burn, but I don't know. All right, so let's do a little reading up first. Yeah, let's see how to print PEEK. I have done a little bit of research, but I just want to make sure before we crank anything up to 400 Celsius. I just want to double check. To 3D print PEEK with let's see. The crystallization process must be controlled. Part of the material will crystallize, changing the density of the material. Therefore, high temperature levels, extruder build plate enclosure must be maintained, and fluctuations in temperature must be avoided. To 3D print PEEK, you need a 3D printer with an extruder that can reach 400 Celsius, a chamber heated to 120, and a build plate that can heat to 230 to remove the part and avoid warping. That's not what they said on the other site. Let's see. Do they have a guide here? We do have the nanopolymer. We're doing this properly. Low toxic gas emissions. Excellent. That is something I want. We don't need a special nozzle. Questions and support? No. I guess we're on our own. FAQ, perhaps? Do we make our own filaments? Let's see. I bet Vision Miner did a video on this. Yeah, there we go. Vision Miner specializes in high temperature printing. So the adhesive we're going to use is actually theirs. Yeah. They're moisture sensitive materials. It's vital to keep away from moisture before and during printing. Shh! Don't tell the filament. Simply apply nanopolymer to smooth glass. Allow 30 seconds to evaporate, and then print. Alright, so we're definitely gonna want to do that. Preheat the build plate and chamber temperatures to 160 and 90 for at least 30 minutes before bed leveling or printing. Jeez. Alright, I think that's let's see. Do we want to alright. Smooth glass. Okay. So let's alright. So let's pull the plate off. Right now there's glue on it. We obviously can't have that because the glue is going to burn. Let's see. Where's our control panel? Here it is. All right. So we're gonna scrape all the glue off. Get that out of here. So we're going to scrape off all the glue. We're going to apply some of the nanopolymer adhesive. And I guess then we will allow this thing to start preheating. Our little Swiss clips, that's what they're called. Let's see. Let's get our PEEK Pikachu. Oh, these filament holders are the worst. Renee was right. All right. We're gonna try to print some PEEK, and we're probably gonna mess it all up. Let's see. I guess in the meantime, do we want to try to preheat the enclosure? Let's get this glue out of here. This is just water. All right, here we go. Marvin Huth says, engage buzzword glue. What's a buzzword? I don't get it. Dot to the Lock says, a hardened steel nozzle works fine unless you're printing crazy abrasive stuff. What nozzle do I have in here? Let me see. I think I have a 0.5 millimeter nozzle X, which now that I'm thinking about it, we need to confirm that the nozzle X will actually work. We need to confirm that the nozzle X will actually work at the temperatures that we're going to bring this to, because it has a polymer coating on it, and that polymer coating could burn off. So we may have to change our nozzle out. Yeah. I'm just want to give this thing a nice thorough scrub. I'm gonna scrub it a few times. I don't want any of this. I don't want any PVA to burn. Bonzi X says, get one of those ruby nozzles. Both of the I think both of the printers, two of the printers in there, two of the printers in the printer closet are have Olsen Ruby nozzles. They're pretty solid. Yeah, pretty solid. We don't want brass at. I don't think we want brass at such a high temperature, right? I'm not sure brass will hold. Or is it? I think steel will lose its temper. Yeah. No. Chris Girard says nozzle X max temp is 450 Celsius. All right, so we're good. I forgot. I missed the name, but someone recommended that we switch off the part cooling fan. We are certainly going to do that because Titan Aqua does not have a part cooling fan. It doesn't need one, so we're not using it. You may ask, why? Why does the Nozzle X, why does the Titan Aqua not need a part cooling fan? And that's because we're only planning on using the Titan Aqua in a heated chamber. And when the chamber is heated, there is no value in having a part cooling fan. Because all it's going to do is blow hot air over the part. Probably, if anything, make things worse. So yeah, the Titan Aqua does not have a part cooling fan. In fact, doesn't have a hot end cooling fan either. Instead, it's got a liquid cooling system that carries the heat outside the printer, so we can like a radiator can vent it into the air. And that's because, again, like the printer, like the nozzle, the extruder itself is going to overheat at 400 Celsius. That's, yeah, the amount of heat that'll make its way into the stepper motor is enough to destroy it. Remember that, like, I solder, right? Like, I solder at like 325 Celsius or something. So this filament actually melts at a higher temperature than solder. So yeah, the heat can't make its way back to the stepper, so the liquid cooling system is going to bring the heat outside of the enclosure. And yeah, there we go. I seem to have been left with one extra clip. Who knows? All right. So we've got that. Now it's time to apply our adhesive. Let's move this guy over here. Try to get a good view of the proceedings, because I'm going to be blocking the overhead camera. So this stuff is Vision Minor nanopolymer adhesive, high temperature glue. This isn't This is like, so when you're using something like PVA, right? Like when you're using something like glue stick, you're not really gluing the thing to the plate, right? Really, all it's doing is providing a layer so that you can get it off. This is gluing it to the plate. If we forget about the print after it's done, it'll crack the plate. We have to remove it while it's still hot. Shake well. Ensure build plate's clean. Apply a liberal coating and allow it to dry. So let's give this a shake. In the meantime, I have to find that brush so that I can actually apply it. I forget where I put the brush. I really should have left the brush with the stuff that the brush is for, shouldn't I? That would have been real smart. I should probably also look up how to clean it off the brush. I'm guessing alcohol. Let's see. The brush in here. No matter how hard I try, I just can never seem to be organized enough. Alright, so we gotta get, it was just like a nylon bristle brush. So, let's see, maybe I put it in with the, let's see, it's a nylon bristle brush, so I'll just use one of these ESD safe brushes. It's basically the same thing. Alright. Let's do this. Apply this liberally. Let's brush it around. I'm only going to treat the center because we're not planning on doing a very large print. We could try a Benchy if we feel ambitious. Alright. There we go. This smells like pure ass. I'm going to put some, use some alcohol to wash off the brush before this starts congealing. Alright, and we want to leave that cooking for a while. Let's, while we're here, I'm going to move the build plate back up so that I can load in our PEEK. Now, I'm not 100% confident on this because again, this PEEK is probably pretty waterlogged, but we'll see. If we hear this is also a test of our system, right? Because I've never run anything this hot, so this is also a test to see what's going to go wrong. So I'm going to feed in the PEEK. Oh man. This guide tube probably has like $50 of PEEK in it right now. Alright, and it came through. Alright. So we need to remove all the stuff from here and close it. Or no, we wanna get our filament in there, huh? Alright, here's another question. This thing is fitted with a sock. And I just realized this. Yeah, this is fitted with a sock, and this doesn't need a sock. No, I was going to say, like, is the sock going to get damaged? But it doesn't matter. Like, it doesn't need a sock. There's no air. There's nothing blowing on it. So I'm just going to pull the sock straight off. Come on, sock. Get off. Yeah, there's sock. Yep, yank it straight off. All right, let's load our filament. Ready to see what the worst that'll happen. Yeah. I am sketched. I don't know. I hope this doesn't destroy. I hope this doesn't destroy the printer. Let's see. So, all right. We're going to let's see. Let's pick up nozzle. Let's pick up tool 0. This is the liquid cooled tool. While we're waiting, let's get our bed preheating to. Oh, we must have to reload this. Backspace. Let's get our bed preheating to 150, and let's get our nozzle heating to around, should we do like around 400? 380? Let's do 380. Let's see, error G10, requested temperature out of range.
Corvus says make sure you take the other filaments out so you don't melt them.
Oh, that's a good point. We do have filaments in here that are in danger. Brooke has come in and reminded me. Corvus says take out the other filaments so we don't melt them. That is an excellent point. Yeah, that is a good point. So we could heat these up and remove them, or we could just cut them. I think it's smarter, better use of our time just to cut them. So let's do that. I'm just gonna snip the filaments on our other three. Yeah, because at the very least it's gonna damage the. At the very least it's gonna damage the spools, and let's spool these back up. Put them away. Well, we did multi-material printing. I'm pretty proud of myself. Because a lot of those scripts I set up ahead of time. Yeah, these filament holders are a real problem. Gotta do something about that. All right, so let's save our filament. Took out the Freedman Galaxy. Let's do the Fusion Filaments color purge next. Oh man, I can see why so few people use these high temperature engineering filaments. This is silly. We have to protect the printer and everything in it from itself. A lot like users and running unsigned code, I guess. Remember, friends don't let friends run unsigned code. I'm joking. I'm sure people here at least know what they're. I'm sure people listening to this chat at least know what they're getting into when they're running unsigned code. All right, we've got the filaments out of there. Our plate is ridiculously hot. How's our nozzle doing? Okay, so we have to change our limits. That's what I thought that was a setting, but now that I'm thinking about it, it's probably in our configuration script. So yeah, okay, it's probably in our config script. So let's open that up, and let's see. Our configuration files. This is nope. It doesn't matter if you know my Wi-Fi password. I guess like you could drive to my place, and then you'd be able to get on the network that all of our IoT stuff is on. So I guess I'll blur that out. Apply custom drive mapping. Yeah. Where's our temperature? Set temperature limit for heater 0 to 255. No, we don't want that. Heater 0 is the bed. All right, we won't. Yeah, 225 is fine. Temperature limit for. Let's see. Temperature limit for heater 1 to not 300. We want 450. Because believe it or not, PEEK is not the hottest material we're printing. So we also want to run this command. Yeah, M1. So yeah, we also want to run this. So let's do so right now. There we go. We've changed our maximum temperature to 450. Yeah. The other ones I think will stop at 305. They're all four of these are all metal hot ends, but there's a lot more plastic pieces near the extruder, like near the nozzle on the other extruders. All right, so let's save this. We don't want to restart to apply it, but we do want to preheat to 380 Celsius. Please don't do this on a regular printer. Please don't do this on a regular printer. All right, I'm just making sure that that liquid is still circulating. Let's see. Oh wait, I should probably put this back on here. All right. Make sure the liquid. Let's see. confirm the liquid is circulating. Let's see, you can see right there, right here, is the radiator and fan. So we should see that fan turn on. The fan should have turned on by now. What's going on here? Why didn't the fan turn on? Let's see, that's not good. Huh. Alright, I'm going to, let's abort. Alright, I am going to close, no, we'll just let the heat out as soon as, alright. So our fan hasn't turned on. Maybe something, yep, something got unplugged. While I was moving this around, sorry if you saw any unmentionables. While I was moving this around, I seem to have unplugged the fan. So let's get that plugged back in. Oh, yep, we're good. All right, never mind. It was just unplugged. Backspace 380. All right, so let's bring this up to temperature. Let's move the bed out of the way. All right, so our radiator is radiating. Doesn't feel much warmer, but you know this is liquid cooling, so it takes a while for the liquid itself to come. You know, it has very high specific heat, so it takes a while for the liquid itself to start coming up to temperature. So let's go over to our dashboard here. Move this out of the way. All right. We're at 380 Celsius. Time for the moment of truth. Oh man, it is hot in here. All right, I have to release the tension on the drive gear, so I'm definitely gonna need a glove. Definitely gonna need a glove for this. Cordy said, "Thanks so much for the super chat. We got a fire extinguisher on standby." You know, I never ended up buying that fire extinguisher. I kept forgetting. We'll throw some cups of water on it. I'm sure it'll be fine. Alright, why am I having a hard time feeding this? Oh, there we go. Alright, it's feeding. We're seeing something. Is it smoke or is it steam? That is the question. This is steam. So yeah, this filament's waterlogged. Yeah, this filament's waterlogged, so this is going to give us some trouble. Still, we've loaded up. We've loaded up PEEK. Yeah, we've loaded up our high temperature filament. It does indeed seem to be extruding. I'm not seeing any smoke. We're not smelling any electrical fires or anything like that. So the system seems to be holding up. Let's turn back to. Let's see. Let's turn back to our control panel because yeah, just verify here. Where are our graphs? Oh, they're only visible. Oh, that's stupid. Let's see. So, see our temperature graph? It is holding its temperature steady. This has been fitted with a PT100 I don't need this anymore. This has been fitted with a PT100 thermistor, so it should be able to measure temperatures far in excess of, far in excess of a regular, basically the way this works is a thermistor and RTD changes. It's a resistor that changes resistance depending on how hot it is. The hotter it is, lower the resistance. So that means that each one has a practical limit to how hot of a temperature it can reach, or it can read. Because once something is a dead short, there's no diff. It doesn't matter how hot you get; it's still a dead short. Or, yeah. So we need to upgrade to a different thermistor, which need a different front end. So this thing's actually been pretty thoroughly upgraded. Let's turn our attention. Let's turn on a little window here. There we go. All right. So yeah, big question is how hot is it inside the chamber? Because we probably don't want to start printing until it's quite hot in there, and it's going to take a while. I don't have anything to measure the temperature. The only thing that we've got some stuff heating it up in there. The plan was to throw a dehumidifier in the enclosure, but that's kind of a last resort. So temperature, I guess we could pull it out of the 3D printer closet. I probably should have grabbed one. See, I have a temperature probe from. You know what? Let's just wait around for a few minutes, and we'll just wait for a few minutes for the heat from the bed to start making its way up into the enclosure. Yeah. Hopefully hopefully nothing will warp. All the extruders, all the extruders and all the load bearing parts are made of annealed carbon fiber nylon, so they should be pretty tough even at a hot temperature. Mitsuo Level, thank you so much for the super chat. Are you going to redo the hot in 3D parts in PEEK at some point? That's a good question. I don't know if I have enough. At the very least, I'd like to redo the ducts and the stuff that's close to the hot ends. But I'm not sure I have enough to actually rebuild a large part of the system. It's very expensive stuff. So, yeah, like, this spool of PEEK that I just loaded in here is probably like, it's probably $150 maybe. So, yeah. I'm really feeling it. Says, what else is in the bed chamber that might get damaged? Any of the wire, rubber covers, or crimps, or electronics? Nothing should be that... Nothing close to the heat should be damaged. Nothing is that close to the hot end. Remember, it's only 400 degrees at the hot end. It's going to be hopefully around 180 degrees in the rest of the system. And that should be safe for everything. I don't want to run anything else, right? Like, I don't want to run anything else if I can avoid it. But, it shouldn't cause permanent damage to any of the other things. Although, look, we'll find out, right? It's part of the fun. Another bite of Pop-Tart. All right. In the meantime, we can try to connect the Viper to the internet. That's another thing on the to-do list. We can also load up a less spicy filament on one of these machines. Yeah, we can try to load up a less spicy filament on one of these machines. I'm going to leave this camera here pointed at the tool changer because if something catches fire, I want all of you to see it. Yeah, let's try to get the Viper going while we're waiting. I think it's 111. I think that's its IP address. There we go. All right. So it says it's connected. Let's see if that's actually the case. Oh, I can't see it. Door's in the way. It's getting hot in this room. Oh man, this printer's throwing off a whole lot of heat. So let's see if we can see if the Viper is working. I've literally done nothing except just connect this thing to Octoprint. Oh, it's working! Holy crap! Yeah, it's using Marlin. I think it's using Marlin. Yeah. yeah, I didn't know, like, this Viper is actually, it's actually pretty sick. Yeah, it was sponsored, so yeah, my opinion is going to be, is going to be compromised. But the more I use it, honestly, the more I like it. Oh, there you go. I'll admit, I used it first because they paid me. But it's pretty sick. You know, it's pre-fitted with a volcano. Like, right out of the box, it's a volcano hot end. I wonder if I can turn the light on. How do I do that? How could I turn the light on? Maybe here. Maybe if I use the touchscreen to turn the headlight on the Viper, it will make a response. It will send a response to the serial terminal. So let's give that a little look-see. Tools, light. Okay. Let's see. Anything? No. Damn. I really want to be able to turn the headlight on. Oh, hey, we got ourselves a super chat. Going on here. Chris George, thank you so much for the very, very generous super chat. I really appreciate it. Thanks for being a badass, trying this so we don't have to. Yeah, I mean, but come on, like, using a water-cooled 3D printer, like, yeah, this is the Anycubic Viper. Using a water-cooled 3D printer to run off filaments so hot that temperature would cause other filaments to, like, catch on fire. I think that's great. Fred Cook says, have you ever considered doing a full Voron build? A lot of people want me to build one. Right now, I think I have enough printers. And I just finished building a very complex XY, or Core XY machine. But a lot of folks want it. I think it's more of a printer. It seems that the best use case for a Voron is to print really fast, and I know that sounds like it's my thing, but you start to get diminishing returns and it increases the amount of work you have to do. So at some point I probably will, but no plans as of right now. So yeah, what should we... Alright, so that was... I expected the Viper to put up more of a fight, so I'm actually a little disappointed right now. Let's, what do you say we run some filament through it? Let's, what do you say we do a little benchy boy? Brooks says, even Voron wants it. They gave me a super chat that one. That is true. They did actually show up to one of the E3D Tool Changer streams, and they super chatted me, which I thought was pretty neat. And it was funny because, like, I didn't know who the hell they were, right? Like, literally never heard of the printer before. So I didn't know who they were. So they gave me some super chat, and everyone was losing their minds. And I was like, what am I missing here? What loop am I out of? All right, so let's print some filament. What do we want? We try reflectolay. Ooh, how about mold lay? How about some wax filament? Master Machetier says, can you do a flex filament in there? I know I said you can't print flex filament through a Bowden, and I'm sure people want me to eat my words. I mean, I guess we could try running a flex filament. It's kind of an awkward layout, though, because it takes... it takes in filament from the left side. And, hang on 1 sec, I gotta get hydrated. 1 sec. So the Viper takes in filament from the left side, and that puts the filament intake under a shelf. So, yes, I mean, it's not a problem. I don't think it's usually a problem, but with flex filament, that means it has to make a couple angles. So, I don't think flex is the smartest thing to do, but let's take a look at this mold lay. I want to, yeah, I think that's a good one to start with. Mold lay printing settings. I think that could be a good one to try. Where is it? Yeah, so mold lay is a wax filament for casting. And the guy who designs this stuff is a friggin' genius. And this actually does two things. First, you can use it as a what do you call it? Like for lost plastic casting. Like you can basically do lost wax casting with it. You can cast into it and it burns out with no ash. but it also it has a very slick surface, so you can use it to make a mold that you cast like silicone or like you cast silicone into it, you can cast resin into it, all kinds of stuff like that. So yeah, it lets you print molds for both permanent shaping and lost wax. It's very cool. It's very stiff at room temperature, but becomes extrudable at 170 to 180. Designed by renowned German developer of 3D printing filaments, Kai Parthy. Seems like a pretty clever dude. Molds should be treated at 270. A kitchen oven can work. Oh, that's pretty cool. Yes, this is pretty sick. So, yeah, where are printing settings? Usage tips, specs, usage tips. Print with a hotbed at 40 Celsius. The nozzle temperature can range between... This is a very cool filament. Once printed, you surround the piece with clay or concrete to harden. This will melt the mold lay inside the concrete and flow out as hot paraffin wax. This is the Englishest I have seen in a long time. Yeah, let's see. Yeah, that's pretty cool. You can always be some clay or concrete attached to the metal object. It can be removed by immersing the object in citric acid for a few hours. Oh, because it reacts with the gypsum or whatever. That's pretty neat. Okay, so it looks like we're going to print as normal, except we just have to drop our temperatures way down. So, yeah. What do you say? Let's go straight to a Benchy. 3D Benchy. Why? Why you guys do me like this? I'm so... Why? That's not what I want. 3D Benchy. Alright, so we're going to open this up with... we're going to use Prusa Slicer for this, I think. That's another thing. I've never actually printed to the Viper using Prusa Slicer. Let me check the temperature of our... That's feeling pretty hot. I think before we get too deep into this, Dagwin asks, does Zack answer normal chats? I do, but like I can't constantly look back at chat, or we're gonna get through even less. We're gonna get through even less stuff. Okay. So it seems like our printer's getting pretty hot. I don't think it's like now I'm thinking about it, I don't think it's like it's hot, but it's not like scorching. So let's try to get this one underway before we get too deep into high temperature printing. So with this right here, let's see, we got the Viper. So we're going to add we have to create a printer profile for this. So we're going to call this the Squirt Viper, because that's what it is. And this is based on the Anycubic Viper, which is in turn based on, like... Hang on a sec. Oh, I forgot something. I forgot something important here. The reason why I want to do this in the first place is that none other than Joel, the 3D printing nerd himself. E-steps are way off. Oh, I'm definitely not using that. Anyways, he sent me his Viper configuration. He sent me his Viper configuration for Prusa Slicer. So we were going to use that, but apparently his E-steps are a total mess. So never mind. Alright, so let's see. We're going to... So we stopped part way. I'm keeping I'm focusing on my nose here, because if something burns, that's how we're going to find out about it. So let's add a physical printer again. Let's call this one the Squirt Viper. This is going to be based on Anycubic Viper. Octoprint. Let's see. Where's our... So I need to grab an API key. Bear with me one sec. I'm going to do this in the other window, because I don't know what nasty stuff a person can do knowing an API key. All those things shouldn't be connected to the internet. Who knows? Let's see. Application keys. Let's grab this one here. Let's see. API key is here. So we're going to do I'll drag this over here. 2168111. There we go. Let's test, and we're good. All right, so we were in Anycubic Viper. The Vipe. All right, we're gonna start with the generic PLA setting. We'll try this at. Do we want to use support material? No, we'll print this unsupported. Do we want a brim? I think we want a brim. So we're gonna do that. We're gonna go to a filament settings. We're gonna change this to use a 40-degree bed. And what temperature the temperature we wanted to print this at was super low. Or that they recommend printing at is crazy low. 170 to 180. So let's give this a you saw nothing. Why did this happen? 100. So let's start at 180 and then go down to 170. Yeah. Cooling. I guess we want to cool it. I don't know. I mean, it's wax filament. I think it'd be pretty sick. Yeah, we're gonna print this in the Viper, not the tool changer. So let's go here. Yeah, I want to try to get a print going. The goal here is I want to get another print going while we wait for the Viper to come up to temperature, because we want the enclosure. We want the temperature inside the chamber to be about 160 Celsius or 150 Celsius, and that's what the build plate is at. So it's going to take a bit. So let's do this. So we're going to preheat this to 210 so that we can remove our PLA. We're going to need our purge filament again. Here we are. Why is it so dim in here? Oh, it's because we usually have the lights on one of these printers. Alright, so let's preheat. Actually, this is going to 190. I don't think we need to purge. I think we should be alright. Yeah. So here's the filament. We got our spool here that's been loaded with both lay foam and mold lay. And I just realized that I'm not sure this is going to ride properly on our filament holder. So, yeah. Let's see. Yeah, so this is our spool. This is our sort of like adjustable master spool, and it's not going to be able to. So I've got those rails up there with ball bearings on them, but this is not going to be able to ride on it. So instead, we're going to build one of these hooks. Yeah, we're going to build one of these hooks and use that to hold our filament. Hopefully that plays nice. What's the trick here? So this goes on like so. All right. So yeah, so we've got these hooks here that should let us hang it directly from the rail. So let's go here and here. Oh, it seems like we still have to clip off some zip ties. Don't worry, we are going to be printing before we know it. Oh, all right, we do have a little bit of room here. All right, so yeah, we got this little apparatus. So where's the end of our filament? It's a bit of a loose fit, so hopefully we don't get any knots. I feel like a knot would be fun because it's going to pull this off and possibly pull down the entire rail. But you know, we do what we can. So question is, where's the end? I can't find the end of the filament. I didn't tape this one down because it was all filament was held together with zip ties. So we got to trim those, but first I have to know where it ends so I can grab onto it. I have no idea where the end of this filament is. Come on. This is it's such a strange feeling filament because it's like a wax material. So it's here it is. Here it is. There we go. It's like a wax filament. So it's on one hand it feels very stiff and like hard to bend. On the other hand, it's very lightweight and very slick. Very slick to the touch. So I think there was only one zip tie. So yeah, let's load it. Let's load her in. Pull out our old filament. And out with the old, in with the new. I know there's I'm figuring out ways to put cameras in here. I know I keep saying I'll do it, but just haven't found good ways yet. Alright. Out we go. Yep, there we go. Doesn't feel much different than PLA, honestly. Yeah. Let's let's see. Settings. So I'm going to move. We don't want it to get that hot. All right. Okay. So yeah. Let's try this. Let's try slicing this for wax. Let's see what happens. Alrighty. So let's slice her on up. 3D Benchy. 1.5 hours. All right. A little faster than I expected. Anycubic Viper 0.2. Let's give it a shot. All right, it sent the file. It's starting to print. That z-axis is slow as heck. So yeah, let's we'll get that printing. We'll make sure the first layer or two go down all right, and then we will turn our attention back to our now presumably superheated tool changer. I'm really excited. So the filaments are running. This filament here is mold lay. Pardon me for talking with my mouth full. I just can't resist delicious Pop-Tarts. Yeah, this is mold lay. It's a material. It's a material designed for various mold making needs. So you can use it to do lost or investment casting. That's what I was thinking. You can use it to do investment casting, and you can use it to do to make molds. So it's like a wax. It's a wax-like filament. It's pretty cool. Let me take a look at how it's printing. So this is neat. Zack, it's very blobby. So the Viper only lets you change. It seems like the Viper only lets me change Z steps, right? It only lets me. The Viper only lets me do baby steps and like adjust the leveling height while it is running the print. So I guess this isn't the best. But anyways, it seems to be printing all right. So let's turn our attention back to this machine. Let's see how hot it is. Oh, that's hot. That's getting pretty toasty. It's getting pretty toasty. So yeah, let's open up our 3D Benchy. with Super Slicer. Oh boy, oh boy, oh boy. So from remembering right here, I think this is a point. Let's see, printer settings. Oh, hey, let's probably help if I showed you the friggin' screen. Extruder number 1, yeah, it's a 0.5 millimeter nozzle. So, yeah, we just have to remember doing that. All right, so with filament settings. All right, so we're going to take our PLA and take our PLA profile and change it. So, let's see, we want 380 for our extruder, right? Is that what we settled on? Let's check back here. Where's our peak? Here we go. Extrusion temperature 380 to 400. So let's go right in the middle. Super Slicer. Let's go 390. Man, it's so hot. It's getting noticeably hot in here. Bed temperature 130 to 140. So let's just start in the middle. 135, 135. All right. I don't know. Like, I think this just changes. I don't know why. I don't know what the purpose of that is. It doesn't seem to affect anything. All right, so we want a 0.25 millimeter layer height. We're not going to print this at 100% infill. That is ridiculous. That is straight ridiculous. So first layer height we'll do 0.2. Second we'll do 0.2. Second higher. 0.25. All right. Is there anything else we want to worry about here? We're not going to have any part cooling fan. Yeah, because there is no part cooling fan. So this straight doesn't matter. Do we need to slow this down? I think we probably want to. Let's see. We probably want to slow this down. Although, let's just open it up and see what happens. Let's see. Slicer on up. Everything's printing on extruder 1, which is actually extruder 0. Oh boy. Alright. Are you ready to try this? I gotta set up a pipeline to 3D Benchy PEEK. Gotta set up a pipeline to export directly from Super Slicer to this printer, and I have to unify everything from Prusa Slicer into Super Slicer. But alright, enough faffing about. Let's light this poop candle. 3D Benchy PEEK. I have no idea what's going to happen here. I have no idea what's going to happen. I think I'm going to just preemptively set this here. So I'm going to watch it. Why did I put... Oh, I have it... Oh, because it has... Oh, look, I'm smarter than myself. I knew I'd forget to drop the tool before I start printing, so I had the script drop the tool before it starts leveling. I am smarter than myself. Yeah. Now let's see if it burns the Z-axis switch. Doesn't seem like it. Let's see if the adhesive sticks the homing switch to the plate. Yeah, the Z-axis switch is actually way over. Like, E3D designed this knowing people would run off high temperature filaments in it. A lot of the parts on the tool changer component are over-specified, and I'm pretty sure all the belts are rated far higher than a few hundred Celsius. A couple hundred. Let's see. You can't even tell where the glue is, so that seems promising. While this thing prints, we should look up how to remove the print. And did it grab it? It didn't look like it grabbed it very, very well. But it is printing. Doesn't look like it has a very firm grip on it. Oh, it's not sticking at all. It's not sticking. Unfortunately, I think this is a bust. Oh no! There's the forceps. Yeah, it's not sticking. Dang. Thanks. Didn't stick. Dang. I did apply the glue, but you know, maybe I should have applied more of it. Yeah, maybe I should just apply some more. So let's grab our palette knife and remove the residue. Yeah, look at that, flaked right off. Right. So let's do that. Let's move the. Right. Let's move the tool changer back so I can access the middle of the plate. And yeah, let's apply some more adhesive. Oh man, hot as an oven in here. It said liberal. Oh man, it's like boiling. Doesn't get any more over the top than that, huh? Let's see. I'm thinking it's waterlogged. Yeah, let's heat up the 60. Yeah, so let's give this a few minutes for it to come back up to temperature, and yeah, we'll try it again. I'm thinking, yeah, I'm thinking. No, I don't think it's the glue's fault. I think that the filament is just too waterlogged. Okay, yeah, let's actually find the piece. And I panicked a little and chucked it, but if we can find the brim section that I ripped off, we might be able to get some ideas of what to improve. I kind of panicked a little and threw it. So, well, here, let's grab the part of the bottom layer. So let's go here. All right. So let's see. So it actually, I mean, the opaque parts are probably where water is boiling, but on the whole, it actually looks fairly clear. Yeah. Looks like we're leveled a little bit low. We could probably pull up a bit, but that shouldn't have anything to do with adhesion. I'm guessing that, I mean, maybe it's just not hot enough. You know? Could be that it's just not hot. Yeah. As for the it could be the chamber temperature isn't hot enough. That's also a possibility. While we're waiting, let's home the system again. Huh. Hey, look, you got to start somewhere. Yeah, look, maybe it could be that we just didn't use enough. We just didn't use enough of the stuff. Let's double check. Bed temperature is 130 to 145. That's what we set, right? Yeah, we were pretty careful to copy down their settings. Filament 135. So let's try upping this. Let's try going to 140. Yeah. While we're here, we might as well save this as PEEK All right. Let's take a look at our wax benchy while we're waiting. Wax benchy. Not the nicest looking benchy. The corners are having a lot of trouble. The corners are curling like crazy. I'm kind of surprised. The part cooling fan. Yeah, the Viper actually has 2-part cooling fans, so I'm surprised the corners are curling. But on the whole, it's looking like it's printing all right. I think I'm just gonna get like a USB. I think I'm just gonna do like a USB extender, like one of the powered repeaters, and just run that all the way from the computer over here around the room into the 3D printer closet. Yeah. I don't think it's so. As for the PEEK, I don't think it's a chamber temperature because I don't think it's a chamber temperature because that would cause layers to split apart. I don't think that would cause a first. It might cause a second or third layer to peel off because it would change its shape. Although now that I'm thinking about it, now I'm thinking about it, it was warping a little bit. So it could be that the temperature inside the enclosure is too cold. That might. I mean, that would have. I've never heard of that affecting the first. I never heard of the first layer curling though. That's something else. Oh man. I've never heard of the first layer curling. But yeah, what do you say we try again? What do you say? David Leal says, "Is the bed heated?" It should be. Yeah, we're hanging out at 160 Celsius. Yeah, I guess I'll grab some sort of temperature probe or something at the center of the micros after this, so we can keep an eye inside the chamber. Yeah, this printer isn't like this chamber is like the enclosure is like an aftermarket thing. Like I ordered that from Pinoco. Didn't come standard. It's pretty neat. I don't think it's a chamber temperature. Let's see. How long do we want to wait here? Let's just try it again. Yeah. What do you say? We'll just run the same G code. We'll just run it a second time. Let's go back to the status. That didn't sound healthy. Every once in a while, it just fails to detect the Y end stop. Every once in a while, it just like doesn't detect. So probe not triggered during probing move. Oh crap! All right, we got a problem. Yeah, something went wrong. So I emergency stopped it. Let's see. Yeah, something went wrong during homing. So let's go back to the dashboard. Let's drop the bed. Let's home it again. Yes, it knocked one of the clips off the. Like there's these little metal clips that are keeping the plate on. They're holding the plate down, and it knocked one of them off. And I think it's smarter just to leave it off because any inaccuracy in the leveling will matter less than losing all our hot air by opening the chamber. So let's try this again. Once more with feeling. Jobs, 3D Benchy and PEEK. There we go. I don't know what happened there. Still getting the hang of this printer. I just don't have enough experience with the low level like printer stuff. This machine gives you a tremendous amount of rope to hang yourself. At least we didn't snap off the homing switch. I did buy 5 replacements. Luckily, I haven't had to use any.
Beefing it says, really cool, but damn, is this the least reliable printer ever? I mean, it's not the printer, it's me, right? It's that I don't know how to use an advanced printer. It's not the printer, like, the printer is just, basically, like, this is why whenever someone says, I just want to get the cheapest printer on the market, I say, no, you don't. You want to get something like a Prusa where they already solved a lot of the problems for you. And this is why. Because this thing, none of the problems have been solved for me. All the stuff that I just take for granted, that's baked into something like a Prusa, I have to do myself here, and I'm not very good at it. But I'm learning. Still, and on top of that, like, there's things that could have been way worse. Some things could have been way worse with this. Like, nothing's caught on fire yet. Liquid cooling system hasn't leaked. The printer itself is working fine. That's the other thing. It's not the printer; it's the script. It's the script. Beefing it says, I feel like a printer being so advanced it's really hard to use is being pretty unreliable. But I guess it's okay. It's innovative and open source. I mean, it comes down to what the intention of the machine is. If the purpose of the machine is like, plug it in, if the purpose of the machine is like plug it in, push the button, load in some PLA, and just go to town, then no, it sucks at it. But if the purpose of it is to have a platform that can handle any material or any combination of materials, then it's our boy. All right, let's take a look. Come on. Stay put. Don't you friggin' peel. Don't do it. Don't peel. Don't peel. It's not peeling. I'm gonna raise the nozzle a little bit. I'm gonna baby step it. It's staying stuck. This stuff is working. This thing is staying put. Normally we'd be ending the stream soon, but I kind of want to see how far this thing can go. I'm guessing...
Your hair is blocking the print.
Oh, my hair is blocking the print! Oh no! Normally we'd end the stream fairly soon, but I want to see how far this goes. I'm guessing that the layers are going to split apart. I'm guessing that interlayer adhesion is going to suck because the chamber isn't heated properly, and this stuff is full of water. But, I don't know, like, at the very least, like, I want to see how far we can get. The surface is looking very lumpy. Yeah, the surface is looking a little on the lumpy side, so we're definitely over extruding. I'm gonna try to raise the platform to or we're trying to increase the Z offset, baby step it off to offset it, but we're definitely over extruding. It's probably I think it's a combination of just not having the E-step styled in properly, combined with combined with the filament foaming up in, like, as it comes out of the nozzle, because it's full of water. Well, this is going to be a pretty rough looking Benchy, but it's still staying attached. It's staying put. I'm try to raise it up a little higher. Still looks like it's digging in a bit. It's too far. Definitely over extruding. Alright, well, it's in God's hands now. It's in the one that rolls all the dice in the universe. Check it out. We got a first few layers. Let's focus. It's happening. I think I'm gonna try to get a better angle though. This is exciting stuff. We're printing at almost 400 Celsius. This stuff is printing twice as hot as PLA. Can we zoom in even further? Nope, that's as far as we go. Stuff is printing twice as hot. Alright, we got two prints going. One of them, the filament's at 390 Celsius. The other, it's printing at 170 Celsius. So we're on both extremes here. This spool is going to get destroyed. This spool is screwed. Yeah. The plastic spool this is on it's going to be warped to hell. Yeah, I did re-roll the filament. But thing to remember though is that PEEK is PEEK is I forget the name for it, but it remembers its shape. So it's really hard to you can't like wind it flat because it really wants to go in its specific direction. So yeah, the spool is a mess, but I was very careful to make sure it never overlapped. And yeah, if it snags, it'll pull itself off. It'll probably break the wall, like the side of the printer. So yeah, look, we gotta see. We gotta work with what we got. As AVE says, one must urinate using the anatomy provided. Let's see. I mean, it seems to be working. This is pretty crazy. It seems to be working. We'll see if we'll see if the spool falls off. I don't like these spool holders very much. But yeah. By the way, this is not the final spool the PEEK is going to be on. The reason why I didn't re-spool it at any point is because I initially... Alright, because we're going to have to dehydrate it, and that's probably going to destroy the spool. It's going to warp it and melt it. So I just assumed that the spool was going to be destroyed. So, yeah. Yeah, this is, the temperature that we're printing at right now is hotter than the temperature I solder at. I usually solder at 325-ish Celsius, and we were printing at 390. So this is hotter than solder. It rhymes. Ah, yes. The wax filament is looking pretty decent too. Let's see if we can. Yeah, I gotta figure something out to get footage in there. I dehydrate. Yeah, I've got the dehumidifier running full blast, keeping this whole place less than 20%. Ooh. Cohen Carnell says this printer can print metal as plug solder in. I thought about this. I thought of trying it as a joke. I don't think it could possibly work because solder wants to stick to metal. Like, it wants to stick to the hottest metal it can find. So, I don't think it'll leave the nozzle. I think it just won't leave. It'll just bolt. It'll like crawl up the side of the nozzle and just ruin everything. Let's check on this. Seems to be printing actually really well. The infill is having some trouble. I think it's moving too fast. But this is looking great. There isn't the tiniest bit of curling visible. Wow, way to go, Vision Miner. Alright. Huh. Might be my imagination, but, let's see. Juan Rodriguez asked, does the wax filament smell like a birthday candle? And it might be my imagination, but it kind of does. It's very faint, though. Very faint. And it might just be in my head, but it kind of does smell a little bit like a candle. Yeah. Pile of Stuff says, ceramic nozzle to print with solder. I just thought of something really stupid. Or really smart. Alright, what do we know is one material that solder doesn't want to stick to? What's the one thing that solder doesn't want to stick to? Anyone? Juan Rodriguez says my flesh, possible. Rhino says glass, not quite. I Ate Dead People says aluminum, also not quite. It's solder mask. It's the stuff you put on the circuit board to keep the solder from causing shorts. It's solder mask. Like the solder mask on the circuit board that keeps the solder from, that's the point of the solder mask, is solder doesn't stay put on solder mask. So we'll take a nozzle and we'll coat it in solder mask. I think this is the smartest thing I've ever thought of. Smartest thing I've ever thought of. I don't actually think it would work. I think Master Machetier is dead on. I think it'll melt. Although I suppose there's one way to find out, right? We could just set a soldering iron to, we could just put a soldering iron on. Oh, I heard a crackling sound, but it was just the filament getting pulled a little. Whew. Yeah. Adam Lesinski asks, what infill did I use on PEEK? I used the default. I think it was 7%. Maybe that was too little. Let's take a look here. Perimeters, slicing, infill. Infill's it's 15%. So yeah, we're on 15% infill. They recommended 100%. So yeah. Numantic says you'll literally end up with a giant solder ball. I'm worried about getting it into the extruder. But like, yeah, I mean, maybe nozzle X, maybe a nozzle X would work because that has some sort of ceramic coating on it. I think. We'd probably want to melt. We'd probably like want. What plate would you use for that? I mean, obviously you just print it right on the circuit board, right? Oh my god, that would be hysterical. Rigby S says it's like printing with a fluid. Yeah, but now that I think about it, like the thing that makes solder like do its thing is that it the temperatures at which it melts. It's basically the temperature at which it softens and the temperature at which it melts are basically the same. So as long as our part cooling fan is working properly, I don't know. It might be neat at the very least. Like maybe I could extrude solder onto some boards or something. I don't. I don't know. I don't know. Whatever it is, I'm probably not going to have time to do BS like that for this video. Wow, this Benchy's coming out really well. This Benchy is actually, like, working. This is crazy. I have to... I'm so skeptical. I have to go in for a closer look here. These layers are sticking together. This Benchy is working. What the hell? What the heck, folks? I'm actually going to start recording on this camera. Let's frame this up a bit better. I'm going to start recording because I don't believe it. I don't believe it. All right, let's do a time lapse capture frame every second. Actually, that's too much. 5 seconds. Boop. Yeah, we're actually going to record. Because I think this might actually be working here. This is crazy. Omar Juarez says recording is going to jinx it. Voidstar Lab is the most cursed hardware hacking workshop on Earth. We are already at 100% cursed status. If we were an Enter the Gungeon game, the friggin' Grim Reaper guy would be chasing us as soon as we drop into the first room. Yup. This is actually, I don't know. Juan is hinting at something pretty interesting here. I wonder if we could print a candle out of this and light it. See, I don't know if this is... They call it wax, but I don't know if it's really wax. I think it's just a plastic with properties similar to wax, because it wasn't like melting in my hands. I couldn't scrape it with a fingernail. But maybe I don't think paraffin is that flexible. Like I thought paraffin was brittle. Brooke probably knows more about this than I do, because Brooke likes the candle. DJ Programmer says, how much longer are you going to stream? Unless Brooke wants us to end earlier, I think we should go until this Benchy either finishes or fails. I want to see what happens here. Brooke says, I want cake. Well, let's see. First first thing I did when I got these filaments was I dehydrated all of them for about 2 days. Granted, it was only 165 Fahrenheit. I don't think it's very hot Celsius, but still. Alex, thank you so much for the ruble. A little bit of worthless currency to celebrate. Hey, I really appreciate it. Thank you so much for supporting Void Star Lab. Brooke says, can we get takeout for dinner? Why are you asking me that on stream? Anyways, one thing I should check is I should check that the radiator is hot. Not really. Yeah, one of the things I'm skeptical about is that the liquid cooling system is working. If I ever, I gotta get one of those. All right, for literally, hang on a second, let me count here. For literally 6 years, I have been waffling on whether to get an infrared, like one of those infrared camera things. For 6 years, I've been like, because I know the exact date because I was trying to debug a climate control system, device controlled controls boilers and stuff, and I was debugging it, and one of the standard tools that an HVAC tech uses these days is one of these infrared thermometers. So I borrowed his. It was a really nice high-end Fluke model, and we fixed the issue on the board in like 20 seconds because I just took a look at the board and I was like, oh, that thing is 180 degrees or something. Yeah, so I've been waffling on getting one, but their decent ones are so expensive. Like a good quality one is like $600 to $1,200 or something. Yeah, dudes, gents, ladies, cyborgs. I can't jinx anything here. We are already operating at maximum curse level. Everything that goes wrong, and Murphy is at least lulling us into a false sense of security. So I'm gonna enjoy it while it lasts here. Cheeseboy772 says, what kind of ghosts do filaments turn into after they die? A Benchy. Yeah, it seems as though our chat moderating bot is a little too sensitive to acronyms. I'll need to have some firm recommendation. I need to have some words with it. This thing is actually friggin' working though. I'm amazed how well the overhang is coming out. Because remember, like, this chamber is at least 100 Celsius, and there's no part cooling fan on this. It's not even like the part cooling fan is off. It doesn't have one. It doesn't even have like a hot end fan that might be blowing on it a little. This is just coming out of the nozzle at full blast, and that overhang, from where I can tell, looks almost perfect. So that is really impressive. That's really cool. JJ Inator says, use the clear OLED display in a HUD on some kind of helmet. I don't think that would make it easier to see. XNeem is actually using their brain and says, check the chamber temperature for the other tool head thermistors. You are so much smarter than I am. Yes, we have 3 other thermistors in there. Let's... smarter than I am. So these things are reading 45... They're reading in the mid-40s Celsius. So this thing could actually be a lot cooler than I thought. It's a little worrying, but it doesn't seem to be causing too much trouble with the print. Yeah, it doesn't seem to be causing too much trouble with the print. I don't know if it's the temperature of the chamber that matters, or just the speed at which the... I don't know. Like, now I'm thinking about it, I don't know if it's the temperature of the chamber or any drafts or breezes. On top of that, yeah, these are on the far end of it. But yeah, it seems reasonable. It's only seems reasonable. Looks like the wax filament's being pulled a little tight, so I'm gonna go in there and add some slack, loosen it up a little. It might be tied in a knot. Ah, there we go. This Benchy, apart from the bow on this Benchy, it's actually looking pretty good. This filament sags like crazy. I don't know what kind of crazy material science this guy Kai Parthy is on, but this filament is sagging and printing at 170 Celsius.
I don't know what this stuff is made of. I didn't even know there were plastics that melted at such a low temperature. Maybe it is just a spool of paraffin. Wouldn't that be wild? Xneem says chamber temperature greatly helps with layer adhesion. So that's why I'm keeping this thing going, because I want to see if the layers split apart. But we'll see. Yeah, like right now it seems to be. Let's see. It seems to be for the most part playing nice. Things are getting a little lumpy. Yeah, things are getting a little bit lumpy. We're definitely over extruding. I think that's going to cause more problems moving forward. I think the infill, we're also printing infill too hot. I'll cut that bit out of the time lapse. Something interesting that you can't see through the through this camera. Filament spool is still working. Yes, yes, Numantic is correct. One thing you can't see through the camera is that this filament is coming out of the nozzle clear, and then it's turning opaque as it sets. It's pretty cool. That's pretty sick. I imagine. Yeah, I think Ted Milker is right. Layers might start separating as you get out of the heat the bed is radiating. I think you're probably right. Like, we're sort of getting a free pass when we're close to the bed because like the heat the bed's heating the air. But as we get further and further away, the air will get less warm, and that might cause problems. But look, we'll chop till we drop. Designer's Mind, thank you so much for the super chat. Has anyone ever tried a part anti-cooling fan that blows hot air onto the previous layer to help with adhesion? I've never heard of anything like that. It's kind of interesting, isn't it? An anti-cooling fan. I don't know, it's actually kind of sick. It's actually pretty cool. This Omar Juarez asks, what printer are you using? Any suggestion for a first printer? This is the E3D tool changer. Certainly, pardon me, certainly not a first printer. I don't know, like, I recommended, it's hard for me to say, because, like, I used to say, you know, I used to be Prusa ride or die, but these, but, like, the Ender style printers have actually really come a long way. The Viper isn't quite ready for prime time yet, but I think in a couple firmware updates, it's going to be close. It has a, yeah. I mean, the Ender 3 is alright, but you have to do stuff like level the bed yourself, and the bed that it comes with isn't high quality. So, I'm not sure the Ender 3 is a perfect second printer. I'm not sure it's a good first printer. Yeah, the Prusa Mini, people really like the Prusa Mini. The Prusa Mini, by the way, is not a smaller version of the Prusa Mark III. They're completely different designs. They have a totally different heat path. It's pretty sick. B-Fingit says, Zach's problem is assuming any cubicle update past the review period. I mean, that's totally possible. I think their support for the Mega series has been alright. Creality also supports their printers. Creality supports their printers a lot. Creality makes the Ender series. They also make the 3D print mill, which is like, it doesn't have a plate, it has a treadmill. Barnaby Drive says, I overwrote the bootloader, so I need to flash a new one. How the hell did you do that one? If you have a lot of time on your hands, yes, the Ender, then Pile of Stuff makes an excellent point. If you're a tinkerer by nature, the Ender 3 V2 is a good value for the money. One of the Ender series has, the Ender 3 and the other Enders have a unique advantage among cheap printers in that so many people have them. There's tons of aftermarket parts and there's tons of printable upgrades. So, yeah. But again, that's why I recommend it's not your first printer, it's your second printer. As for first printer, I still got to give it to Prusa, but that, I think, has a lot to do with my ignorance of low-end printers. Yeah. It's Vanna says, I think the Ender 3D is a food first printer. I started with the Ender 3 Pro, which took a lot of extra learning to get started with, and the V2 fixes that. That's interesting. I feel like I should just like go to Micro Center one day and just like grab an Ender 3, because they're only like $150 or something. I feel like I should just grab one and be like,
just do like a YouTube short being like, I got an Ender 3, it aight, or this sucks, or it's kind of good, and then like just I don't know, give it to I don't know who normally they'd say give it to a school, but I don't think they'd use it. I don't know, give it to some kid who could use it. Yeah. Juan Rodriguez says, I have a CR6E, happy with it. Viper similar to the CR6. Yeah, the Viper has some interesting features to it. It looks exactly like an Ender, but it uses a volcano hot end, which is pretty cool. I don't know why they don't promote that more. Like, they're more promoting stuff like the touchscreen and the auto leveling, which, alright, they're fine, but like, it's got a volcano nozzle in it. Like it's got, I think it's a 30-watt heater cartridge. Like, out of the box, it can print 20% faster than my Prusa. Yeah. But yeah, I don't know. I still give Prusa the W, but the math is changing every day. One says, I didn't know the Volcano had a Viper, or the Viper had a Volcano, I saw the stream. I didn't know either. Like, I noticed that the nozzles are very long, but I didn't know why they did that. I figured it was just some weird proprietary lock-in stuff. And then I built this printer here, and I put a Volcano on one of the extruders. I'm like, wait a second, I've seen this nozzle before. So I took the Viper and I cracked off I took the Viper, I cracked off the shroud, and sure enough, it's got the vertical block. It's pretty sick. Keeper says, did the PEEK ever work out? Judge for yourself. That's what we're printing. Yeah. It's somehow working. Yeah, let's do takeout. Yeah, let's do takeout, Brooke. Let's be butts. That's what we call it. We call it being butts when we get delivery. Yeah, let's get some delivery. Let's get some smothered burritos. Let's get some smothered burritos. Let's use that to explain to the rest of the world what a green chili smothered burrito is. Green chili. All right. Oh man, the green chili. So green, yeah. So here in Denver, you can get what's called green chili, and green chili is a pork stew made with hatch chilies, and you can get a smothered burrito, which is a burrito smothered in green chili. Just pour this green chili on it. This green chili is unlike anything you can get anywhere outside of Colorado and New Mexico. We've tried too. It's not salsa verde, right? It's not. It's not like they're not like jalapeno. It's not like jalapenos. Like their hatch chilies are very flavorful and they're not very spicy. So yeah, smothered burrito. It's like a regional thing, and I do not understand why this hasn't gone national. They are so delicious. Like with the green chili, like the hatch chilies. We never really found good. We never really found a good place to get hatch chilies in New York. The closest thing was Anaheim peppers, which have a similar flavor but are much spicier. Caitlin McCall says New Mexico green chili is better than Colorado. They're both good. New Mexico green chili is similar, but it's spicier and it's more intensely flavored. I think we had that when we took a road trip. The first time I was in Denver, we took a road trip down to Brooke can tell you the exact town, but basically in New Mexico, we did an Airbnb. It was great, and we had some green chili near Albuquerque, I think, and it was delicious. It was much better on its own. You can't eat green chili on its own. You don't eat it with a spoon. It's a topping. I feel like a New Mexico green chili would overwhelm the flavor of a burrito. But yeah, both of them should be much better known. But yeah, let's get one of those for dinner. Caitlin McCall says, I lived in Colorado my whole life, but visit New Mexico. We haven't gone down yet, but we really should. It's a lot of fun to drive down to New Mexico because it's just like straight ass roads through like deserts and crazy rock formations, tumbleweeds, bizarre looking plants. It's crazy. Caveman Dan Wilder says, Zach, how much have you played with the filaments that are meant to go into a kiln after printing? So this is the the wax filament that we're printing this other Benchy out of is one of those. It's designed for investment casting. The other one is called Ultrafuse. And Ultrafuse is one of the few filaments. Oh, Kalen McCall says in New Mexico you can get it on burgers. Oh, green chili burger would be the best. I would love a green chili burger. Yeah. Anyways, there's material called Ultrafuse, which I'm not going to get for this episode because yes, it has to be fired in a kiln. It has to be fired in a metallurgy kiln. Or like metalwork, I forget the term for it. Basically, a really, really hot kiln because it's got like stainless steel particles. It needs to be fired at like 5,000 Celsius or something insane. I don't know if it's that hot, but it's really hot. It's kind of what I'm saying. Yeah, it has to be fired at crazy hot temperature. The filament is bananas expensive. Like a 250 gram sample is like $500, and finally, the filament itself is, from what I've heard, the most brittle filament around. And this printer here doesn't have a runout sensor. Yeah, so it's going to break. Basically, it would cause non-stop problems. We'd spend more on that one filament that we have for everything else I bought for this episode, and we'd have to send away to have it fired for us, and it has a high chance of getting damaged in transit. Yeah. So no, we're not going to be. We're not going to be using most of those. I keep seeing the extruder on this, like, go far off the side of the print, and like, oh no, it's skipped, everything is ruined. But I keep forgetting the nozzle is on the extreme right side of the printer, or of the extruder. It's very unnerving. I can't believe Benchy is still working. What the hell? What the hell is this thing is still going? I expected that, like, it would split by now and we would have killed the stream. But yeah. Damn. Oh, jeez. Dangerous Dynamo 217 says, "Hey Zash, this is my first year streams. I want to see you make another Nerf blaster." Oh man, it's been a while since I did a Nerf blaster. I don't have any blasters planned for the foreseeable future, but we'll definitely print some more. We're definitely going to bring it back to the channel, but not quite yet. Not quite yet. Oh man, this is so exciting! Ah! This is so exciting! Crow says PEEK Nerf blaster. You know, that it's not a bad idea. Like, there are elements of Nerf blasters like the plunger, the sear, basically parts that the rear component of the receiver that just take a tremendous amount of punishment, and those would be perfect to print in PEEK, or even like a material like PEI that's even more impact resistant. That would be bananas. Yeah, it's crazy. Vector Finesse, hey, welcome to the stream. Vector makes these really cool semi 3D printed headphones. Basically, like, you buy a parts kit, and you buy a parts kit from them, and you print all the parts yourself, so you make, like, custom headphones in, like, whatever colors and materials you want. It's pretty sick. Thank you so much for the super chat. They ask, do you have a favorite filament of all time yet? Oh man, I was talking about this on Discord yesterday. It's really hard because different filaments are used for different purposes. But on the whole, I would say that my favorite filament has to be carbon fiber PETG, because it just, you can like 99% of things you can print in carbon fiber PETG, and it's going to be the best. It's going to, like, work out perfectly. Like, awesome surface quality, awesome printability, great strength, decent temperature resistance. It's fairly easy to print. It's not terribly expensive. I think it's all around my favorite. Yeah, I mean, I have some filaments that I really like. I'm not sure I'd call them my favorite. The more I use Tolman tea glaze, the more I like it. You just make gorgeous looking prints. Some of this is printed in tea glaze. Some of this guy right here. Carbon fiber nylon is also really cool. It's got this it's really nice. It's very easy to work after you print with it. So, like, it's like super easy to, like, file, drill, and just clean up in general. It's a real pleasure to work with.
So, yeah. Yeah, there are a lot of interesting filaments. Let's see, Prusa, like, there are all kinds of good ones. Prusament, like, their Galaxy Black film. That was my my speaker's opening. They have apertures on them. Prusa's Galaxy Black filament is just gorgeous. Oh man, everything pretty much everything Protopasta makes is. I mean, it's a pain in the butt to print, but it all comes out looking great because they just put so much. Oh my god, they just put so much pigment and glitter and additives. Like, Protopasta just put so much crap in their filaments that's super brittle, but they come out looking awesome. Yeah. Caitlin McCall says, how would carbon fiber nylon do with a drone frame? It's actually a very interesting question. I don't think it's the right material because I don't think it's the right material because it's semi-flexible, and that's not what you want with a drone frame. So I think instead, if you wanted that combination of, I gotta babysit the wax. Oh no! We're getting way jangled and tangled because we're at the wrong angle. It's gonna get mangled. Oh, I gotta wrangle. Oh, jeez. Oh, this is such a mess. Damn you, Kai Parthy, why couldn't you why do you have to spool your filament so friggin' big? Their sample spools are, the sample reels, the diameter of these things are stupid. They're huge. Let's see, let's hope that works. Yeah, anyways, I don't think, I'm not supposed to close this door. I don't think carbon fiber nylon is what you want. I think what you want is either, carbon fiber polycarbonate, perhaps, but I think you could make a strong case for carbon fiber PLA, just because it is the stiffest of the materials. And carbon fiber PLA has become so much cheaper now that even if you crash it and smash it, like, you can just print a whole bunch of spare parts. So, I don't know, I think carbon fiber PLA is probably your best choice because of its sheer stiffness. Yeah. Could be pretty interesting. Yeah, I still mean to do some drone flying. I wanted to do that earlier, but just circumstances haven't played out. This video here is taking a lot of time. I have another one coming up with some machine learning. That's going to take a lot of time. A lot of folks are asking about the upside down printer. I've seen upside down printers before, but what makes this one special? Like, why did some prominent YouTuber talk about it? So I don't know. Marvin Huth makes a good point. Drone stuff gets hot. Will PLA hold up? It's actually an interesting question. I don't actually know. This is where my inexperience comes in. Because on one hand, I'd feel like, yeah, like these motors are very powerful. The drivers get hot. On the other hand, like, these are outrunner motors, right? So the stator, they have like a big spinning chunk of metal, right? And it's not just a big spinning chunk of metal. It's a big spinning chunk of metal with fans on it. So I'd imagine that, like, it's cooling itself off a lot as it flies. But I don't know. I don't know. I think Botgrinder is definitely the one to ask. Yeah, Botgrinder FPV is definitely the one to ask. Yeah. Maybe it's pretty interesting though. Gotta stay hydrated. If any folks have been watching the whole time, you haven't had any water. Now's an excellent time. Join the Hydro homies. Set Top Fox says, why is there not a way to 3D print PCBs yet? There are a lot of reasons why you can't 3D print PCBs, and I don't think any of them are going away. I mean, that said, I could 3D print some very simple circuit boards using this machine. I just load in some conductive PLA in one of the extruders. I load in literally anything else in any of the other extruders, and yeah, maybe I can just get away with printing a multi-level board. That'd be pretty neat. I can't believe nothing's gone wrong yet.
like this is. I'm gonna go and I'm gonna like snap this thing off the plate and then wake up in my bed and it'll be 5 minutes till I have to start the stream. Like nothing's happened. It hasn't even. I haven't even tied the filament in a knot. What the hell? Unless, I mean, what do you think? Are we gonna make it almost to the top and the smokestack is gonna fail and like the printer will catch fire or something? There are some interesting ways to make boards. I gotta get in touch with someone from Bantam. I think of all the in-house circuit board manufacturing techniques, milling it is definitely the way to go. Milling it is 100% the way to go. And yeah, I've been meaning to get in touch with Bantam Tools that makes a pretty high quality desk. It's basically a CNC mill approximately the size of a 3D printer, even a little smaller, and mills circuit boards. So yeah, that would be pretty interesting. The conductive PL... Emilio Esposito says, really interested in conductive PLA for boards. If the resistance is good, that would be amazing. It's not. The resistance is, it's like, I think if you were to print a trace, I think if you were to like the filament itself, I think is about 1K resistance for 25 millimeters, maybe, something of the sort. One says, Zach, when you're done with PEEK, remember to purge the nozzle. If it stays there, it might get clogged. That is an excellent point. We need to figure out what the hell I can use to get the PEEK out of there. PEEK purge filament. I have no idea. Like, I don't know if I can just run purge filament through there because it might burn. Purging and cleaning filament? How do I... Oh, this is a filament maker. Oh, man. How do I purge it? Oh, that's really interesting. We got some information about plastics. Yes, I've seen a lot of information about injection molding, but nothing about 3D printing. I'm imagining that people never... I'm imagining that folks just always use the same nozzle to print exclusively high temperature materials. I guess we could... we could try... I don't think cold pulling it would... Calibrate is recommending cold pulling it at 200 Celsius or using nylon. Well, is nylon stable at 400 Celsius? Or at 360 or something? Nylon temperature. Let's see. Everything you need to know about nylon. Let's see. Nylon 6. Well, that could be interesting. Material, what temperature can nylon handle? Can't be exposed to extremely high temperatures. Yada yada yada. That's not what I want. Nylon burn temperature. Let's see. It says like this site here is saying that nylon ignites around some nylons ignite around 424 Celsius. Polycarbonate could actually work. That could be pretty interesting. Maybe we could use Prusa polycarbonate blend, because I know that stuff is stable up to at least 300, and you can print it as low as I think 220. So I think we might be able to use Prusa polycarbonate blend as an intermediary. So I think that's the way to go. Yeah. Anyways, definitely don't want to be burning nylon. I agree with you, Ted. Yeah. Oh, that's why everyone's talking about 3D printing metal. Because Integza released a video about 3D printing metal at home today. Connect with them about the topic. I could take a look. The 3D filament video, we're strictly doing filaments. We gotta stay focused because there's only so much to do. I think the way to go is to use polycarbonate. I think PC is the way to go. Let's take a look here. Prusa PC blend, because I think it has a really, really wide temperature range. If I'm remembering this right, yeah, because it prints at 275.
but I think you can run it at a much lower temperature. Technical data sheet, let's see. Nozzle temperature is 275. Heat deflection temperature. I might be wrong here. Yeah. 'Cause I thought it said I thought a lower temperature printed on the reel. Ah. Oh, the wax boat is printing. It's happening. Oh my god, it's happening. Alright, so here we got Jet Black PC Blend. And it says, oh no, it says 275. Alright, there we go. We could use, yeah, I guess it is 275. Alright, never mind. Yeah, this is it's a really high temperature. I don't even know what is purge filament? Like, I don't even know what it's made of. Is it polypropylene? Or is it because I know some purge filaments are like this special polymer used to clean injection molds, but I don't think the one that I have, like the one that I'm using here, I don't think that's it because it was really cheap. I think it could be like nylon or something. Cleaning filament. I don't know. Maybe there's like a special high temperature cleaning filament. That could be pretty interesting. Cleaning high temp filaments out of a nozzle. Cleaning filaments. This is the one I have. It's made by eSun. Professional grade. Well, I definitely trust that. Pure material. I mean, it says you can use it for polycarbonate, but I've seen products sold on Amazon that claim a lot of things. Let's see. PETG, PLA. Yeah, I mean, I wish it had information about it. Cleaning filament. Do I see anything here? I don't know. Yeah, I don't even think they know what temperature the stuff burns at. Let's see, PLA burning, yada yada. Let's. I think we might just be able to use standard cleaning filament. It says all right. It says wide cleaning range up to 260 Celsius. So yeah, we're not this. Yeah, I think we just have to leave the PEEK in there, and that's just life now. Sylvia says purge filament is 100% nylon. I wonder if nylon's the way to go. I wonder if nylon is the way to go. I think so. Yeah, I think that's what we'll use. Yeah, maybe like Tolman Bridge. Oh, that's why Tolman 230 is called Tolman 230. I just realized, because it prints at 230 Celsius. The reason I'm looking at Tolman Bridge is because I know it prints at a low temperature, but it might be able to tolerate higher ones. Prints at 250, melts at 217. But it burns at 360, so no dice. No dice. Oh man. Yeah, this is tricky. I don't think we have a lot of time left to figure this out either. We're done with the boat part. We're moving on. Like, we're almost done with the prow. We're moving on to the bridge. That's I think polycarbonate's the way to go. Because even if it burns, I don't think it degrades into very nasty stuff. Yeah. I don't have pure polycarbonate. I have Prussia's blend. Let's see. Prusia PC blend pyrolysis. No. How about burn? Burn! You may get burned if you touch it. Yes, I know. It's 300 Celsius. Oh, it can scar you. It can cook your flesh. Oh, that commenter. That the person on this Prusia forum is really intense. Man. Brown plastic teardrops drooped onto my print. Huh. It's pretty interesting. Characteristic and processing behavior of heated polycarbonate. Oh boy. Heated. Oh no. No, this is aluminum polycarbonate composite build plates for the FDM manufacturing process. That's not what we want. You. Pardon me. You know that your question's esoteric when your search results start to be scholarly papers. Yeah, I think we're just gonna run Prushiment PC blend through it and see what happens. We could try, like, the thing I'm worried about is Sylvia points out that nylon decomposes at 400. Yes, pure nylon. Pure nylon breaks down at 400, but also when nylon breaks down, it releases some really nasty stuff. So, yeah, I'm worried about what else would be mixed in with the nylon. And yeah, what about alloy 910? Maybe that would work. I think that's what it's called an alloy 910. Yeah, because this stuff prints at a very high temperature compared to this stuff can print. I think it can print at a high temperature compared to standard nylon. 95 degrees Celsius working range. You can print it at 245 Celsius. This, Is that what I want? Is this what we want? I don't know. No particulates, nothing like that. Specs. Tech G, Evolve 3D. Some of these are really crazy sounding filaments. I got some of their PCTB. I'm super excited to print with that. That filament is exactly what it sounds like. It's polycarbonate mixed with TPE mixed with, basically it's polycarbonate mixed with flexible filament. So it should be pretty sick. Ted Milker says, any glass infused filaments on hand? I actually do have a number of them. This one doesn't have a temperature. This one doesn't have a stats table, and it's kind of cheesing me out a little bit. Oh, there we go. Perel says 350 Celsius, no dice. Damn, what the hell am I going to use to get this stuff out of the... Like, will the PEEK melt at all at a lower temperature? I have no idea. Oh, man. From Brooke says Nightbot, our new YouTube bot, is so sassy. I think all the quotes are from Duke Nukem. I think they're all from various Duke Nukem games. Yeah, what kind of... So these are all nylon plins. Do I even have a pure nylon? Let me get in there and take a look. Wait a second. I certainly do. I actually was drawing it out because I thought we'd do some printing with it. Yeah, it's fishy filaments. This might be our boy. I have some fishy filament, which is made from recycled nylon fishing nets. Check this out. Here, I'm gonna take a look. Fishy filament, 100% recycled marine nylon. So maybe this could handle the heat. Yeah, let's take a look. Let's take a look. It's got let's see. Let's dry it. Yada yada yada. Printing temperature up to 270. All right, that's pretty spicy. Does it doesn't say how? Let's see. Doesn't say what temperature it burns at. But I'm thinking this is our best bet because this is nylon 6, which is a pretty robust material. Let's see. Or not strength. We want pyrolysis. Let's see. Polyamide. yada yada. I don't want to look through an entire friggin' research paper to find the one piece of data I'm looking for. I'm very lazy. Ah, damn it. Let's see. Temperature rating, is that it? Heat deflection temperature is 200. Melting point, oh, this is Fahrenheit. Get that Fahrenheit out of here. I think this is about what we want. I'm guessing that it's probably going to be fairly close to this, because, like, you know, the fishing, like, these nets are disposable items. Esoteric questions. I know. How hard is it to find out what temperature things... Why is it so hard to find out what temperature things burn at? Flammability. 26% oxygen. Let's all hold our breath. I think this is our best bet. I think we'll just run some regular ass nylon, or we'll just run some fishy filament through here. There we go. It makes sense, right? Like, after we're done printing boats, we can run some filament through made with recycled nets. Yeah, be pretty neat. Oh man, I wish Sanjay from E3D was here. That guy knows everything about polymers. Oh man. Blade Matlock says glass transition of PEEK is 343, so we just need to get to that 350 range to purge. Yeah, I think we'll try 375. I think we'll try the coldest temperature they recommend, because we don't want any residue. We don't want any flecks coming off and, you know, flaking off and ruining our ruining future prints. So yeah, we'll run some fishy filament through there. Pardonnez-moi. Yeah, this is turning out to be our longest stream. There should be about 15 or 20 minutes left. Let's take a look here. 60% done. About half an hour. Yeah, we got about half an hour left. So the stream is going to be a bit longer than usual, but this is a friggin' historic occasion here. This is crazy. Like, yeah. Oh, take a look through our other camera. Yeah. Here we go. You can almost see it, but let's move this over a little bit. Maybe get a better angle here, because that wax boat is almost done. Check that out. You can barely see it there. God, gotta get a better way to get a freaking camera in here. Look at that. Look at it. It's a wax boat. I don't think we can cast it because there's too many undercuts, but I think if we do end up wanting to actually use it, or you do want to actually cast with the mold lay, I think I'll just modify it to make it castable, and that could be pretty neat. Jay Sean 04 says Devo Clean Purge claims 180 to 420. 420, haha. I don't know what that is. Let's see. Devo Clean Purge. 3D Evo. This is these are pellets. This is a filament maker. It's a filament extruder. It could be pretty interesting. Oh, it's got abrasives in it. That's neat. Scrape out the inside. It's pretty cool. Here, take a look. Yeah, it's made for a filament extruder. So you can make your own filament, and then when you switch from one material to another, you can just run some of this through, and it scrapes all the crud off. It's pretty neat. Pretty neat. Look at that Benchy. What happened? Like, here's my guess. The thing is going to come out pretty good. I'm going to go to pull it off the bed, and one of two things is going to happen. Either the layers, like, peel apart like a book in my hand, or it'll take a chunk of the plate with it. Any other suggestions, or we want to place any bets? Actually, I think I can do a poll. Hang on a second. I think I can do a poll with this. Let me look up how to do that, because I'm gonna abuse this like a lot. How do we do this? Logs, regulars. Oh, recognizes people. It recognizes our regulars. Isn't that neat? Commands, poll. There we go. So how does this work? Where are options? Poll new, title. Alright, let's do this. Let's see. Poll new. What's gonna happen? How is this print going to go wrong? Let's see. Clog. Delamination. Destroy plate. Nothing. Let's see. I gotta test out the bot too. Come on, bot, do something. Oh, it makes a straw pull. That's pretty cute. Like when it said make a straw pull, I didn't mean like it used. I didn't know it meant the site strawpull.com. Oh, that's pretty neat. Oh, that's pretty rad. I wonder if I reuse the same information, I wonder if it'll just send people back to the same straw poll. Let's see. I mean, we're in the home stretch here, and this actually looks like a pretty solid Benchy. The color is about what I'm expecting. From what I read, PEEK tends to like after. Even if everything is right, it tends to print a little bit lighter than it is on the spool. Tends to print a tiny bit lighter. So yeah, it tears a hole in the space-time continuum. Oh no! So like when you open it and like when you throw a bag of holding into a portable hole, wakes up. Willie V says, "Ad wake us up from the simulation." Oh God. Oh man, I know that if I like get hit by a bus and I wake up and it was a simulation all along, I'm just gonna grab the nearest person and say, I'm gonna say there is a VR game where you could play Duke Nukem in like hang on, I'm mixing up a whole bunch of things. Be like, in that simulation, you could play World of Warcraft. And you could play Bejeweled within World of Warcraft. That was a game within a game within a game. Damn. Ah, man. Like, if that happens, the thing I'd be most salty about is losing all my Magic the Gathering cards. Can't take him with you. I want to find a pharaoh and laugh at him. I'd be like, yeah, look at how much you prepared for this crap. That'd be pretty funny. Although I think I'd be fairly well adjusted if I woke up and it's a simulation. Yeah. Let's take a look at our straw poll. Let's take a look at our poll. I'm gonna post it back in for anyone who missed it. Question is, what's gonna go wrong with my print? Let's see. Nothing. Wow, folks are really giving almost half you people think that I am going to actually print this Benchy. The next most common, with 35%, is destroy the plate, followed by delamination at 14%, followed by clog. I am inclined to agree. I feel like if we were to clog, it would have happened already, although this is the part that tests the retraction. So I don't know, I think it's the most likely times to clog are either like a cradle death in the first few layers, or this part where it's retracting a lot. Destroying the plate is a possibility. Yeah, the real question here is, when do we remove the print? Because if we wait too long, it'll break the plate. But if we don't wait long enough, it might split apart. I'm thinking we should open this up and get this thing out of here as soon as the print is over. And I've got my palette knife right here. This is the exact tool you want. The exact one that you want for 3D printing. Look how thin that edge is. There's no chance that this thing is going to scrape. It's going to scrape it up. Plus, see, it's got a whole bunch of different angles on it that you can use to try to get up under the print. So this is the only palette knife I could recommend. You don't want one of the ones with the rounded edge. You want that point because you can use it to carefully pick up. You can use it to carefully pick up a bit of brim and like run it around. Anyways, we've got this at the ready. I hope the adhesive is like. I hope we can clean the adhesive off the plate. Yeah. Well, let's see. The buzzword glue is supposed to make it impossible. It says right there in the instructions you have to remove the print quickly. You have to remove the print while the plate is still hot, or it can crack. So, yeah, we'll see what's going on. I did use buzzword glue. Apparently, it's from my best research, it seems like the real deal. Every place that recommended a glue for high temperature printing always came back to that one particular brand. There are like special surfaces designed for printing PEEK and stuff, but that seems to be the only bed surface treatment that works well and doesn't put wear on the bed. Marvin Huth says, I read the instructions. I do. I read all the instructions. Burke can tell you. Yeah, I always read the instructions. It's really annoying. Gift Hammer Game says, all these fancy remover tools, who else just uses a hammer? That's what we used to use at the Fab Lab. We used to use a hammer at the Fat Cat Fab Lab. The reason I don't like to do that is because it's really annoying to keep pulling the plate off. It's just a pain in the ass to pull the plate off of the printer and put it back on over and over again. Also, I can't believe the liquid cooling system hasn't leaked. That's crazy. Yeah. Master Machetier asking the important questions. What is the actual use case for PEEK? High temperature engineering these high temperature engineering filaments actually have a lot of uses. The first is that they're very non-reactive. Remember, like, the thing that makes something burn is that it reacts with oxygen, and filaments, like materials that don't burn, that like burn at a high temperature, also tend to be non-reactive and inert. And PEEK is very inert. So anything that has to be exposed to acids or bases, anything like biocompatible stuff, this particular PEEK isn't appropriate, but you can. Another thing is things you need to be autoclaved. Like if you want to print things that you sterilize with high heat, remember that this melts at a far higher temperature than the boiling point of water. So you can actually steam clean things printed in this high temperature filament. Another thing is radiation hardening. That's not a factor for PEEK. That's more PEI, I think, or PEC. But yeah, they're also resistant to radiation, which I hope I never need to care about. But maybe I'll use that for the next Fallout Boy, or the next Fallout Pip Boy. What are some other things? The strength is exceptionally high. I know a company that prints suppressors in PEEK. I think they use PEC, actually. High UV as well. Set Top Vox brings up high UV instruments like UV filtration and sterilizing. Absolutely. Yep, it resists UV very, very well. And also, just environmental... It's just a very tough filament. But, yeah, the strength is astronomical. If this thing comes together, it'll either be super brittle, or I'll be able to run it over with the car repeatedly. There's a company that prints suppressors, like devices that contain explosions. Our wax benchy is coming to an end. Oh no, you've been looking at the same thing twice. What a doofus I am. Our wax benchy is finishing up. I'm amazed how easy this thing has been to set up on this. I really wish you could baby step it though. Yeah, can you like adjust the Z height from within Octoprint? Let's see, control. Yeah, I don't think you can. Maybe I should add some buttons to baby step from within it. Xneem says PEEK is also a lot easier to machine than to print. That's true. Oh hey, we're done. Check it out. Oh, I always mess that up. Check it out. We're done. We got a wax benchy. I'm gonna give that an extended time to cool off. Yeah, I'm gonna give that an extended time to cool off because I don't. Well, yeah. It prints only 170 Celsius, so it's probably still a little wibbly wobbly. Yeah, Brooke says, I had some hummus. Oh,
David Leal says, "Bruh, I bet your lady's starving." I thought, Brooke, I thought you were gonna order some smothered burritos. Wasn't that what we were ranting about? This is incredible. I can't believe this is still working. I guess this is where it could easily fail, because this is where the bridging happens. This is where the bridging comes in. Yeah, let's see. Panzer Apple Husky says, if the radiator isn't hot, pump might not be running. 3D printers are not that hot. Like, there's not that much heat coming off these things. What does it end up being? Like 20 watts or something? Like, it's like nothing. You barely even need the radiator at all. I just want to double check, make sure the filament's not tangling up. No, I think we're good. No, we're definitely getting some bridging. We're definitely getting some bridging going on there. That's pretty sick. Tolan Saunders, our newest Discord mod, asks, do you use any kind of version control or Git for G-code or other stuff while you write it? No, I'm just practicing my trapeze without a net here. I should really back them up. Yeah, 20 watts, Set Top Fox says 20 watts is borderline passive cooling territory. Yeah. This one is actually hotter. Like, I'm using a 60 watt cartridge. Okay, fine, like it's 60 watts, but still, like, the thermal mass of water is so ridiculously high. Let's touch it. Let's give it a feel. It's a little warm. It's a little warm. It's definitely circulating. Yeah. Oh yeah. Sherwin Darsu asks for a close-up of the Benchy when it's finished. Oh, 100%. 100%. If we pull this off, I'm not just giving you a close-up. Like, I am fitting the macro lens to this so we can take a look at this properly. This is cool. This is pretty sick. Man. I didn't expect us to actually, pull this off. Speaking of pulling this off, let's take a look at that wax Benchy. Huh. This is not the neatest? No, that's not what we want at all. There we go. Look at that. Look at that, it's a wax Benchy. It's made of castable, this is an investment cast / mold making Benchy. Isn't that sick? It's got bad pour overhang going on there, but otherwise, this is pretty solid Benchy. This is really sick. That's pretty nice. Beef Ingot asks, how much time is left on the Miracle print? 15 minutes. The slicer is estimating 15 minutes on the dot. Check that out. Look at that. Felix Parbury asks, Benchy candles. We are definitely in our video. We are definitely lighting this thing on fire. 100%. This thing is going to be lit on fire. I'm not going to do that now because then I have to print a second one. But damn, I bought way too much of this filament. I expected this to be much harder. I'm glad I bought samples this time. There, I'm glad I bought samples instead of whole reels. Because I believe it or not, I'm actually getting a little better at 3D printing through this whole experience. There we go. Give ourselves another angle to watch the carnage. That's working. That's working, folks. Robert Schlong asks, what's the chamber temperature on the PEEK? I think it's supposed to be right at 120, but this is definitely not that hot. This is definitely not that hot. If we tried to... I think they overspecify this a lot on their website because most of the stuff people are printing out of PEEK is larger, like gears, mechanical parts, cams, vehicle parts, prosthetics. I don't know, but yeah. Oh man, it's working! I can't believe it's freaking working. It's bananas. That's bananas. That's bananas!
Robert Schlong asks, what is on that printer right now? This is polyether ether ketone, a high-temperature filament that prints almost 400 Celsius. Printing on a liquid-cooled Titan Aqua extruder. This is rad. By the way, this would be really hard to print without liquid cooling setup. This is one of those few circumstances where liquid cooling is not optional. I think you can do it with air cooling, but the liquid cooling makes this. I think that's why we're having such success, is because the air inside there, except for updrafts coming off the plate, is completely still. There is nothing going on there that could disturb the air. So yeah, I think that could be pretty sick. H4 says seal your enclosure and get a heater to get above 75. I agree. I actually bought, or I didn't buy. I have a dehumidifier that I'm going to put, that I thought I would have to put in there to keep things dry and also to add more heat. But I'm not sure it's going to be necessary. We'll give it a shot. But I'm amazed this thing worked in the first shot. I've literally never. This is literally the first time we've run any filament at all through the Titan Aqua. So, yeah. Jack Frost says Peltier. I don't think it would be a good idea. Peltier plate is an electronic. It's an electronic component that drags heat from one side to the other. It doesn't break the law of thermodynamics. It's not a Maxwell's demon. Basically, it works like making it easier for heat to travel in one direction than the other. Anyways, you can use them. They're not a cooler. They're a thermal interface. It's not your sole way of cooling something, because eventually it itself will get saturated with heat. The reason you use a Peltier plate is because it moves heat faster than heat can move on its own. And the problem with that is that unless you have a powerful cooling system on the other side, it's guaranteed to saturate itself with heat. Because you can't get heat off of it faster than you can get heat onto it. So, yeah, eventually it gets saturated. Zoster, thank you so much for the super chat. You have to run that over with your car for the video. Oh, you bet I will. We are going to destroy stuff for this. Like, we're going to be smashing stuff with hammers. We're going to be running stuff over their car. Maybe we'll even blow something up. Yeah. Yeah, on top of that, the Peltier plate is super inefficient because not only do you have to get rid of the heat that you're carrying over, but you have to get rid of the heat from the Peltier plate, which is super duper inefficient. Tons of heat. So generally when you use Peltier plates in a real life application, you're usually stacking a bunch of them up to make sure that heat can't make its way, like heat can never saturate all the way back. So yeah, there's that. Set Top Vox asks an awesome question that I'm super excited to answer. Are there any filaments that are optically internally reflective, like fiber optics? Not quite, but I do have two really sick filaments. One of them is retroreflective, right? It's got little bits of the same, it's got little flakes of the same stuff they put in like street markings and road signs, so that no matter where your headlight's pointing at them, they're always bright. And I have another that's PETG, that's optically clear PETG with fiberglass in it. So it's like an extra clear PET. It's really cool. Yeah, it's pretty sick. It's pretty cool. Oh man, yeah, we have to. I gotta tune the settings for the bot because I think it's being a little. I think the auto modding is being a little too aggressive. Yeah. Oh, we got another cool question here. Where is it? I think I can't see where is it? Yeah. Somebody, sorry I missed it, asked, can we see your filament storage room? Because I bet it's full of filaments. You have no idea. There's so many friggin' filaments in there. It's got well over 100 filaments. Yeah. So, yes, that's actually the next episode. I realized that I do 3D printing all the time. I have tons of episodes with 3D printing. In fact, most of my episodes involve 3D printing. Most of the streams involve 3D printing. I've never talked about my printers. I never talk about my equipment. So I decided to make the next episode sort of like a workshop tour, but specifically on 3D printers. So I'm going to show you all of our printers, all the modifications I made to them, all the improvements I made to them. We're going to take a look at how I store all my filaments, take a look at all the extra tools that I use to clean up and work with printing. So it's basically like all of our stuff. Cooper G says, Zach, when's the next episode likely to be uploaded? Probably a week, probably 2 weeks. Probably 2 weeks. The way we're scheduling this is really weird because just the sheer volume of work that has to go into the every filament episode, we're probably going to end up. You're going to wait for 2 weeks. We're gonna do the video about our 3D printing stuff, and then follow that up the next week, probably with the every filament episode. So yeah, that's probably going to be what's what. So that also means the next few streams are going to be very interesting. Because basically the number one thing we're going to be doing for the next few streams is printing boats. So I have lined up a ton of really cool activities that we can use to pass the time, and make it fun to watch us print things. Like a lot of folks enjoyed when Renee came and we chatted while we hacked on the thing. So we're bringing in at least one other guest. We're bringing in some guests, and we're going to like hang out and chill while we print boats. We have some pretty interesting hardware. There's some pretty neat hardware to take a look at. I don't want to spoil too much, but there's a reason I had to rearrange the room, and we even have like some we might even spend a day like gaming or doing like a hardware related, like a hardware puzzle, or even a little reverse engineering. Basically for the next few weeks we're going to be just doing nothing but printing boats, and it's going to be a blast. Because it's super chill. I've been busting my butt doing all this crazy engineering to get this thing working, all that. And all we have to do now is just run 2-hour prints. Like, we just have, at least 130 hours of printing ahead of us. It's great. So excited. Cohen Carnell says, bring on an actual sailor. I don't get it. Oh, for the boats! I'm dumb. What can you do with a drunken sailor? What can you do? Yeah, but unfortunately, Benchies are too top heavy. They don't float. It's a real mess. It's a real mess. Michael Wayne Yoiki shouldn't spam the same message over and over again. I disabled that for testing, and I forgot to re-enable it. So you dodged a bullet there. Michael asks, can you make a smart glass like your Optigon? I just love it. The Optigon, for the foreseeable future, no. There just aren't the right materials. There's aren't the right materials available. It's just, in this, it's a way of saying it. When I initially promised to make a follow-up to that video, and I made that promise to the patrons, it was right at the beginning of the pandemic, and it wasn't clear that there was going to be like a crazy recession, a lot of class conflict and stuff, but at least for now, it would just be kind of gross in this, in this situation, knowing what a lot of our community is going through, to make a project with a $900 component in it. So, I just think it would be kind of gauche. Yeah. Unfortunately, so Michael says nothing fancy is cheap and affordable. Unfortunately, there is no compromise. I don't think a heads-up display that is... Basically, I only think a heads-up display that's transparent is worth building. And as of now, the only optics that allow that to happen in a decent way, they have to be salvaged from an expensive consumer product. So, at least for now, I've been keeping an eye on some other solutions, like a viewfinder module with a beam splitting mirror, but I'm just not satisfied with the performance. So at least for now, it can't be done. On top of that, like the price that, on top of all of that, like remember the price that, if I'm suggesting that anyone's going to build a project, I really want to keep the cost not much higher than $100, and that's straight up not possible for a wearable computer, because even if you get the display, right, and I don't know, like these viewfinder modules are $50. You're gonna need a driver, you need some circuits, right? You need glasses and stuff, and you're gonna need a computer, and the computer is gonna, and like already you're breaking the bank. So like, you know, Raspberry Pi 4, it's like another $80 or something. So already we have a nearly $200 project. At least for now, it's just not a, I don't know, it's just not a project that I think is a nice thing to build. I think it's going to make a lot of people feel left out. Yeah, but I suspect things will change. One thing that I'm going to take a look at is project. I think it's called North Star. Basically, it's an augmented reality headset that uses sort of like one of the standard displays from like a cell phone, and these specially made curved mirrors. It's basically like having two reflex sights on your head, and that can, I think, it's not cheap, but it's not terribly expensive, and it is a fully open source project. So going to be getting some hardware in for that at some point, and we're going to give that a shot. I think that if it's not going to be a new Optigon, but I think it will scratch the itch for wearable computers that I think a lot of folks have. As I showed in my last episode, Cooper G says you can make a heads-up display for $200, but it's not going to be high quality. As I hopefully proved in my last episode, you can make a heads-up display for like $50. It's not going to be very good though. Beefing it says, I think most people watch for entertainment. They won't get bothered too much. I know, but like at the end of the day, like it's a hacker show. It's a hacker show first, and I got to be true to that crowd. Look at that friggin' smokestack. It's looking like a bit of a blob. The smokestack's a total disaster, but I think that was kind of inevitable. Without any sort of active cooling, the smokestack. The only way we could possibly do that is to just like edit the G code or something to make it leave, make it move off to the side and wait for the filament to solidify. Yeah, so our smokestack is going to look disastrous, but with no active cooling, I don't think that's feasible to avoid. But yeah, we can. I think we can account for that. Austin Allen says, "Crank the fan up." I can't. Fans on the only fan. The fan for this extruder is on the outside of the enclosure. Yeah, so that's why we use a liquid cooled printer. It's pretty sick. Alejandro Gutierrez says, "Have you seen the Android smart glasses on AliExpress? They appear to be Google Glass clones." Yeah, there are some knockoffs. They're not great. The screen, like the optics, are very chunky given the screen size. Yeah, they're kind of sus. I should order a couple pairs though. I haven't seen any in person in probably not 10 years, maybe like 8. Yeah. Anyways, yeah, I know they're bad because I know the guy who did Project North Star. His name is Noah Zirkin. He's the guy who got the first picture of Google Glass, which I think was under suspicious circumstances. Oh, that's it! Holy crap! It even dropped the tool. Look at that. Ladies, gentlemen, and cyborgs, we've done it. We've made a high temperature print. Let's switch over to our alternate angle so we can rescue this thing and let this heat out. Oh my god, it's so hot in here. Holy crap. That's a scary sound. That's it. This is... I'm hearing a sizzling sound. let's oh, there we go. I'm hearing a sizzling sound. I hope that's nothing valuable. All right. Check it out. So it is a little on the blobby side. So I'm hearing some sizzling sounds. Hopefully nothing's melted. Let me stop filming. Yeah, hopefully the liquid cooling system isn't like damaged or anything like that. Now, that would suck if it melted down or something. No, I think the sizzling sound I'm hearing is like water inside the filament boiling off. Huh, it's pretty sick. Yeah, we'll purge it in a sec. Yeah, that's definitely what's happening. Water in the filament's boiling off. Now that the heat is capable of, now that the heat's making its way back up the heat break, because filament's not moving anymore. It's exposing filament. So it's a little on the blobby side. Wait, I promised to do this right. Let's take off the zoom lens and go over here and grab our macro lens, because let's give everyone a good look at this. Snap in macro lens. That sizzling sound is really scary. All right. Can we bring this in even closer? Oh, our power cable's all messed up. There it is. That's our boy. Check it out. This is, I mean, it's blobby. You can see like the weird extrusion here, probably caused by filament cooking off as it retracted. But yeah. So yeah, on the whole, this is not a horrible looking Benchy, especially given the filament's probably like a total mess. Focus. There we go. So obviously smokestack is terrible. There's no active cooling, and we didn't slow it down, or we didn't force a long layer. Yeah, we didn't enforce a long layer time. So it's yeah. So that was kind of inevitable. Let's see. Let's check underneath. Can we get a good shot? So yeah, bridging is terrible. Yeah, you can see here in the front as well. Yeah, bridging is bad. But we kind of knew that. There are special high temperature support filaments which we might be able to use. It's pretty sick though. It's pretty nice. The overhang performance is great. Look at that. Look at the prow. Yeah, that's great. It's pretty sick. Like this is PEEK Benchy. Unfortunately, layer adhesion is a mess because of all the moisture. So sadly, this one can't be. We can't run over with a car. Yeah, I'm still hearing water boil off in there. So yeah, the filament's totally waterlogged, and the layer adhesion is crap. So it's not very strong. I can break it apart with my hands, but. Look, we still printed something at 390 Celsius. Like, the system itself worked. Yeah. So, not a total victory, but also not a failure either. So that's pretty cool. Yeah, we did some high temperature. We printed some high temperature filaments. I guess while we're here, I might as well show you the castable wax Benchy. Look at that! Look at that finish. Isn't that weird? Yeah. So this is this can be used for investment casting or for mold making. So sadly, this isn't as strong as it should have been, but I think once we get this material dehydrated properly, this is going to be a real spectacle. It's going to be really cool. In the meantime, I think our show is coming to an end. So yeah, in the meantime, I think our show is coming to an end, and if anyone has any last things to say, I think now is an excellent time to do so. The next episode on Monday is going to be a bit similar to this one, except remember, the difference is we're not going to be fighting with our printer very much, because at this point the printer is basically locked in. We've proven that we can print high temperature stuff. We've done actually a really good multi-material print. Let me where did I put it? I've been fiddling with it over here all day. Where is it? I throw it on the floor. Anyways, we did a really solid multi-material print. Oh, here it is. Check this out. Look at that. Oh, that boat's not doing too hot. So yeah, look, like this. We need to work on our Z. All of our extruders are over extruding. I have to calibrate our E steps. But apart from that, we're ready to go. This printer should be about ready to run basically anything. Whether it's support filaments, dissolving filaments, exotic composites, high temperature engineering stuff, even filaments designed to be printed super fast. It is still a Core XY printer. So at this point, we can basically grab anything off the shelf and chuck it in there. Which is pretty sick. And we also have 3 other printers that we can have running in the background so that we can do more boats. Yeah. So some folks were asking about the 3D printing setup, or filament storage setup, and I'm wondering how far I can carry this camera around. I don't think it's gonna work out very well, but yeah, we have. So yeah, our setting. Oh no! Oh my! So yeah, Voidstar Lab has been upgraded with all kinds of with a whole new printing area. We're going to throw this box fan in this window so that we can get some resin printers on here. We're not doing resin for the next every filament episode, but I have a rather interesting resin related item, actually 3 of them to show off, so that's going to be quite exciting. Looks like our temperature is dropped below boiling, so yeah. After the stream is done, we'll heat that up. I'll run some fishy filament nylon through, and we'll make it happen. So, in the meantime, this has been a real fun. It's been a real fun one. If you're not subscribed, definitely subscribe. If you're interested in supporting the channel over the longer term, helping us do projects and stuff, the best way to do so is go to patreon.com/Zack Freedman. Let's take a quick look and see if anyone became a patron during the stream. Connor, thank you so much. Let's see. Oh, there we go. Connor, thank you so much for becoming our newest patron. Yeah, you folks rule. Join our Discord. Let's thank thank some supporters here. So yeah, Voidstar Lab would be Voidstar nothing without our awesome patron supporters. So yeah, super special thanks to our collaborators, our highest tier. Oh hey, there's one right there. Jeremy Arnold, Schweddy Vag, Chuck Fadouk Small Dong, Command or CMD, and of course, I'm Not Betacor. And I realized I probably should have pulled together a list of our patrons before the stream started, because I just lost all of my momentum. But anyways, thank you so much to everyone who supports the stream. Thanks to everyone who joined the stream. Yeah, I do these things because it's fun and it's fun to watch. And I hope all of you had an excellent time, and I will see all of you in the future. And I forgot to pull up the window that has the end stream button, and there we go.